Hey guys, this is Rob. So I've had a lot of requests to show start to finish an electrical Revit project. So I've decided to do a residential scale project, but design it as a commercial project. So what I mean is it will be a small square footage and only 2 levels, but we will draw it and circuit it and detail it as if it's a commercial level of detail. So kind of a hybrid project, but it should show a lot of the techniques used in commercial work, and you can apply it to residential work as well. I'm going to be using as much of the out-of-the-box templates and families as I can so that you can follow along without needing a bunch of custom content. So if that interests you, stick around. So here we are in Revit 2023. And what we need to do is find an architectural model that we can use as a starting point to add our electrical to. So what I've decided to do is use an architectural model that can be found on the Autodesk website that is free to use. And if you just go to your browser and do Autodesk sample projects, and let's get a 2023 in there to get the right version because there's a few different ones. And go to sample files right here. And you see we're in the Autodesk Revit 2023 help. This also points out there's quite a few help topics in here that you can go through as you're learning. But right here, Revit sample project files. They also have sample family files and these kind of things. Let's go to sample projects. And right here, this is a basic sample project. And it is a residential style home. And it's got 2 levels to it. And it has a sunken living room here. So that's a good sample project to work on. Now, I must say that Revit is typically used electrically for commercial industrial work, not so much on residential, because residential typically doesn't require the level of connectivity and detail in those plans that a commercial project would. A lot of contractors and electricians will self-design the electrical system. And frankly, I don't know how far they take their designs on paper, if you will. You know, they would have to do some kind of design to decide what circuits things connect to, things like that. So what I'm going to do is treat this residential project like a commercial level of detail, just to show how it's done on a small project, a small footprint. So with that being said, we're going to download this residential project. Now you can see there's other commercial projects. And in fact, in 2024, they have a complete commercial project, multi-story, multifamily, with full HVAC, plumbing, structural, architectural, electrical, everything that I will also be covering eventually. But that's a big project. So I wanted to show how this can be done on a smaller level. So let me go ahead and just download that RAC basic sample project. And I've already done that. So let's get back into Revit 2023. First thing I like to do is open the architectural model to see how it's built, see how it's put together. And I've relabeled this to get the version into it. I like to know what version it is. I mean, you can see it here in the thumbnail. It'll tell you what version it is. But that's only if I'm looking at this while I'm in Revit. If I'm outside and just explore and looking for projects, I can't tell what they are. So here's advanced, here's basic sample project. That is what we're looking for. That is the architectural version. Let us just open that up. Now, it's not too huge. It only takes a second to open. And I want to get an overview. You want to get an overview of your project architecturally so you know what you're going to be designing. Now, this lesson mainly deals with how to use Revit to document your plans, but it'll also encounter some design issues. So here we go. Here is a site plan, which is, of course, a view looking from the sky down. And we can see that here's the north arrow pointing up, and our building is somewhat tilted. It's not straight up and down north. And this here is some kind of a solar analysis to see how much light is coming into that project, as well as how well it hits their solar panels. And then we have a little bit of a planting schedule. So that's the site plan. Now, if we decide to do our own site plan, let's say we want to do a site plan that shows a connection out here to the solar panels or some other, bringing service in from the utility, we might need a site plan to do that. And this is a good idea of, what kind of tilt it might have if we really want to show it this way. Now we can always turn this and show it vertical. And then here's some other plans. These are the floor plans, a level 1 floor plan and a level 2 floor plan. Like I mentioned, it's a 2-story building, 2-story house. We have a kitchen dining. We've got the typical hall with a little mechanical room, a bathroom and laundry, and then one large living space. And then on the second floor, we've got the bedrooms, master bedroom. It's a linen closet, bathrooms. We got 3 baths up there and the entry hall and just a deck up here. So not a huge house, a nice project to start on to show the basics. And then they include elevations and sections, which are nice for us to see how this thing's put together. So we have those. More elevations and sections. Now, as we get into electrical design and drafting, we're going to be studying these a little more to see some of the details. Like we'll want to see, where does the architect want the lights? You can kind of see that this is a sunken living room. This is down a little bit lower than up there. So we'll have to look at that. That will affect the mounting height of some of our equipment. And then they have construction details like sections and such. And these are actually interesting because if we look into these sections, we'll find out that these are actually walls and railings. And so that someone didn't just draw detail lines and create the sketch of this. This is actually a section cut through the building, and these are actually building elements within this model that are cut and then just labeled. So that's another, of course, benefit to using Revit in lieu of a CAD program. And here's just some more sections to get an idea what things look like. We've got a walkway. We've got all kinds of interesting things in this project. So that gives us an idea of what's going on. And then if you want to get further, you can get to the views themselves, because these are just sheets that have views dragged onto them. We want to get into the views themselves. You can do it from here. If you expand each of these sheets, you will see the individual pieces. And this one, here's a schedule. Now here's the 3D view. Here's the site plan. Let's go to actual plans. Floor plan level 1 and floor plan level 2. You can also get to these views and pieces individually up here, the same stuff, sorted by name. Now, this brings up an interesting point that there's a lot to be said about organizing this project browser, and every firm, every person has their own preference. So you'll find different kinds of organization. This one is more of a out-of-the-box style Revit organization, but just note that this will vary project to project. The filled-in box just means that view has been dragged onto a sheet and is being used. And you can turn that on and off if you don't want those boxes. But let us go to level 1 and start looking at the details of this. As you can see, it's all individual pieces. These are model groups of chairs. This is an actual casework. We have doors, which are pieces. We have windows, walls. We have furniture. That there is a furniture, a table, a dining table. So it's just all a bunch of pieces. And what's unique about consultants, electrical, mechanical, even structural, is that we take this architectural model that's a bunch of pieces and we link it into our model, and it comes in as one giant piece. So we can't actually highlight the individual pieces as easy. There's a way to do it, but it's all kind of one piece. They've got some collection tanks, mechanical. We don't have HVAC or plumbing designed for this project. So that's one drawback on this project. I can't show how we would collaborate and coordinate with those other trades. You can link other trades in and see their equipment. You can see their ductwork and pipework, so we can avoid it. We don't have that, so we're going to miss that step, but we will at least get through all of the electrical connections, and we will assume some mechanical units and things like that. Again, a basic project just to show some of the basics and not get too complicated. I think the most complicated piece of this project will be that sunken living room. And that's only complicated because of Revit things like levels. Let's look at how that works. Now, in these plans, they've turned off their section cuts. You can't see the section symbol. So we will have to just find those ourselves. But here's a building section. And this is one that has that sunken living room. And what you want to look at here on sections is these things called levels. And if you recall, levels are actually an entity within Revit that determines what a view is based upon. What I mean is this level 1 is actually a physical thing in the model that a plan can be hosted to or attached to this level. It's related to this level. And once you set that plan up for that level, you can't change it. So thing about these levels is you have these little circles on the side that, and if it's blue, it just means that there is a plan view set up for that level. This level is being used for a plan. So they've only done it with 2 levels. These other levels now may be used for other constraints, maybe used for other purposes. But as far as what plans were done, it's just these 2. Now we're going to have to copy these levels into our own electrical model so that we have those levels. We need those levels to create our plan. Now we may not need a roof plan because in this residential project, it's just a gable roof. There's no platform up here with mechanical equipment on it, for example, like you might find in a commercial space. But it's still good to have a top limit in your model that we can relate to as far as view range, which we'll get into. But that's how that's set up. So, and the other thing I'll notice too is that this project was done in metric. These are all millimeters. Now we can still use this in our Imperial US based project. So this is sunken about 2 feet down below. And they did not create a separate plan view with that level. Some architects will. And so they would have this floor plan split into 2 pieces, one piece with the upper level and another piece with lower level, and then maybe combine them on the sheet somehow. But in this case, they've just decided to keep it all level 1. And what they've done is, even though this plan view is set up as level 1, and when over here under extents, we're actually looking at the floor plan. So under extents, you will see associated level right here on the right. It is the level it's associated with is level 1, the entire thing. And so what they've done is the plan is set at level 1, and the view range, if you recall, the view range is a bottom, a cut, and a top primarily. They have it set up for these kind of levels. The bottom is actually the level below. The cut plane is at this level above the associated level, and the top is hard set at this above the associated level. So they've got their cut plane established. But the bottom is the level below, which in this case ends up being that lower level living room. So even up here we can see down below, but since there's no basement in this, it doesn't obscure things. But we'll get into view range a little more then. But the things that are in this sunken living room are actually, as you will see, hosted to level 1 living room. So even though our view is set up for level 1, you can actually mount or host objects to the other levels. So it ends up being hosted to level 1 living room with a 0 elevation from that level. If we were to host this to our level 1, then it would need a negative offset to be down. So you can see what I'm talking about. It gets a little complicated when you have different levels, but it's something that eventually you'll need to deal with and learn. Other things, this whole living room could have its own view range. There's a way to do that. But anyway, this is how they've set it up. So we will mimic what they've done. Now here we can actually see the sections. So click on a section, and this is a section looking this way through the house. And again, you can see things like we've got the elevation. We can see the kind of the elevation of the kitchen. And you click on that, and that is a dishwasher. We'll need to know these appliances. A lot of times an architect will actually maybe do an enlarged view of this kitchen and point these things out to us. So it looks like a cooktop. You'll find as an electrical designer, you're going to be trying to figure out what are all these pieces because the architect didn't explicitly call them out. Luckily, here in Revit, we can click on things and see that it's they've got an induction cooktop. They may have a basis of design model number that you have to look up to figure out what the load is. But a lot of things, at least residentially, are kind of a typical. We put an outlet in for the range, for example, let's say a 50 amp outlet at 240, and it doesn't matter what model of range it is. Unless it's some special thing that needs, 60 or 100 amp outlet. But in this case, we're going to assume it's all standard stuff. Same with the laundry. How are these set up in the laundry? They're not called out. We can click on that and see that it's the washing machine. As you walk in, it's on the right, and on the left is a dryer. So that's good to know. Again, we have no mechanical equipment called out here. Also, in our electrical model, we'll be able to cut our own sections and elevations and look at things as well. So mainly from this model, again, I got the levels that I need to deal with. They're dealing with two plans. They're at, well, it's 1 to 100, so we'll have to figure out what that is for us. They have the site plan that's angled, and we may have to figure out how that's done. They are using a topographic surface. They're using actual model trees. They've actually modeled pieces. Now, why I bring that up is doing electrical work, you'll find out that a lot of architects do not model a site plan. And for some reason, they may just draw some detail lines on here, especially when you have commercial work with parking lots and such. It may be done with detail lines. The curbs are just detail lines. Well, those pieces don't show up in a link. So we'll link in their model and look at the parking lot, and it'll be blank because those were detail lines, not model lines or not curbs and things that are actually in the 3D model. So this is nice that this stuff is actually modeled so it will show up into our linked plan. So that's a note to you architects, anyone watching. So I think we know enough about this architectural model to go ahead and put that into our project. So let's close out of this. We have to be out of it to link it, and we don't need to save the changes. So let's start a new project. Oh, the other thing I'm going to do is I'm going to try to do this using the out-of-the-box templates and families. Now, that will be a struggle sometimes, as you'll see, but we're going to try it. So let's use in this version, we have an Imperial Systems template. So systems, MEP systems. So we're going to use that template to start our electrical project. Now, why it's called systems, what makes it special? Well, mainly because they have some views set up already. Over on the left, you see they've got some lighting views, power views, mechanical HVAC. They've got plumbing views. So that's one piece that makes this an MEP template. And they may have loaded some families. They may have done some settings. If you go to manage and look at MEP settings, they may have gone in here and got some things set up for us. And let's look at the electrical settings. This is a whole dialog box of all the behind the scenes stuff that Revit does, but some of the wiring may be set up, and they may have voltage definitions in here, even distribution systems. This is interesting because in doing residential, we need a 120, 240 volt single phase or split phase system set up if we're actually going to connect things together and make the distribution system work. So again, we're going to treat this residential project as a commercial project. We're going to add up receptacles like commercially we would with 180 VA per each, and just kind of a hybrid here to teach how to do this. But we do have the 208 three-phase system and a 480 three-phase system like you'd use commercially, but we also have 120 volt single phase. So it's single phase, 3-wire, 240. So that is a good sign. We already have that in here. We don't need to add it. Now, whether we have a single phase panel, we'll find that out later. but at least we have the system. And we can, in here, change things with, and we're okay with wiring sizes, but how wiring is shown. And when we get into wiring, we may come back here and change some of these things. But I mean, you can affect what the hot wire looks like, the ground wire, neutral, is it slanted? Are we going to show tick marks always or just on home runs? So these kind of things we will be messing with as we go. This will also point out to you how important your template becomes. All right, enough of that. Let's go back to we only need electrical. We're going to go to electrical power plan to start with. And we'll see that it actually is empty. This is where we can bring our linked architectural model in. And you have to do it into a floor plan. If we were to try to do it from, and we don't have any drafting views, but if you had a drafting view open, you wouldn't be able to bring that in. So we need to be in a plan view or a ceiling plan. And what we do is we just go up to, there's a couple places you can do this. You can go to manage links right here, manage links, and add one from there, a Revit link, because there's Revit, CAD links. We have images, all kinds of links. So you can do it from there, or you can go up to the insert up top, insert tab, and link Revit. So we want to link a Revit, and we need to find that basic sample project, not that one. Basic, there it is, basic sample. It's the RAC for architectural. And we're going to link it. Now, there's a number of positioning things we can do. We used to bring things in internal origin to internal origin. But if you study origins and project base points and all that coordinate system stuff in Revit, you'll find that internal origins really don't mean much. The thing that means the most is that project base point. It establishes elevation. It establishes rotation with from north. It establishes a north and south location. So I've been bringing things in base point to base point. Unless you have some kind of a fancy shared coordinate system, that typically will work. So that's what we're going to use, base point to base point. So there is the architectural model just brought in. And you'll see our template has some elevation markers, which you can delete, turn off, or whatever. But I just like to move these out of the way. And I do them by window because they're actually two pieces. So now if I do window this way, I may be grabbing the model. And that's a good point to think about. This model, there's the model. Let's pin that up here under modify. We're going to hit the pin. We don't want that moving around. And then if we window, I can move that. Now you also have over here under the modify, there's a select drop down. You have selection check marks. If you want to make sure you never select a link by accident, you can turn that off. And never want to select an underlay, never want to select a pinned element. You can do that. And that will keep you from accidentally, I can't even select that linked pinned model anymore. You can also get to those down at the bottom right for select links, select underlays. And so the same controls are down at the bottom of your screen down here. But I'm going to get these guys out of the way. I don't need those showing up all the time. So that's the architectural file. And now, as you can see, I see everything here. Even if I hit ZA for zoom all, I get everything. Now, when I actually create floor plans, I don't need to see the entire site. Well, a couple things you can do here. Escape out. You can get to the crop. There's a crop line here, crop view. Over here under extents on the right, there's a crop view. This just means that I want to actually crop the view, yes. And then the crop region, I want to see it. It draws the crop region box. And I can take this crop region box and I can drag this down. Now I'm cropping the model, not the grids. The grids are an annotative element that don't get cropped by this line. So I'm going to pull this in close to my wall. This guy, I don't need solar panels in my building floor plan. That's a site plan issue. Bring this in like this. Let's get how close we want some of that outdoors to show. So I'll just go to there. I'm lining up with this end of the building. And then the right one. Now, do I need all of this? I don't think I do for this plan. So I'm going to bring this clear in close to the wall. So there, now I've cropped out everything else. That's one way to crop a plan. But now if I jump into level 2, it's not cropped. I have to do the same thing. I'll have to do the same thing to all my lighting plans as well. So there's a shortcut to this. Instead of using this manually adjusted crop view, we're going to use a thing called a scope box. I'm going to undo all that. We're going to go ahead and draw that scope box. That's under the View tab. It controls the view. And right here, Scope Box controls the visibility of datum elements, grids, levels, and reference in the views. Yes, it does, but it also crops the view. So let's do that. And we're going to do a similar border. We're going to start here and just click it once. And then this drags as you move the cursor to there. Now that created a scope box. And over here, we have an opportunity to name it. We will call this, I like to call it something like building versus site. Apply that. So now we actually have a scope box, and it's a 3D element. If we go down to this created 3D view that's already created, here we can see that this scope box is actually a 3D box, and it can be dragged up and down too, but it looks like it encompassed our entire building. And so we're good there. I think even we may want to go a little lower just to be sure. So there. So now we have the scope box and it's named. Now we want to apply that scope box to this view that we're in. We're actually in Power. So over here with this extent stuff, down here there's a place to assign our scope box. So we're going to assign the building scope box, apply, and there it went, instantly cropped. And the benefit of that now is that when I go to my second floor, I can apply that scope box and it's instantly cropped exactly the same as the other floor. So you can see the power of that is it's kind of like a template controlled cropping. So I'll do that with all of these. Now, one thing I'll mention on the ceiling plans here in a second. There's two different kinds of plans. We have a floor plan and a ceiling plan, and you can see they're both created here in this template. If you get into the nitty-gritty of that, you'll see that a floor plan is looking down on the floor. A ceiling plan is looking up. Well, it's reflected, but it's as if you're looking up. So they display differently. They show different things. A ceiling plan, you can get to the ceiling to put lights. A floor plan, you can't. So what we've decided, our firm has decided to only use ceiling plans for lighting. Some firms may do both. They may do floor plan and ceiling plan. We like it all in one. So we don't even use these floor plans for lighting. I could just delete them, but I'll just close it for now. So we're going to be using the ceiling plans only, and we'll get into more of that later. The other thing I want to make sure is I have these things already made for level 1 and level 2, but are my level 1 and level 2 at the proper place? Let us go to an elevation. There's already a south elevation created, and this is how you can see your levels. So as you can see over here, these end up being the architectural levels that were brought in, and it's kind of hard to see these with the scale. We can play with the scale to make these smaller. There we go. So we can see these levels, but we can't touch them because they're part of the linked model. Here's our levels. You can see I can actually highlight those. And level 1 and level 2 are just in my template. Let me drag these over so I can see them. Now, when you click on it, you'll notice there's a tiny little circle, and it even gets smaller sometimes. It's a tiny little circle that if you grab that grip and hold it, you can drag it around. Now, if I let go, I can't drag it. Now, if I was to drag it and continue dragging it beyond the edge of this view and now let go, I'm still dragging this while I'm letting go of my mouse. So now I can drag these all the way over somewhere where I can see them and line them up. Now, level 1 is at 0 elevation and 0 elevation. So these are already aligned. These match. Level 2, ours is a little bit higher. This level 2 is not at 10 feet. It's at 3,000 millimeters. Now, again, I mentioned before that this model was done in millimeters. Our model will be done in feet and inches, and it's doing the conversion for us. But I want this level to match their level. Now, the way you can do that is to go up to Modify and find the Align tool, or there's a shortcut. As you see, after Align, it says AL. That's a keyboard shortcut built in. Instead of going to Modify, we can also just click on the level, and that automatically opens Modify to get to there. Or we can just hit AL. I'll use the ribbon for now. And Align works where it says, select the line or point reference for alignment, which means, what do I want to align my stuff to? I want to go to this from a second, from there. So that pulls it down and aligns it. And no need to lock it. If it moves, we'll have to adjust it later. Another thing I show in my commercial videos is that our actual template only has one level, and we just copy and then monitor the architectural levels. But there's multiple ways to do it. If you want to have multiple views already set up in your template, then you need levels in your template to set these up. And I've seen some architects set up to 10 floors in their architectural template. So, there's always 2 or 3 ways to do things. So this is how you would do it if you already had the level. Now, we do want a roof line. Again, I said it's nice sometimes to have an upper limit on views. So let's go ahead and put that roof line in. I also want to make sure my lines are extended, and they're extended way over here, which is more than enough. Let's go ahead and add that. Now we can just right click on here and say, create similar. You can go up to architecture and add levels that way over here. But let's just right click, create similar. I'm going to start, and I don't care the height right now. I'm going to adjust it later. I can start. You can see as I get close to the end of that, it gives me a little dashed guideline to line them up. It's not critical, but I like to line them up. And then drag it way over, and then you can see my blue line lines up to line those up. And it gave it its own name. It just called it whatever. We can change that. Click on there and change this to roof line. If I can spell, there we go. Would you like to rename the corresponding views? No, I'll name those manually later. And then let's do the align. Align to there, from there. And you can see the conversion from millimeters to inches gets a little messy. But that's what we want. So now we have our 3 levels in our model. And let's go back and see. Level 2 was close already, so it's not going to change a lot. Another thing I'll point out right here is that this background architectural model automatically gets half-toned, and out of the box Revit is pretty light. Like right now, these seem fairly faint. These can be adjusted, and we adjust this in our own template. The way you get to that, go up to Manage, and under Additional Settings, there's a couple places of settings. We saw the MEP settings earlier. And then over here, there's object styles, which you can get to things like lines and line weights and all that kind of stuff. And then you can get to additional settings, which has more line styles and things. So there's a number of places that you'll have to get familiar with where settings are. We're going to go to one called halftone/underlay. And this controls the transparency or brightness of these halftones. We're going to leave the underlay with the built-in pattern, but we want the brightness higher. Right now it's at 50. I'm going to suggest we go to 70. You can just type this in manually. You can also just drag it. So that is a little darker. If you want it darker, you can go to 80, whatever works for you. And then the real test is when you try to print this to a PDF or even to paper, what does it look like? We do want it somewhat dim because we want our electrical items to pop out. So that's how you can control that. Another thing that we do when we set up a project is see these grid lines. You know, architects use grid lines and structural use grid lines to show typically columns, walls. They set up a grid pattern that's meaningful to help us identify where things are. So we want to mimic that. Now, we have no control over these grids. And maybe it doesn't matter. For most projects, it might not matter, but we've run into issues where it does matter, where this is in the way of a schedule, or I really want these, I'm zooming in here and I want these bubbles over here. Well, I have no control over this at all. I'm at the mercy of the architect. So, like we did levels, we want to have our own grid system. And this is where we will actually copy the grids rather than putting our own grids in and making them all align. It was fine with 2 or 3 levels, but with this many grids, I just want to copy these. The way we do that is actually under the Collaborate tab. It's a kind of a collaboration to copy monitor someone else's link. So that's the way to think of it. Collaborate, there's a copy monitor button. And now, which project do you want to copy monitor from? Well, we only have one link, so we could say use a current project. But for good practice, let's go to select the link, because eventually you may have structural, mechanical, plumbing links. So select the link, and this, even though you don't select links here, this overrides that and lets me select a link in my project. So copy monitor, select link. It will let me select this link. So there, I clicked on it. You couldn't see much, but I actually clicked on the link, because now I have things I can do. I'm just going to go copy. Now, monitor is only monitor. If I do copy, it will copy and monitor. You'll find out. It's kind of confusing. They didn't say that. And then under here, we have another little menu, copy monitor. We want to copy monitor multiple things at once. We don't want to have to pick them individually. So hit multiple. Now, I can use different windowing techniques to grab just the grid lines. I can start at the right and drag left, and you'll see I have a dashed window, which is a crossing window. And you can see these highlight as I drag over them. You can do that. And then if I want to do another set, if I do this other set here, the first set's gone. I have to hold Control down to add more sets. Now I can do this with everything. There's another way to do this. Escape out of that. Copy. Multiple. I'm going to window from, I can left to right, right to left. Get the whole project in here. And then use a little funnel. It's a filter. Filters are very powerful in Revit. Use a filter. It shows that I have floors, grids, and walls. Those are the categories I have selected and how many of each. I don't want to copy the walls. I don't want to copy floors. I only want to copy grids. So there's all 14 grids selected with one window, and say OK. So that narrows down my selection set to just grids. I need to finish the multiple selection, and then it kicks me out of copy monitor after it's done. So then it kicked me out. I'm still not done copy monitoring it, but it kicked me out. Who knows why? Go back to copy monitoring. Now we can actually finish the copy. The first finish was to finish these multiple selection set. Second finish is to finish the copy. Now what you'll find is I can hover over these, and I have control now of my grids. Now they're tied together right now. They're pinned together, locked together, which is nice. I can control them individually later, but I have control now where these grids are. I have control on whether I show a bubble there or click on here and show the bubble here. Now I don't want to move these around, but I can control their appearance. But I still see the architectural grids there as well. Well, we can turn those off. So now we're going to jump into a visibility/graphics. You're going to eventually know this like the back of your hand. This is what controls most things in Revit. Not everything, because some things are controlled by phase and things like that, but most things are controlled by visibility graphics. If I go over here, I get this giant window. What's going on here? Visibility graphics override, and I'm in floor plan 2. So I'm in level 2. Showing all the model categories. There's also annotation categories and imported categories and Revit links. So we can get to all kinds of things. So you can get to all these categories. This is our model, controlling our model. We don't need to turn on and off our model grids. We want to turn off only the linked grids. So we need to go over here to Revit links. There's our link, architectural link. And it's already halftoned, so we don't have to hit halftone again. The display settings for that link are by host view. What's the host view? Our model is hosting the linked model, so we are the host. Right now, our view is controlling grids. We want to turn off just the grids in the link. So here we go. There's a bunch of things you can do here. Like I mentioned, there's phase filters, detail levels, all this kind of stuff. We want to go to custom, and then we want to custom the annotation. And grids are annotations. So we want to customize the annotation view. Again, we need to go to custom, because there's so many different things you can do here. There's a few levels. Now we are looking at, reminds you that we're in the Revit link display, not our model. We're in the link. And we're going to turn off grids. So go down here, you see all the different categories of annotations. Tags, 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 tags. There's all different kind of tags. Right here, grids. We can uncheck grids and say, okay. Now the architectural model grids are off, and all we see left are our grids. So now we can control our grids and where they are. I did this one here. Let's say I want it down here on all three of these. Now I have ultimate control on my grids and what it shows. So what else do we need to do? Well, we need to finish setting up our plans. We have our power plan set up and cropped. And we have ceiling plans set up and cropped. Now we need to control what do we see in each of these views. For example, first floor power. Similar to the scope box that let us apply a crop to every sheet, we can set up view down here, view templates, templates for the appearance of these views that we can apply to other views. Right now it's just two views, two floor plans. I don't have any other plans. I may only have to set this up twice, and I may not need to use a template for everything, but I think it's good practice to get used to setting up view templates for use. So we're going to do that. Now again, our project template, don't get confused project template versus view template. Our project template that we use has a number of view templates already set up. But even those need some tweaking when you have a linked model, unless you are starting from an actual project-based template. So what we're going to do is do a view template. There's none assigned to this view right now. We're able to control everything, view range and everything from here. And that does bring up a good point, is that we haven't dealt with view range yet. We will deal with that in this template. So we are going to look at templates. Now there's a few out-of-the-box templates. We can, let's say if we try this architectural plan. So as you see, architectural plan has the same categories here as we do over here. But these are the settings within a template called electrical plan. So it's set up for 1/8 inch. And this column here called include tells you what's included in this template. Because sometimes you can not include things in your template for various reasons. So right now they haven't included any color schemes and underlay orientations in the view template. They're letting us control that with each view. But most things here are controlled in this view template so that we don't have to set them on every view. So we have our model overrides, annotation overrides, and you can see they're broken out. Instead of just one button, they've got individual ones, just as if you went to the individual tabs up here. So we have scale set. The detail level of this view is set here. Now, what is detail level? As we'll see, your families look different depending on the level of detail you pick. There's a coarse, medium, and fine. On a coarse view, plumbing may look like a single line. Conduits may look like just a single line. But in fine view, they may look like a 3D pipe, 3D conduit with fittings, things like that. So this one is set up for medium, and we can tweak that stuff. The overrides we just did on that Revit link are not set up in this. But let's just change the electrical plan and see what it does. It doesn't look a whole lot different. Now, they called it electrical plan, not power plan, not lighting plan. So this template is set up to show anything electrical all in one plan. Now that does bring up a good point as to how many different plans do we want and what do we want to see on each. I think architects, if they were doing an electrical plan, they would put power and lighting and even, technology, teledata, things like that, all on one view, one plan, because they're not going to the level of detail on that we would as electrical designers. So that's why we are breaking this up into a separate power plan and a separate ceiling plan for lights. And we could even have a separate technology plan if we want. Sometimes we'll combine technology with power. Again, it's a decision on how you want to set up your set of plans. It boils down to we don't want lighting showing up on a power plan. So we need to turn these lights, and these are lights in the architectural model, we need to turn those off. Long story short, we're not going to use the built-in view templates. We're going to set up our own. So let's get out of this electrical plan. We want none. We don't want that view template. We are going to create our own. And what I like to do is set things up the way I like, and then I create a view template from that view. So like, for example, in Power Plan, if I right click, I can go to create view template from this view. So once I have everything set up, I can create a view template and use that view template on the other power plans. So that's how we're going to approach this. So let's get this one set up the way we like. Now what happened is when I switched over to the electrical template, it undid what I had just done for my architectural. So keep that in mind too. If you switch to other view templates, a view template, it's going to counteract what you had done because what I did was not in a view template. So we have to redo that. The other thing that can happen, usually commercially, is you might see other architectural things that you want to turn off. I don't see it here, but sometimes they'll have an ADA door surround, that little dash line that shows the ADA clearance. And we don't typically need that on our doors, so we could turn that off. So there may be other architectural things we want to turn off, but we're going to quickly go through and just redo this as practice. We want to go to the Revit link. We want to make it custom. We want to customize the annotations. And we want to go down to grid and turn the grids off. So we just redid what we did before. But as you know, the more you practice, the better you get. So those are off. Now we want to turn the lights off. So let us go and turn those lights off. Now, I could turn the lights off here and it would turn off in the Revit link. However, we are going to apply custom to the model categories as well in our Revit link. So now we're not going to be controlled by the host anymore. So we do have to turn them off here. So we want to turn off, while we're at it, let's turn off any electrical equipment, any electrical fixtures, any fire alarm, and let's turn off, there is no mechanical equipment in here, but you can turn off a lot of things in the architectural model that you don't want to see. Sometimes you want to turn off this, there's one that jumps out at me as entourage. This guy has people and vehicles, things like that. Well, we don't really need to see those. They're not on our way. We'll leave them on for now, but sometimes if they put little people inside the building, we don't want those showing. So let's go down to our lighting devices and lighting fixtures. We'll turn those off here. Now, when we get to the lighting plan, it'll be a different story, and we'll talk about that when we get there. But we don't want lights on our power plan. We're going to leave furniture on because we may want to align some power devices like receptacles. Maybe we want some floor boxes underneath some of the furniture or things like that. So we'll leave that on for now. It's nice to know where the television is planned to go so we can get facilities for that. So I think that's a good setup for the power plan. So let us now, an 1/8 inch is a good scale for us. We're going to create that view template now. Create a view template. Well, it wants us to save the project, and that's fine. I haven't given it a name yet. So let's go ahead and that's not, I don't want it under XREF, I want it under electrical. We're going to call this tutorial, residential. I like to call it electrical. And I like to give it the version R23. All that in the name. And I only need one backup. There we go. Good idea to get that saved early on and named properly. Your office, if you're in an office, may have your own naming convention. Now, I'm jumping back into my creative view template. So I'm going to call this ER for electric Rob. I like to give it a name in front of it. We're going to call it power plan because it's not lighting. And I'm going to give it the scale because scale is baked into this. So now I have ER power plan. Good. Now it doesn't always assign it yet. So now I need to also assign it to ER power plan. There. Now that this has a view template, I cannot make changes here. All of this is grayed out. Anything that's tied to that view template now, I cannot change here. Now we saw some of the color schemes and stuff wasn't tied to that, but things like view range, I can't even get to that button. So the view range now is controlled by the view template, and to change anything view range, I have to go into the template and then change it here. View range is here now. So you can see all this stuff is brought back in. I can't change the detail level. It's grayed out. So that's what's going on there. It means it's template controlled. But that does mean that I can jump into my level 2 power plan and assign this view template ER power plan. And everything's controlled by that. Now let's get into the view range issue. And perhaps let's cut a section. Let's go to the power plan and let's cut a section through here. The way we can do that is up top in the quick access bar, we can go to section. And this is really handy to just cut a section wherever you want. Start there and drag this over, try to keep it parallel. And then if I double click on the pointy head there, it opens up a section. And it opens up a section and it's a discipline called electrical. If we had electrical devices in here, it would show all of them in like a X-ray vision. But let's look at that. So as we're looking at view range, now we see that these two levels have different tops. This may affect us more when we get into lighting, because the roof line that they've established, maybe where the eaves are. In fact, let's go here and cut another section. Let's cut a section this way. Yeah, see, so the roof line is up here at the bottom, the start of the roof. The second story has a lot of vaulted area above it that may cause problems with our lighting. So we'll have to adjust that. There may be something we need to deal with if there's any kind of fans, ceiling fans hanging up there. So we'll have to keep an eye on that and see if we need to adjust. And what would that do with our view template? That means we may need separate view templates for level 1 and level 2. That happens a lot commercially. A lot of times level 1 is taller. It's the opposite here. We can do that, again, with only 2 views, it changes really how much we need to worry about view templates, because if we only have one view that uses that template, why have a template? The template's made really for duplicating the same view elsewhere. But it's good practice to get used to. The other thing you can do is we could actually disconnect the view range, pull it out of the template, and let each floor dictate its own view range. And again, depending on the situation, that may be the choice. A couple different choices. Getting ahead of myself, we're going to be fine with this for now. So the last thing I want to do as far as setting this model up to get started is dealing with the work sharing issue. Now, you may have heard that Revit has a work sharing option that allows multiple users to be in the same Revit model working on it at the same time, which is pretty ingenious if you think about the old CAD systems where only one person at a time could be in it. So we don't really need that set up. If you're just a sole proprietor working on this project by yourself, you have no one else dealing with you, no one else in your project, you may not need it. Now, if you do use things called work sets, we can't see them here, but work sets for visibility or for turning things on and off or possibly for performance issues, then it needs to be a work shared project. We're going to use filters to turn things on and off here instead of work sets. I'm trying to work more into the filter line of thinking. So you may not need it, but I like to do it. We use it commercially in our firm, so I want to show how that's done so it gives you a complete picture. If you don't need it, you can skip this. But the way you do it is you go up to the Collaborate tab, and it looks like I'm already there. And there's over here, Collaborate, and then there's Work Sets. So we want to hit the Collaborate tab. We need to save the model before we can collaborate. All right, that's fine. We can save it. It wants to make sure we have the latest and greatest. Now, Collaborate. You can collaborate within your own network or out in the cloud. Now, you need to have typically a special license to do this cloud collaboration, and firms do that kind of thing. But for us, we're going to go within our own network. Okay. And right now, behind the scenes, it's just doing its crunching to make it collaborate. On a larger model, it'll take a while because it looks at each view and things like that. So if you have a 10-story building, it's going to take a while. This was quicker. Now, it didn't do much, but it's set up. But before we can actually use that collaboration as such, we need to save this as what's called a central model. And the central model will live somewhere on the network, a central location. We put it on our main file server so that other people can get to it. So let us go ahead and save it. And I hit Save As, Project, not Cloud, Project. And I'm resaving what I'd already done. But now it's going to be saved as a central model. And the options, look at that. It wants to give me 20 backups. Well, I'm fine with one because we do our own nightly backup. And just say OK. And hit Save. And I'm just saving over the old single model. Now I'm putting in a central file, central model. So collaborate, set up work sharing, save it as a central model, and then get out of it. Now, when I reopen it, you'll see I have some new options. So let's go to Tutorial, Residential, Electrical, not the backup with the 0.0001. Now down here, you'll see some new work sharing options. Create new local. That just means it's going to take that central model on the server. It's going to create a copy of it onto my local hard drive for me to edit. And every now and then we're going to synchronize with each other so that I get the latest updates from the central that maybe somebody else is doing, and central gets my updates. So that's the collaboration part. We don't want to detach this. That's another step that we do for other reasons later that we'll cover. But for now, we want to create new local. So every time we open this, we want to make sure we open it from the server and that we do create a new local, because the old local will still be on your local hard drive. You do not want to open that because now you have an old version of your file. So that's how work sharing works. Other than that, it's pretty transparent. You'll see down at the bottom now we have this thing called work set. This is a way to divide your work up into further categories, if you will. Not quite layers, but it segregates things into pieces. So in a large model, you may want to have half the building on one work set, the other half on the other, so you can turn it off and not affect performance. A lot of people use it, and we used to use it for visibility control. I'd put my site stuff on a site work set so I can turn it off on my building. We've learned that using filters is a better approach for various reasons, which we'll cover in the filter lesson. But for now, you'll see that it puts your username on here. Mine's just email address. It'll put your username up there, and that lets you know that you're working in a local file. And now instead of just save, you get a button next to it called synchronize. So if I hit synchronize now, it is synchronizing my local file with the central file. And of course, nowadays, a lot of firms will put a central model in the cloud that multiple physical, geographically remote locations can get to and collaborate on. through the internet. So the last few things I'd like to do to get this model set up for this first lesson is go to my ceiling. I want to do the same type of things with the grid here. And remember, I have not assigned a view template to this yet. So let's go ahead and practice. We'll go to the same thing. We're going to the Revit links. And I can do it here now because I don't have a view template. So I'm doing this first, and then I will create a template from it. And we want to make this custom. We want to make the annotation custom. And we want to turn off grids. Okay. So those are turned off. Now I have my own grids like we talked about before. Now, what about lighting? Eventually, I'm going to be bringing my own lights into my model. Now, some people might think, well, why not just use the architect's lights? Well, we are going to connect our lights electrically. We can't do that with a linked light. Furthermore, even if we could, architects typically link in lights that have no electrical connections. That's not their thing. So we are going to be reproducing our own lighting families into here. Now, also, what level of detail do we want those? As electrical designers and engineers, we are not creating a rendering kind of atmosphere for this model. We are just it's diagrammatic mostly. We want it for the electricians to know how to connect things up. So we don't care that it's ultimately, beautiful visually. We get close, but we mainly are looking for things to connect. So we're not going to need the architectural lights on in our model when we produce it. We may want them on in the interim to help us line our fixtures up with theirs. So what we can do is we can turn them off in our, what I would call production view or sheet view, the view that gets dragged into our construction documents. But we can have them on in yet another view that we can create as many views as we want with different things showing. We can create a working or coordination view that has their lights on. So we will get into that. Right now we're going to set up our production view, our sheet view. So we're going to turn those off. So again, we're in the Revit links. Make sure you're in the Revit link. And we have custom set up. Now we're in the Revit link display settings. Under the model category, we need to make that custom as well. And then down here, again, we're going to be turning off electrical stuff, fire alarm stuff. And then we want to turn off the lighting devices, lighting fixtures. Okay. So now those are turned off. So in our production view, we're not going to see those. Let's go ahead and create that view template. The way we do that again, right click, create view template from this view. And our new name, ER lighting ceiling, 1/8 inch. To remind us it's a ceiling plan. And it looks good. And then we want to assign it to the ER lighting ceiling. And then we also want this one to be the same. We may adjust the view range later. That gets us started. The last thing I'll do here is I like to rename these views. Now, when I drag these onto a sheet eventually, I can give them their own name on that sheet that shows up in the title block down below. But I still like, for my own, organization and for helping us as we go through, I like to change these things, rename. Now, the number in front helps them sort. And I've used things like, 00.1s and things like that. But for a simple project, the 1 and 2 works. So I'm going to leave it as 2. Now, you can call it floor plan, ceiling plan, whatever you want. It's based on a ceiling plan and it looks up at the ceiling, but electrically we often call these just lighting plans or floor plans lighting, because sometimes we'll show lighting that's not on the ceiling. It may be under cabinet. It may be, on the edge of the floor, things like that. So it's really a floor plan for lighting, but call it whatever you like, what makes sense for you. And let's go, I'm going to go first floor plan. You could call it level 1 lighting, level 2. And frankly, a lot of this has to do with the architect you're working with and what they're calling their plans. Make things match. Power. Again, your company may have its own naming conventions. Okay. Now the 3D view, we're not setting up yet. We may do that later as we go, but for now we've got the basic plans, the basic views that we need to start doing some electrical work. So this concludes the first lesson, which is setting up your electrical model, getting the architectural linked in, and setting up your views. So stay tuned for part 2. Welcome to episode 2 of the full project residential series that we're doing here on the Electric Rob channel. We're going to be covering things like adding room names to your project and some of the pitfalls you may fall into with the room tag issue. We're going to look at downloading some content from Autodesk's cloud. We'll look at placing receptacles, assigning loads to receptacles. We'll change the scale of our drawing. We will get the mounting heights set for these receptacles and associated with different levels of our building. So stay tuned for an in-depth electrical video. So here we are in our residential tutorial project, and I'm on first floor plan power. I plan to put in some room names. Now, how do we get room names into this thing? We don't want to just type text if we don't have to. We'd like to use the built-in room tag tool in Revit. So up here under annotate, we go to room tag. This may seem like a very straightforward, simple thing to do, but sometimes you'll run into roadblocks, and I'm glad we will on this one so we can show you how to deal with them. Nothing like the simplest things driving you nuts. So here we go. Room tag. First of all, rooms are not currently visible in this view. A view template is assigned to the view. In order to make rooms available, the view template needs to be edited or removed. So by default, our view template did not have rooms turned on, which are a physical entity in Revit. So we need to manage our template and get those rooms turned on. And they mean in our model. So we're going to go to our model here, not the Revit link. Our model, edit that. And we're going to go down to, it's actually a model category. It's a 3D piece down here under rooms. And we can see that rooms is not turned on. We're going to enable rooms. Okay. There. Now we have rooms enabled. Now we go to room tag, and I'm hovering over things. Now, I've already gone back and checked the architectural model, the original model, and found out that they indeed have rooms set up in this project. So we should be getting some kind of an indication that there's a room. So there's another thing going on. Other things you can check, and this is, again, I'm glad this happened so we can review this. Other things you can check are to make sure, and we can't do it there, we have to do it in our view template. Make sure that room tags are also enabled. That's the annotation portion of the room tag. Down here, make sure that room tags are enabled. We're good there in our model. Let's go to the Revit link. Make sure that rooms, remember we're in custom, and we are going to the model to make sure the rooms are enabled in the architectural link. Rooms are good there. And let's check the annotation. Make sure room tags, we have a lot of places to check here. Make sure the room tags are good there. So all of that stuff is enabled, and we still cannot get to room tags. There's an obscure issue here with this linked architectural file, and it comes down to kind of a more advanced topic that we usually don't cover till much later in a lesson, but it's called phases. Revit has built-in project phases, so that what I mean is phases in time, where you can have an existing point in time where you show maybe it's a remodel project and you have an existing portion of the building that's only half of the building. And then you have new construction, which is this wing coming out. And you can have those in different phases so that they can be turned on and off. Down here at the bottom of this view is the phase filter. And it's grayed out because in the template we says we want to show all phases and which phase are we currently modeling in, the new construction phase, because the existing would be nothing. This is a brand new building. So that seems okay. But what we need to do is look at the phasing of this model. Now, the way you do that is click on the model. I've got this set up here so that I can select it. Click on the model, and there we have clicked on the link. Now, we need to go into it's a type thing, a type parameter. We need to go into the types and clear down at the bottom. There's other phase mapping. Again, this is advanced. Go into the phase mapping. Now, if you had a project where you had a remodel and there was an existing phase and a new phase, and maybe there was a phase 2, phase 3, you would need to map our model to match the architect's model. Why would their model have phases? Well, look at this. Our phases are existing and new, the standard out-of-the-box phases. The architectural link has existing and then one called learning content. So these don't match. We're looking at a learning content phase, which because this architectural model was set up for trying to teach how to do things, they had looks like here they had a separate phase called learning content, which had, I don't know if you recall when we looked at the model, but it had some question marks that you could click, things like that. So they put that on a whole separate phase. So they have existing working drawings phase and learning content phase. Well, my hunch is that the working drawing phase is what we want. Click match our new construction to their working drawing phase. Click OK. First of all, it's not so dim, so that acts more like normal, because usually we have to go in here and change this to a halftone. And the other thing is when I click on it, now I see these X's, and these X's indicate rooms. So the whole key here is that the architectural model phasing had this extra phase called learning phase, which did not have rooms in it that was linked. So that's a good key for any future projects. If you have trouble with room names, things like that, check the phasing. So let's move on with now that we have that fixed. So back up to room tag. Now, as we hover over a room, you will see they work. So we can put kitchen and dining. This whole area is kitchen, dining, all one area. We can put this somewhere where it mostly will be out of the way. We can always move it. That's the joy of having our own room tags, is we can move them around. And we need them typically in different places for a power plan as we would in a lighting plan. So let's get these in here. It gives you a name and a room number. And that can be controlled. If you click on there over here, there's two different room tags built into Revit, room tag and then a room tag with area. So if you're looking for some areas, and typically residential load summaries are handled a lot by area. So we may need that later. But right now we're just going to tag it without the area just to get the name in here. And this is a hall, and they don't have the stairs tagged separately, which is fine. This is the living area. So second floor power, same thing, go to room tag. Now you can also go to tag all and click room tags down here and see what happens. And it puts them all in for you. And then you can move them around to suit you. But that's kind of a shortcut there. Now, some of these areas don't have rooms, like this deck and this side out here. So if we want to label, we can just use text for those. But I would recommend doing the same for the lighting when we get to the lighting plan. But for now, we're good with power. So we have that done. Now we can deal with this halftone issue because this is fairly dark. And we do that in our view template. Let us go to our Revit link. And there we can apply the halftone. I also like to make it an underlay, which just means that if you think of it as layers, we want the architectural plan to be behind or under our line work. So the architectural doesn't obscure our devices in our line work. So what we want to do next now is to actually let's get to do some electrical stuff finally. we want to get some receptacles and power connections into this model. Like I said before, we're going to try to use as much of the out-of-the-box Revit families as we can, because I know customizing families is an advanced topic, and many of you aren't ready for that yet. You're just learning how to do this, and so I'm going to try to do this out of the box as much as I can to minimize the learning curve of getting things started. So let's see what we have in our model right now for families. Down here under electrical fixtures, families electrical fixtures, we have a duplex receptacle, and looks like we have already brought in a special purpose receptacle. Now, if you don't have that, we can bring in some more families. So a standard duplex, let's look at that. And we can just drag one in. You can also go up here to the systems menu and find the electrical pieces here. You can go to device and you can go down to electrical fixtures and you can click on that. And then it will give you a drop down that you can click and find the receptacles that way. That's one way to do it. I like using this project browser as kind of an old school tool palette. So I just drag those in from here. Another way you can do it is you can create a separate plan that has all of these in it, and you can just create similar from there. There's a number of ways to do this, but let's just do this. We're going to drag it in. Now you'll see that I can't just place this anywhere. It is a face hosted family. So it wants me to place this on a face. Now what's funny is it considers a grid line as a face. So that will kind of mess you up, especially somewhere like here where you have a grid line right along an actual piece of wall or cabinetry. So that will mess you up. But let's find a clean wall right here. So if we get close to that, now this receptacle is set up for the two lines hitting the wall. Some other receptacles are turned around. I've even seen receptacles that was just a circle with two lines in the middle and no lines extending from it. So whatever symbol you're used to, if you're trying to use out of the box, this is the one you get. So right there, it will let me place that. If I go too far, it tries to flip it around to other things. So you have to get a little careful to get that guy right there and click it, and there it is. Now a question mark popped up just because this receptacle has the opportunity to put some kind of a label in here. But when you escape out, that's what you get. So I should say, since we're doing kind of a residential plan here, there's a lot of code implications to residential receptacles. In fact, there's more code implications to residential than there is for commercial. So it's a much tighter code, and it's there for safety. We don't want people running extension cords across their room to power things, or through doorways or across doorways, things like that. So I recommend studying up on code section at least 210.52. I'm not doing a code class here. There's plenty of other places on YouTube you can find things, and on the internet, such as Mike Holt is a great code resource. He's been doing it for decades. And a great resource I found to study up on a lot of code issues is also Ryan Jackson. I'll put a link to his YouTube channel down below in the description, and you can check it out. He has a 3-part series specifically on residential code interpretations for receptacle locations and circuits that I find very helpful, and our firm uses that for a lot of reference as well. So shout out to Ryan. But I'm going to try to hit the major points of this, and I may miss a few, but I want to teach you at least the basic steps for getting receptacles into your projects and getting them circuited up. So we're going to follow the typical, what they call the 6-foot, 12-foot rule, which is where when you need a receptacle within 6 feet of the end of a wall, and you can't have more than 12 feet between them, such that a 6-foot cord along that wall can reach anywhere. That's kind of the basic rule. Then when you get in the kitchen, you've got receptacles needed above the counters. You've got receptacles that you need for the appliances, receptacles on islands and peninsulas, things like that. So we're going to try to hit as much of that as we can to get things laid out. So this is just a standard receptacle, 120 volt. Let's look at that. Edit. It's a voltage of 120, load classification. Now this is used mainly in commercial work where we need these loads to be classified by what they're used for, by the load, so that an appropriate demand factor or calculation factor can be applied to it. Some things need a 125% demand factor, like lighting. Other things need less. So that's under load classification. And you can see here, I'm not there, but right here, you get the list of load classifications that are built into Revit. So there's a lot of them. We've got clothes dryers and ranges, existing loads, equipment, elevators, heating, all kinds of lighting. So whether you have a different demand factor for this or not, you can still divide things up by load types to help you get an idea for how much load you have of each type. And that will show up in the panel schedules that we do. Again, this is residential, and we're kind of doing a hybrid using commercial calculations right now just to demonstrate how this works. So we're just going to leave this as a receptacle. And then over here, you'll see it says demand factor. Well, it gets confusing because the demand factor has the same name. It's called receptacle, and here's similar demand factors for these load classifications. Very rarely are they a different name, but what happens is in the receptacle, if you look at the details of it, there is a calculation going on in here. And this can be customized for other types of loads, but the basic idea is the calculation is by load, not by quantity. And following code rules, it's the first 10,000, first 10 kilowatts or kVA is 100% of that load. And then anything above 10 kVA is only 50%. And that's based again on the NEC. But that is done here for a number of different kinds of loads. So that luckily is already done for you in Revit. So we're just going to let that be with the demand factor of receptacle, load classification receptacle. We just want to briefly cover that is all variable in here. 120 volt. And you'll notice that there's no option here for a multi-pole like a 240 volt outlet. This is strictly a single pole 120 volt, which is great for this receptacle. Another thing I want to mention is you didn't see me do it because I did it in between episode 1 and 2, but I changed the scale of my drawing to 1/4 inch. You look down here, 1/4 inch, because this will be detailed enough where 1/4 inch will be nice. I could just enlarge the kitchen at 1/4 inch, but if we look at the size of this building and we kind of cheat and look at the size of the sheet, we find that it fits on there. So I only did it on this one view template and I did not carry it through. So let us just review how to do that. As you can see, my name of my view template still says 1/8 inch, so I need to fix that. But what I did is I went in here and I go here and I just simply changed the scale to 1/4 inch. And what I want to do is I want to rename this to make it the right name, just so that doesn't confuse us. And we'll do the same with the lighting. Let's jump into lighting, do that right now. See, it's still at 1/8 inch. So let's go here, simply change the scale to 1/4 inch. And let us rename it to 1/4 inch. There we go. Now that will affect the size of all of our symbols. So there we go. That's why the symbols aren't too huge. But the next thing I'd like to look at is these symbols don't really pop out of the plan. They're kind of just fading away as far as line type goes. They're very thin. Even the architect is thicker. We need to stand out more than the architect, of course. So the way we can do that, this is a symbol which ends up being a generic annotation category. Now, custom symbols that we make, typically we try to change that line type so that if we change the generic annotation in here, we're not changing the generic annotation for everybody. But let's just change the generic annotation line weight here. And the way we do that is we go up to Manage and Object Styles over here on the left. Object Styles. This is where you can get to the line weight of these categories. You can change colors, line patterns, things like that too. We need to change the size of the lines for the symbols. So we want to just go down to annotations. We want to go down to generic annotation. Generic annotations. And right now it's set for 1, which is the smallest line type. I like to punch these up to about 4. And I'll leave it black and solid. So that, as you can see, it makes it nice and thick, and it stands out a little better when we print it. So there, I think we're ready to send these around. I'm going to start with this room, which is we've got the kitchen, and this is a dining area. We're going to call this kind of a kitchen island, which isn't exactly against the wall, but it's close enough where I would think that an inspector, someone reviewing this, analyzing this would say that this is not an accessible portion. We can't get back here to plug things in. And this is a permanently mounted cabinet. If this was just something on wheels, it'd be different. But this is permanently mounted cabinet, so I'm going to consider this all part of the, part of the wall, not behind it. So we're going to start at this edge, and the basic idea is to be not more than 6 feet away from the end of this wall. Well, how do you measure that? Well, you can start using dimensions if you want, but then there's nothing left to dimension it to. We can dimension it from here to our receptacle, and then you can move the receptacle around if you want to get that. That's one way to do it. So that's under 6 feet. Give it a little extra room. I don't like to be right on the edge. Another way you can do it, let me get out of that, is you can simply go to an annotate and just draw a detail line. And so I will typically just draw a detail line, and I'll come out, 5, 6, 5, 9, something like that, to give myself an idea. And then I'll place a receptacle. So that will put the receptacle not further than 6 feet. Now, the next thing is, what am I mounting this to? I've got it on a wall, but what is this thing here? So let's go ahead now and draw a section. Double click it. Now we're looking at that south wall, right in the middle of the cabinet. Now this is where you may want to change the view from electrical to what we call coordination. That will change the look of it. So it looks to me like we have window. See the glazing? We have window all the way to the floor along this. So that's going to be fun for our receptacles. So that's what I was afraid of, is that we have window all along this entire living space. Well, it looks like the owner of this building gets to invest in some floor outlets. The other thing you can do is you can hang an outlet from the ceiling on a cord, but I don't think that's going to be the preferred option here. So we are going to be getting into floor outlets. So now what do we have for floor outlets? Let's go up to the insert, and right here you can load a family from your network, from your local hard drive, wherever, or you can jump over here to load Autodesk family from the cloud. So this will link us to Autodesk's families. They have quite a bit here, and this used to get loaded onto your computer in previous versions of Revit, but now it's just online. So let's go to electrical. Now, I covered a lot of this in my other video, which I'll link above, which covers a lot of the out-of-the-box content you can get from Autodesk. And I covered that there's an architectural tab, electrical panels, there's a floor box, outlets, things. Warning against using architectural families, they do not typically have electrical connectors built in, so we can't connect them to our circuits. They're purely for visual. So let's get back out of there. We want the MEP type of families. Now we have standalone connectors. If we want to just connect something and not actually place a physical model, we may use those later. And then we have power, and this just narrows down the search. So we have appliances, fans, hair dryers, hand dryers, heaters. We may need fans for our mechanical equipment. But for now, we're looking at terminals, which they call receptacles, devices, things like that. So we have receptacle countertop, disconnect, double pole, duplex receptacle, top switched, emergency switch, high voltage. Do we have a floor box? It looks like we do not have a floor receptacle. We can see if the architectural floor receptacle actually has power. Let's load that and see what happens. Now, where is it? Let's see. Outlet floor. Well, because it came into electrical fixtures, this might be promising. And there, let's us put it on the floor. We click on it, you get no power connection. That was my fear. And you go to edit type, there's no electrical connection. Now, this may be an opportunity to actually edit a family. Either way, to get a floor box, we may have to edit some family. So we can either edit this architectural family and simply add an electrical connector, which I think may be the chosen route, or we can create one from scratch. That's much more advanced. I think what we'll do is we will eventually just edit this floor box to have our electrical connector. for now, we're just showing receptacles, so we're just going to leave it as is. So we can get rid of that guy and put this one in instead. So there's a floor box. If you hit space a number of times, it rotates it. And it has to be, by code, within 18 inches of the wall. So we'll just put it there for now. This is just, as we know, diagrammatic. We're not dimensioning these. A lot of times an architect will come in now and dimension this for us. Let's go to the next one and keep moving along. In general, we're going to be measuring not more than 12 feet along here. I don't see any operable doors out of this first floor, so we don't need to worry about watching out for doors. So we're going to go all the way around this with our receptacles. So I'll end up speeding this up so you don't have to watch every measurement. But I do my typical, let's measure 12 feet. Let's go to about 11. And I can now just copy this. And then I have to go around the corner from the wall. So I'm here about 3 feet. So I have another 9 feet I can go. So let's go about 8.5 to be safe. Now we get to the hallway. There's a different code rule for a hall, in that if the hall is longer than 10 feet, you need a receptacle. So we know we need at least one receptacle in here. I like to go above and beyond sometimes, just because I've seen halls done so poorly. I'm going to copy this guy 12 feet, roughly here. We can use a standard receptacle now that we actually have a wall. So let's drag that back in the duplex standard and get that in here. We can center it on this wall. Again, these are all design decisions that you'll have to make. There, so we have receptacle, there. That should cover that area. Now, these, as we saw in the architectural model when we looked at episode 1, click on it. For a linked model, I'm just hovering over it and hitting tab to get to it. And eventually you get there, and then you can see that this is, and it doesn't drop down, but it's a piece of furniture, so it is not a built-in cabinet that I need to worry about. So we got that. Now let's work on the kitchen. Now kitchens are tricky because we don't always know where the appliances are. Even the architectural plan that we looked at did not point to things and call them out. Some architects will do that, and I think that plan may, not be completely ready for bidding or construction. So there's a few things missing. So we will have to do our best here. It looks like if we hover over it, we get a little bit of note. If you read that whole pop-up there without clicking it, generic models, Mealy induction cooktop. So that's a cooktop. We need a receptacle for that cooktop. Now, we don't know the electrical specs for that cooktop. We don't know if it's a 120 volt, a 240 volt. Is it, 30 amp, 50 amp, what is it? So you may need to get cut sheets from your architect. You may have to go out and find it yourself based on a model number. For my purposes, right now, we're going to assume that we looked it up and found out that it is just a 30 amp 2-pole cooktop. So a 30 amp 240, we're going to say that's what we looked up. Now, how do we get a 30 amp 240 volt outlet in here? I'd already downloaded a special purpose receptacle. That's from that Autodesk site. And let's see what that does. Drag it in, and you can see it's trying to latch onto things, but it is a face-hosted receptacle as well. And we're eventually going to mount this to this back wall of this kitchen counter. So right there, let's click on that. Let's see what that is. It's surely a different symbol, and comes in at 1'6". We can leave that there. It's going to be behind. But what is it electrically? It says 120 volt, 180 VA, which is kind of a standard receptacle load. It's single pole only. There's no choice for 2-pole. So this is just a standard receptacle that with a different look. Now we need to find a receptacle that we can make 2-pole 240 volt. So that's not it. What do we have? Load from Autodesk. And we're going to go get away from this architectural because, as we saw, it doesn't have connections. MEP, electric power, terminals. You don't know what a clean receptacle is. Countertop, we can look at that. And a double pole switch, a duplex outlet we already have. This is a duplex outlet, top switched. High voltage receptacle, let's try that one. And eventually one of these switches, quad receptacle. There's a 220 volt receptacle. That might be promising. We'll have to see if it's 2-pole though. So we already have special purpose. So let's bring those in. So simply bring those in and they will populate over here in our project browser under electrical fixtures. So let's look at this 220 volt receptacle, see what's going on here. Pull that in and it's got a nice different symbol. And sometimes you find there's something there in the model that causes this. It may be a column, who knows what it is. So you may have to find somewhere else to do this and then drag it over. Sometimes I end up putting a receptacle here, dragging it in. Let's look at it. 220 volt single. Well, that's more like, I would say, like a European type of connector that's just line to neutral, single pole, but higher voltage. So I think that's what that is. And we cannot change that. It's hard coded into that electrical connector. So again, this doesn't work. I do like the symbol. So now we're into a high voltage receptacle. Let's try that. It looks like a standard receptacle as far as the symbol. They've filled in the middle, which for our firm means above the counter standard receptacle. So here we have a symbol issue that we have to deal with. If we're going to live with Revit built-in, we're going to have to live with their symbology. And we can just call this out with a note. But let's take a look at the electrical. This is looking better. 240 volt, 2-pole. See, the number of poles is a parameter that we can change. So we have access to this. Luckily, it's already set to 2. And it's 240 volt, which is what we want, line to line. And then the load of this, we decided that if we're using a 30 amp outlet, well, 30 amps at 240 is like 7 kW. Let's say that this thing is, we found out this is a 5 kW, more like a dryer, because it's just a cooktop. So we'll say it's 5 kW. So now we have our cooktop. Now, as far as tagging this, we would need a tag that reflects a parameter within this. And let's see what we have for tag for receptacles. Question mark. Let's see what that is. This is a electrical device panel tag. Well, we don't have it assigned to a panel. And then we also have an electrical device circuit. So we can either tag the panel or the circuit is all we get out of the box to do this. Now we can look at other tags in the load from Autodesk. And if we go to all results up here, annotations, there's lots and lots of tags. So electrical tags, annotations, where's our tags? Down at the bottom we have wire tag and wire tag panel. With panel and circuits. Well, we may want that. Let's load that one. But let's see if we have anything about, we have conduit, capture, conduit, tick marks. If we have anything for electrical equipment, let's look at equipment. Electrical equipment tag, electrical equipment type. That's equipment, not fixtures. Electrical device circuit. Electrical device panel. So device circuit, device panel are what we already have. Now here they're calling it device, not fixture. Electrical equipment tag. Here's an electrical fixture tag. So we don't have a tag that will tell us anything about that receptacle. So we're just going to have to tag this with a text. So we'll just call this cooktop. And we're using the built-in 3/32 aerial. And then we can extend from here, click on it, and up here we can get to the leaders. So we can use a curved leader. Architects use those. I like to use this one. Nice straight. We've got the shoulder there. So something like that. That's the cooktop. Now, what else do we have for kitchen equipment? I like to pull this section, now that I have, up to here so I can kind of treat it as an elevation. Now, one thing about a section is you'll see this dashed line down here. That indicates the extents of the section. We can pull the sides in, and we can pull how far in it sees in the section. So I'm going to pull this in so that I only see inside the house. Look at this section. Well, not much to see. Now there's this up here, which is interesting. Let's see if we can, what is that? Built-in range hood. Well, that's good to know. We have a hood. So we'll need to connect that as well. And then what else do we have down here? There's our cooktop. I don't see any other appliances shown. So we will just make sure we get the hood. Now, how can we show the hood? We didn't bring in the motor connection, which I need to do. So let's go back to that load family. We're going to be in here a lot. We'll go to MEP, electrical MEP. And we're going to go to appliances. Let's bring this fan in. We don't need hairdryer, hand dryer. Let's bring the fan in, and that may give us what we need to hook up the hood. Now, again, this looks to be a face-based family, so it's looking for a wall or a surface to mount. We're going to mount it on this surface here, right there, and that's their symbol. So you get what they give you. I use a different kind of symbol, a circle with little wings on it for a motor, but this will work. And let's see if it has the proper connections. Right now it's a single pole. It does have multi-pole, so we can use this for a 240 volt equipment if we need to. Maybe we have a condensing unit or something outside that we need to hook up. But right now, and let's change this to, we typically do a 120 volt nominal connection instead of 115. This is set up load classification as an appliance dwelling unit. Again, we're going to be calculating this project like it's a commercial project, just for demonstration of a commercial job, not using the residential. But for a commercial, we would apply something like a motor to this. So I'm just going to call this motor. Other times you can call this an HVAC. And for exhaust fans, things like that, I like to call it HVAC, but I think this is not specifically HVAC. This is more of just a motor. And the demand factor for a motor, just to show you how that works, 125% for the first one, and then 100% for any more attached to this circuit. So that's good. And then our load on this, you know, we would have to look at equipment cut sheets to figure out the load on this. It's probably going to be a very small fan. I'm going to give it 100 watts. So there's that. And we can, again, we don't have an equipment tag made. It just tells circuits, not type. So we're going to have to use dumb text tag. Again, another reason for having some custom content is to get tags that actually tag, for example, the type mark of this. There's a hood. And then the other things we want to hook up here are what's on this other cabinet. So let's drop another section. And I'm going through this detailed piece by piece just for instructional purposes. If you want, go ahead and scrub through this and get to something more exciting. I knew this would be like this, showing every step of the way. So, tab over that, it's a dishwasher. Tab over that, it's just a sink. Okay, that's just the hardware for the sink. What's that? Someone left a cup. That's a vase. Okay, so we have a dishwasher and a sink. So we're going to assume the sink has a disposal. Now, these are all things that you can coordinate with your architect, or if you have a, plumbing designer, HVAC designer, things like that, kitchen consultant, you can do all the consultation with them to figure this out. I'm just going to show you what happens once we, if we knew what the loads were. So here's the dishwasher, kind of. Now, the dishwasher just gets a receptacle underneath the counter. So we need our standard receptacle. I can go down here and find it, or I can also find the one I already have, right-click, create similar, and put that guy down here. Now I want it to be on that cabinet there. Now this also assumes that this cabinet has a back wall deep enough for receptacles. So now I'm under the counter here, so it may not be an issue. Now, when I get above the counter, that might be an issue. We're going to assume that this will get adjusted to be deep enough for a box. We want this to be a special load, not just a standard receptacle. So I'm going to call this a dishwasher. Now, the way I do that is go over to Edit Type, because right now I just have a standard. I can go Edit Type, and I want to duplicate this and give it a new name. I'm going to call this dishwasher. I do this, created a separate type so that I can modify some of these type parameters. I want to change the load. I want to make this 500 watts for a dishwasher. Load classification. I can leave it as receptacle, but I'm going to call this equipment. And what's the demand factor on equipment? It's just 100%, which is fine. It's not on full time. And it's 120 volt. So now I have a receptacle. Now, when I connect this up to my panel, it will use the 500 watt load, 500 VA load, not the standard 180. So that's why it's separate. And again, we want to put some kind of a label on this. Won't be a smart tag. I use all caps. You can do what you like there. In commercial work, this is how I typically work. So there's the dishwasher. And then we also want to get a disposal down here. So let's do this again. We're creating similar from here, the standard. Get that here, and we'll call that disposal. Again, let's edit that and call it a different type. Disposal. And, you know, some of these can get pretty big. I've seen some that are half horsepower, 3/4 horsepower, pretty good size. So we're going to get it up there. Let's put it up around 800 VA. And we'll call that equipment also. $120 volt. So we're assigning separate loads to all these different kinds of appliances. Again, treating it like a commercial project. We'll just call this a small commercial project that looks like a house. So we have those appliances. Now we're going to finish the rest of the appliances. I think we have some stuff over here. Again, we can move this section over to that wall. And it shouldn't matter that I look through the wall here because I can change it to a coordination view, which acts more like an elevation. So there we go. That's nicely elevated. This guy looks like a refrigerator. Let's tab over it. And there he is, master cool, fridge freezer. This one ends up being a microwave, and this guy ends up being a oven. Okay, so refrigerator, again, you start looking at specs on these things. They typically, can be around 800 to 1,000 watts, depending on how big it is, maybe 1,200 watts. We're going to go with 800 for now. The oven, I'm going to figure at a full range power of a full 50 amp, 240 volt outlet for that guy. So that'd be more like an 8, 9 kW. And then this microwave, they're typically down around 1,200, 1,250, up to 1,500. So again, we are hooking up typical appliances to typical loads. It's never exact because people can change these out in the future. I'm sure you've changed out your oven or your dishwasher at home, possibly. So we just have to get close. Now, with these guys are stacked, so we're going to have to show receptacles. If we show them stacked, they won't look right, so I typically show them side by side. There's a way to show them stacked by applying an offset, which we can show, for example. But what do we want to show here? Let's go to our refrigerator first. It's a standard 120 volt receptacle. And I'm going to show it connected back here on this back wall, back in here within the cabinetry. It may get, in reality, may be pulled out to a face here, but for our purposes, diagrammatically, this works. So we're going to have that attached to that wall like that. And a lot of people like to put refrigerator receptacles higher than like 12 inches or 18 inches above the floor. So we can say that too. So for example, we can here put a little plus 48 inches just to signify that if you want to put a height. And let's make this a special type of receptacle. Duplicate that again, and refridge is enough. It is 120 volt. We'll call it equipment, and we'll give it a load of, let's go 1200. This is a big refrigerator. That tagged with a dumb text. And then up here, these are one standard and one special. Our range is going to be this guy, the 240 volt outlet. So let's get that in there. Let's go here and call this range. We're going to make that more like a 9,000 VA. And we can call this electric range 3.5 to 8. We're close to 875. We can leave that there. How's that calculated? That's a commercial range type demand factor. So we are just going to leave it as equipment because I want it fully calculated. 2-pole 240. There we go. If anyone knows the joke, 240, 241, whatever it takes, let me know. So that's the range. And then the microwave, great, similar. Get that there. Now, like I was saying, I could stack these, and what I could do is I could take one of these and see this offset from host. There's two different things. There's an elevation from the level, and then there's an offset from the host. Now, the elevation we could also change for this microwave, put it up at 5 feet. This guy is going to be a duplicate type called microwave. We're going to put him clear up at 1500. Equipment 120 volt. And let's put that up. Well, it's default. Actual elevation is going to be at 5 feet. And that's a microwave. Get a tag on there. Get a leader on there. Okay, now let's go back and fix this cooktop that I failed to name properly. We can just rename this now to cooktop. So that looks like our kitchen equipment is all in. Now we need to fill in with the rest of the receptacles that are required. Again, look at the NEC, you'll see that there's requirements for how many receptacles, and then when we get to circuiting, there's requirements for how they get circuited. For now, we're just going to show receptacles. The basic rule is, it's similar to the 6-foot, 12-foot rule. It's more of a 2-foot, 4-foot rule here. You have to be within 2 feet of the end of a countertop, and then not more than 4 feet between them. And anything that serves a countertop has to be ground fault, GFCI protected, things like that. And you can indicate that on here if you want. Sometimes people just rely on the electrician to follow the codes when they install those to be the type. So right now we're just going to show these as receptacles and let the GFCI and furthermore tamper resistant, arc fault, things like that be more of a specification driven, things like that for now. We're mainly looking at the circuiting aspects of this. So let's get some more receptacles now. I typically use this for a countertop receptacle. What do they have for countertop receptacle? They use the CTR. Okay, we'll use what Revit says. We're going to go with the CTR. And we need to be within 2 feet of the end of that cabinet. 2 feet's right there, so we'll stop where we are right there. And let's get this copied over. At not more than 4 feet, which looks good. We want to be a little bit away from the sink. So I think a couple receptacles here will do the trick. Now this guy's underneath, but we still need receptacles on top. So let's mimic what we have here. We have one there and then one within 2 feet of there. And back to the microwave. I was trying to show some offset and I forgot. So we can offset it. Let's go 2 feet. And you can see it pops it out from the wall so that I could actually stack these on top of each other graphically, but the receptacle is still on the wall at the height. So we can try that for now. That's one way to get things lined up properly in 3D, but not be obscured in 2D. And now let's finish up this countertop down here. We're going to mirror what we did up there. It's a very similar layout. And 2 feet and 4 feet. And again, we just get close. We make sure we have the right number of receptacles. Architects will often on their plans, their architectural plans might do some elevations with some dimensions because they get picky about such things, which is good. And that does that. Now let's go into the mechanical room. Let's say we've talked to our mechanical designer and they've decided that they're going to have a furnace in here. So it's just a 120 volt, 20 amp circuit, they said. Create similar for this fan, and it's hosted, so we have to find a wall, put it on the back wall. We will call this, they're calling it the furnace. And we're going to call that one actually HVAC, just so it schedules separate. And this guy is going to be a full 1500 watts on a full 20 amp circuit, not a 15 amp circuit. That's the other thing we'll deal with is residentially, you'll see a lot of 15 amp circuits. So we'll go 20 amp there. And in the bathroom, we want, now it doesn't show the sink. One thing you can check to make sure is that we have plumbing fixtures turned on in our model. And go down here to plumbing fixtures is turned off. Try that. That's in our model. We also need to make sure that plumbing fixtures are turned on in the linked architectural model. Plumbing fixtures are off. Now, why that toilet showed, it must not be a plumbing fixture category. There's the sink. This guy is generic model. That's why it's a different category. It's not a toilet category. Okay, so now we have the sink. I like to get the receptacle either here on this side of the sink or on the other wall. We just have to be within like 3 feet of the sink. So we will get, now I call it above counter mounted because it's high. So we'll use this symbol right there. It kind of overlaps the sink. And this is one reason I don't use labels built into receptacles is because they're turned upside down. I typically will just show receptacle and I have a different symbol, but if I need to add a label, I will just put it as text. Now the laundry. I think we already looked at these and the architectural model determined that that's the washer and this is the dryer. Now a washing machine gets a standard 120 volt receptacle. So we can use this guy. Put that back here for the washing machine. Again, we hit something, so we want to find clean wall and then drag it in. That's for the washer. And it's going to be, again, residentially, codes say we use a 1500 watt circuit. For the laundry room, washer itself, and other things in the laundry room. And then we need to have also a separate dryer circuit. So this guy, we're just going to call, again, a mixture, a hybrid of load styles. Duplicate. We'll just call it laundry. And do we even have a laundry? We don't have a separate laundry. So we'll just call it equipment. And our load, we're going to put at 1500. Again, we're going to calculate this like a commercial project. Now the dryer is a 240 volt, 30 amp outlet typically. So we need another 240 volt outlet receptacle right there. And we will call this guy duplicate dryer. 240 volt 2 pole. And we're going to call this electric clothes dryer. Look at that. What do they have for demand factor on this? Less than 4 or less. Less than or equal 4 or less is 100%. So that works. Again, commercially, if you have a lot of them, you get some diversity. And this guy is also a 5,000 watt load for that 30 amp outlet. And let us put some text on these. Washer and dryer. We can move our tag around, which is nice. Washer and dryer. Now, we may also like another receptacle in here for an iron. So let's go ahead and do that with just a standard receptacle and get that. Looks like, now that wouldn't be a window, maybe a very high window. So I'll put it on the wall. Now what's happening is I've got a grid line right next to my wall. So the receptacle is trying to grab onto that grid line. So what I need to do is make sure I'm hitting the wall. Now, when things are stacked in Revit, remember you use the tab key to drill down into it. So if I hover here, hit tab, you see it pop up there. Now it's actually using the wall, not the grid line. So click on there, and I'm going to drag this underneath this window. So now we have a convenience receptacle in there as well. I think we've got this room taken care of for receptacles. One thing I haven't checked is to see if we have anything on the ceiling that needs power. We can check for that later. For now, we're going to look at the living room. And we've got some steps. These are steps because this, as you recall, is a sunken living room. It's about 2 feet deeper. So anything we put on the walls is going to be really kind of the wrong height if it's based on the level 1 height versus the level 1 living room height. So we're going to have to deal with that. I'll show you how we deal with that. We want to start our receptacles. We need something for the TV. Now we can just put a receptacle here. We have to be within 6 feet. This, I would say this is the end of the wall for this living room. So let's put a receptacle, create similar, on that wall. And within 6 feet. And it looks like we're good. Let's just check the distance here. Yeah, 5 feet, that works. Right now, this is hosted to the linked Revit model. It's hosted to level 1. That's up here, 2 feet higher than the level we need. Now, we can't host this to the level 1 living room because we did not copy that. If you go back to episode 1, we did not copy the architect's level 1 sunken living room into our model. So we actually need now to link that in so we can relate these receptacles to it. So how do we do that? We go back to an elevation or a section. We can do it right here in the section. You'll see our levels. And I'm going to grab my levels and grab it here, not at the circle, and then drag it out so I can see it. So we have a living room, and let's change the scale list so we can actually see those. We want level 1 living room. We need that. So we can just copy this and draw over it, or we can do, again, copy monitor. That was under collaborate, copy monitor, select the link, hover over the linked Revit model, click that, copy. I don't need multiple this time. I just need one. And I can't get to it out here. I have to be here within my boundaries of this view. Click on level 1 and it's doing its thing. It's copying down here, processing. And then since I don't have multiple, I don't need to finish there. I can just finish the copy. Now I have a copy of that living room, level 1 living room, and it put it in as feet and inches instead of metric. Drag it over so it lines up with that. Now I have level 1 living room that I can utilize in my model. So back to my plan, back to this receptacle, click on there. Now I can change the level to level 1 living room. And what I should have done is put my section down there. Let's drag this around. This is just so we're just using it for our purposes of design. So here we have our elevation of this wall. Now we can see our receptacles are still high, even though we associated them with the lower level. Well, the reason for that is, and let's look at this, just because we associated it with a different level doesn't move it. It just changes the dimension. So now it's elevated from the level by 3'3" and this crazy fraction of an inch. So it didn't move it. It just is hosted to a different level. So now we need to manually put this down. And I have these at the 1'6" dimension, like commercial ADA receptacles. Now, if we look at that section, we can see it's down here. So as I create new receptacles, I want to make sure I create it from this one, which is set up to be hosted to the lower level. So let us look at the rest of these. In this room, we have some more windows. Let's check and see if these are clear to the floor windows again. They are. So we're going to be doing some more floor boxes. This is wall. This may be window. Let's cut another section. Window all the way down to the floor. Okay, so that's what we have. Now this guy, just looking at this, we have doors, so we don't have to count the door as part of our distance. We can start at the edge of the door. And what do we have for a distance between these? We have 10 feet, which is less than 12. We can get away with a single receptacle here. Now this is, let's look at what this thing is. I think it's a fireplace. It is a fireplace hang. Not sure if this is going to be very accessible, but we'll put one here. I would say a fireplace is typically permanently mounted. So we may be best to go ahead and put receptacles and add additional receptacles on either side rather than hide it behind this guy. So I'm going to go that way. Now we need to get our floor box from up here, create similar, and we're going to have to relate that to this level. So turn it like that. We'll put it right here, and let's get that hosted to living room level. Now, because this is hosted to the floor surface, it automatically is still at 0. It wasn't wall hosted. And we can just copy this. If we're not putting something on a different level or something, we can just do a standard just copy. And it will still be hosted, and it's still at 0. I tend to use create similar a lot just to make sure that it hosts properly. So we've got that, and we have 5 more feet, so we can go 7, but let's keep it a little bit short. Put that guy there. Now this is again where we have a grid line in the way of our wall. So hover over the grid line, hit tab. Now we are on the wall surface. And we want to copy this not more than 12 feet away. Wrong, we need floor boxes. So 11.6 is a good, careful dimension. Get this down here. And if we want, we can line that up with that mullion and still be within our 12 feet. And we can move this a little bit because it was 11.6. But we're getting down to the inch here. And then what do we have from here? We can go 11.6 to that. And that truly is a wall. So we can create that on the wall. Not the, let's tab out. There we go. And how are we doing for distance here? We may need another receptacle. If it's further than 6 feet, it is 7'11". Yes, we do. So get that down, and I don't like to put it right at the corner. Let's get a couple feet in so it's actually useful. But that wall needs two. Now we can just mirror what we've done over here. Now, are we on the grid? It looks like it's not trying to hit the grid. So we're okay there. We'll put a floor there. Let's get another. Now this is a different layout. I'd go 6 feet from this step. Right at the edge. I think that will still give us 12 feet. And get this floor receptacle over here. So that does the living room. This is all just furniture. Now, if we want to try to, put some floor receptacles in here for tables and such, we sure can. And, we may talk to the owner architect and see if that's something that's desirable. But for now, we'll do the minimum. The other thing is, do we want anything outside? Do we have any outside appliances? And typically outside appliances, are like gas. Commercially, we have to put in some interlocks and electrically controlled gas valves and some timers, things like that. But residentially, it's much more lenient as far as that goes on gas. So we may still want some receptacles outside for convenience, an exterior mounted light or something like that. So I'm going to at least get one receptacle out here. And tab for the purposes. And those would end up being weatherproof and GFI. And we can tag some of that stuff later. Or again, we can let some kind of a written specification do that or let code drive that. And before we finish up, it just occurred to me that when I created this similar, I did not check to make sure that I put it at the level 1 living room. We're still at level 1 because this one was hosted to level 1 when I created similar. So a couple things we can do. We can either go through and change each of these to the proper level and change their height, or I can actually create a plan view at the lower level, model my elements from that plan view, and it will still be available in this plan view because it's all part of the model. So let me demonstrate that way to do it. So I think best practice here would be for us to go ahead and create a lower level floor plan. Now we go up to view, plan view, floor plan. We don't have one created for level 1 living room yet. And this is just a standard floor plan. Say, okay. And we need to give this the proper view template, because view template also arranges it into our project browser under the proper headings, disciplines, subdisciplines. So let's go to our power plan, 1/4 inch. And we don't need to worry so much about cropping this and all of that because this is not going to be what I would call a production view. It's not going to be a sheet view. It's just for placing. It's kind of a working drawing. So I'm going to call this, just to get it numbered here, let's just call it 3 lower living room working. So it's just we don't want to rename the level. So just lower level living room working view. So now what we can do is get rid of that. If we create similar now and put it in the same place we had it before, and we have to tab again. Now this guy is hosted to the level 1 living room at 1'6" above it, because that is our current work plane. So we would do the same here. Now this guy, because it hosts to the floor, it's a face-based hosted family. We can merely change it to the proper level and it is still at the floor. This guy, well, he will need a new one. So I'm going to delete these. And because we're on the same face, we're on the same wall, I can actually just do a regular old copy. And let's copy that one. And we can see that we're within 24 feet. Copy that and then get this guy down here. We already made sure this one was on the lower level. This one is on the lower level. These guys are on the wrong level, so let's get rid of those. This one needs to be moved. So again, this complicates things a little bit, makes it a little more tricky to have this different level, but it's a good exercise to understand how to deal with these different levels. So we're going to create similar roughly across from that one. And it should host to the level we are on. More copies. So this is finishing up this plan. And I would say the same thing with these exterior receptacles. We're on the same wall, so we can just copy. And actually, these are a code requirement to get receptacles out on a porch. So that's another reason to put these out here. So that takes care of the level issue. Now we want to go back to our actual first floor level to go back to the kitchen dining. And what I realize is that this back of this counter is actually going to be considered a wall space within here. So we are going to need to treat that just like a wall. So we need to be 6 feet from the end of this, wrap around the corner. So we can include the corner as part of the 6 feet. So we have a distance of just over 2 feet. So if we're within 3.5 feet from here, we should be good. So I'm going to put one right in front of this. This is just a stool that can be moved around. But let's go ahead and copy our receptacle to here. And again, here we are. Here's our grid line, the same old issue, tab through that. And then let's copy this within 12 feet. And we're good there at this one. So that should cover us in this room. The only other space would be if we need one here in this kitchen. Lately, I've been just playing it safe and adding a few extra receptacles. I would rather have a little bit extra than, especially in the work where you do the design and someone else installs it. You hate to have all these change orders and things added later on. So I'm just going to put that in there to be safe. Now that guy wants to host on the back of that wall. See right there, it flips over. Here it doesn't. So again, there's something in the model that's invisible right now, but it is affecting where that receptacle gets hosted. So that can drive you nuts sometimes. So let's find a place that works and then drag it down. And that should cover us here. And that should complete this level. So I'm going to stop episode 2 right here with just getting level 1 receptacles and appliances connected. I think level 2 is going to be much faster because it is bedrooms and bathrooms. Hey guys, welcome to episode 3 of the full project residential Revit Electrical series that I've got going here on this channel. In this one, we're going to cover a little bit more of the view range changes we need to make for this project. And then we're going to finish laying out receptacles and HVAC equipment for this project to get it ready for circuiting. So stay tuned for more. So we left off episode 2 here in our first floor plan power. We got all of these receptacles installed. And the next thing we would like to do is work on the second floor power plan to get those receptacles installed as well. So double click that. And the first thing you will notice is that we have the devices from down below showing through on our second floor plan. This will happen once in a while on a project, and you'll have to deal with what's called the view range. Now, we looked at this earlier and set the view range up for a cut plane, top and bottom, but that was for the first floor. If we review this, what we actually ended up with, we tried a few different things, is we ended up needing the bottom of our view range, if you recall the picture, down at the level below so that we could show that sunken living room. And that works fine for that view. But now that we show the level below on second floor, well, level below, if we look at our elevation, level below level 2 is level 1. So we see all of this space between level 1 and level 2. So we need to fix that. There's a couple ways we can deal with this. And so this is good practice on dealing with the view range, which can be quite an issue on some projects. Okay, so back to the first floor. Because we have this sunken living room, we do need to see lower, at least in this area. We do not need to see lower in the entire view. View range affects the entire view. So we can set the view range up for just this normal level 1 view, and then we can apply a separate view range just to this sunken living room. So let me show you how to do that. Let us reset up our view range for this view template for just this first floor view. So go down to view range, edit this. Instead of level below, we're going to set the bottom to this actual associated level at 0. And the view depth, we don't need to see below our first level in this case. Now, again, in some cases, on a first floor at least, you may want to see under the floor. You may want to see underfloor conduits coming in. That would tend to lead to a separate view template just for level 1. In this case, we're not going to show that, so we're going to have level 1 and level 2 be the same. So we have associated level from the bottom, and the view depth will also be, because view depth is how much below the bottom do we want to see. We don't want to see any of that. So we're going to say it's also the associated levels. The bottom and the view depth are at the associated level, which is level 1 in this case. So there. Now, as predicted, we cannot see the receptacles in the sunken living room. Go up to view, and under plan views, you will see this thing near the bottom called plan region. I'll point to a video link up above for a whole video I did just on view range and plan region. But the short story here, plan region allows you to set up an area that you want to apply a different view range to. So this is perfect for this sunken living room. So we are in a sketch mode because you see the little check and the X marks here. And our plan region can be a rectangle. So we will use the rectangle tool and just select a portion of the project that is sunken lower. Now I'm going to call this, these are steps. The bottom step is where I'm starting. And I also want to include the walls in this. So I'm going to do that. And then I'm going to drag it. And I do want to include this porch area as well. So I'm going to be a little bit outside like that and say, okay. Now I could have set up the view range there, but let's go back and we can get to this. It's a dash line. Over here, you'll see it has its own view range. Edit that. And this is where now we can set up just this plan region to have a different lower level. So instead of saying just level below, we get absolute levels. We want to select level 1 living room as the bottom of our range and the view depth as well. And those are all no offset to those. Hit OK. And now our symbols show back up because this view range is set up differently. So that is a very common way to apply a different view range to different areas of your project. You may encounter a school, for example, that has a gymnasium that's very high compared to some classrooms next to it. You can use the plan region to increase the height of that view range to show your lights up at the top of the gym. So that's a very common technique, and it doesn't mess with our actual view template. Now we can see the second floor, which has that view template applied, is correctly showing nothing below. So we fixed those problems. Now we can get right into adding receptacles to this bedroom level. And we can move these room names around like that. So let us see. Like I mentioned before, we're going to do basic NEC code locations for receptacles, and we'll cover some of that. I talked about that in episode 2 a little more and gave you a link to a good resource on YouTube. So let us find our receptacles. We're down here at duplex receptacles, standard. And let's start showing these. Now, as we talked about, we need to be within 6 feet of the end of a wall. Well, that also includes any wall that is 2 feet or longer has to have a receptacle. And we can check dimensions of this guy with the dimension tool, or like we did before, we can go to annotate and draw some detail lines just to get an idea how long this is. That's 2 foot, just over 2 feet. And this is out here, this is 1'6". So we have 3 or 4 feet. It's not long enough to require 2 receptacles, but it indeed does require 1. So put this at a reasonable location in the center of one of these walls, typically. Let's go here. Now along this wall, we have to start our 6 foot dimension from this edge of this doorway in what looks like a closet and start counting 6 foot maximum from here. So let's look here, and we have roughly 3 feet, and then we can go another 3 feet. So let's put one a little short of 3 feet. Right click. First of all, let's make sure this is the right height. We're good. We're at level 2 and we're 1'6". Again, I'm showing these at commercial 18-inch height. You can put them down at 12 inches for a residence if you want. Create similar. Get this guy right here. Get rid of our line. Now we have the rest of this wall. Let's see what dimension that is. We're beyond 6 feet. So we're in a position where this full wall is a little longer than 12 feet, so we need 2 receptacles. Now, I'll call your attention to this guy. This is a pocket door, and so that's a door, of course, that slides into the wall. It is not enough depth in here to actually recess a box for a receptacle. Choices are you could go a surface box or you could go with a floor receptacle, but in reality, since this is not more than 6 feet deep, we don't need to put one within this 3 foot door length. We can put it just near it. So we could put this guy right there. And then the other one, anywhere we can put, I'm going to put it on this wall as well. So we have a couple places to plug things in this little hallway if you want to set a little table and a lamp right here. Whatever you like to do. We do not require receptacles in the closet, although I will note that a lot of times, at least in apartments, you may get some kind of a media cabinet in here that would need a receptacle, so keep that in mind. Let's continue on with this bedroom. We have a window, and this is where I use my section again, which I already have drawn. Let's use this section and see what we have upstairs for windows. Now we need to make sure that my section is looking far enough, so if I click on that, I can see that the dashed line of the depth of this section does not include this wall. So I won't see that window. So let's get this down a little further. And again, these sections are just for us during design. I'm not dragging these sections onto a plan. Go back to that section that I already hit. And let's see where we are. It's good to have an idea. Let's pull this in a bit so we're only looking at our room. That helps us to narrow down our view. You can do it here, or you can actually do it in the section. You can get to this crop. If I click on the crop, you'll see a dot that I can drag around and narrow it down. I like to do it in the view so that I really know what I'm looking at. So back to this section. Second story. Let's get up to the second floor, just to help us remember where we are. Okay, so that window comes clear down to the floor level. Good to know. So we cannot put a receptacle here unless we did something like a floor receptacle. We're going to try to avoid that. And actually the window counts as part of the wall. So we start here and we have to be within 6 feet. Looks to me like we're going to put one right here in this corner, either down here or on this wall. You can take your pick. And we run into what we did on episode 2, where we found this grid line is trying to host our receptacle. Hover over the grid line, hit tab, because tab will drill down through all the stacked lines. And now we're hosting to our wall. There we go. And I will put this a little bit of ways. And if you have any trouble getting to here, you can sometimes just go down to another portion of the wall, put it there, and drag it over. So I'm going to drag this near the window instead of around this corner. And then we can go up to 12 feet away with the next receptacle. So what do we have here? We have 10 feet and then another 2 feet. And I'm going to stay a little bit short of 2 feet just to be safe. I can put a receptacle around this corner. However, that's looking like window again to me. So let us get a section in there. I have one looking that way. I could take this, and there's a little flippy left and right button that I can use. You can see that the head of this turns around. I can do that. I can drag this over. Instead of creating a bunch of sections, I can do that. And I'm making sure I'm looking at this wall. Let's see this section. And get up to second floor. Try to isolate that so we can see it a little better. Okay. This is all glass. This is glazing. It comes clear down to level 2. So this architect likes full height glass walls. Okay, so we're going to need floor receptacles in this case. I can avoid one in this area by keeping my receptacle down on this actual wall. So that's what I'm going to do. Create similar. I'm going to put it in a little bit in from that wall. Use my tab to get past the grid line. There he goes. It does mean I'm a little further to my next receptacle. So let's see what we have for distance here. We're only a foot away, and we can go up to 11 feet away with this. How far is the door? Okay, so we are going to have to put one here. So that's within 11 feet. I'm going to put one right here at this mullion. And instead of trying to find my floor receptacle, which is not that hard to do here, I can also just go to first floor. As long as I have second floor open, go to first floor. I can simply right click on this, create similar, and then pop over to my second floor and place that. So there's a number of ways you can get to these things. So there's that, and I'm within 6 feet of the end of this wall, which the door creates the end of the wall. So I'm good there. Now let's see the rest of this room. Starting at this wall here, I need to be within 6 feet. There's 5, 7. Again, does this window hit the floor? I'm not even going to look. I'm sure it does. So we will put a receptacle. Instead of going floor, we're going to put one right here at the edge. And let's see, is there a grid line? There is. But it looks correct, so I'm going to place it there. What do I have for dimensions? We have 15, 16 feet to the end, so I will definitely need another receptacle here. Let us put one in the midway. As you're looking at this wall, it'll be kind of in the middle of the wall. And then this is, again, an outside porch, which is going to require receptacles. So let's get those out here. I'll put one here, and let's just say for convenience, we'll put another one down here. And tab to make sure that we are on the wall. So this room looks good to me. Let's look at the bathroom. Now we have a tub. For now, we're going to say that it's just a regular tub that needs no power. But we do have a sink, so we need to get an above counter, a higher mounted receptacle. Back on first floor, let's find what we have. Over here in the bathroom, we had a counter height receptacle. And as a reminder, we are using as much as we can the out-of-the-box Revit symbols and devices. So this was their symbol for counter-mounted receptacle. As long as we indicate this symbol on a symbol list with our project, which we will do in future episodes, then we're golden. As long as your symbol list matches what you're doing on your plan, you're good to go. Unless you start getting into custom symbols, which I also show how to do. I'll point to one of the videos above that shows how to create some custom symbols and content for your models. But for now, we're going to use the out of the box, and we're going to right click, create similar, pop back to second floor, and put this on the right or left. I don't see a compelling reason for either one. Let's just put it right here. So that's really the only receptacle we need in this restroom. And again, we're going to rely on some written specifications or some notes elsewhere to remind the installer to make GFCI type receptacles where needed, tamper-proof receptacles, arc fault breakers, all that kind of thing. We're going to handle with some general notes so that we don't have to try to indicate all of that in the plan. Okay, now this bedroom will be similar, and I will start laying these out, and then I'll have the video speeded up a little bit so you don't have to watch every little decision. But it's the same process, measurements, and placing of receptacles. So 1, 2, 3, 4, 5. Bedrooms typically need 4 or 5 receptacles, you'll find. In the bath, we have an issue here with this sink. Let's right click, create similar. I like to put it on the side wall of the sink. And while I'm here, let's do the side wall of this sink. And this bedroom will not quite, it looks like a mirror, but it's not really because it has different walls. And so each bedroom has to be figured out individually. And if you're really trying to min-max this thing, you'll stretch these as far as you can with 12 feet, but I don't think there's a problem having one extra receptacle in a bedroom. If you've ever been in a bedroom that doesn't have enough receptacles or in the right place, you know exactly what I'm talking about. So that's roughly 6 feet. So yeah, we're going to be further than 6 feet from this guy, so we're going to need 2 receptacles on this wall. Let's get them something like this, try to make it usable. Now, what's our issue here? We have no grid line, and it's a little bit away from that wall. So something there, see, something's going on. Once we get up here, we have a little different graphic. So let's get to the point where the work's on the wall, and then we can drag it down. So something like that. 1, 2, 3, another 5 in those. These are good sized bedrooms. Okay, that's the bedrooms. Now, let's look at the entry hall. Looking at codes, you find out that if a hallway itself is longer than 10 feet, it needs a receptacle. So we need at least one in here. I think for usability, it makes sense to put a couple. So I'm going to put one. I have a lot of sliding doors. I could put one at the end here. And then I think another one in this entry would be nice. Now, hallways aren't just for plugging in a vacuum cleaner, for example. Sometimes people will set little tables along the wall and put a lamp on it. So you need to think about that as well. If it's a wide enough hallway, that might happen. Now, this hall here, definitely somebody could put something along this if they wanted to, but it's not required by code to have these. So again, make your judgment call on what you want where. This happens to be a walkway over to the driveway. So we don't require one out there. And you don't require any in a stairway. This is an outside terrace type patio. Now, this could be considered, a balcony or patio. So I would get a receptacle out here for that reason. So let's put one right here on the wall. Now, another thing we want to look at up here is some equipment needs. HVAC, HVAC needs. Now, again, we don't have a mechanical or HVAC design done for this project, but on most projects, you will have that, and you'll refer to that. You can either link the model in if you have that, or refer to the PDF documents that they have and cut sheets. So we're going to say we have all that information behind the scenes, and what we found out is there's going to be an exhaust fan in each bathroom. So let's go back to our fan. We have standard. Now, this fan from Revit is hosted. It wants to host to a wall, which is, I would say, unusual for a piece of equipment. Usually they're floating. We can put them anywhere we want. But in this case, we're using their built-in. So we're going to put it right here. And because sometimes the fan will be near the shower, near the toilet. So we'll get this guy right here, at least for now. We can move the room tag around. And we will call this, we're going to duplicate this so that we have separate type parameters like load and load classifications that we can apply to it. So we want it to be its own type. And we'll just call this bath fan. Something like that. 120 volt, single phase. Load classification. Now, I like to classify these things something like HVAC. Say OK. And then the apparent load, these things are typically small. We'll stay with 100 VA for now. Say OK. And we've determined from previous episode that we do not have a built-in tag to tag this piece of equipment with its name. So we have to use dumb text. Again, another reason why we create custom families, so we have more variety. But for here, we're going to do this. This is an out-of-the-box project. So we will say bath fan. Get that in here and point to this with a leader. Add a leader. And we can adjust the shoulder of it. Something like that. We will need to do the same thing down below. Create similar. Let's get that fan right here. We can also use copy here, or we can Control C and Control V, copy paste, move it around. You can drag the leader over to the other side, or you can also use the controls up top and remove the last leader and then add a leader to the left. So that's sometimes a shortcut. You can move this around with a little move symbol. So a lot of variety of what you can do with the text. Bath fan there. And we need another one in the master bath. Right click, create similar. And we're going to say that this bathroom ends up having 2 fans in it. So we'll get that. Copy this from here to here. Swap it over. And sometimes you need to move this to a different room. Whatever works drafting wise for you. And we're going to have another bath fan. We'll say it's out here near the shower. Create similar. You can retype it yourself. You can copy it. Lots of options. Get this master bath out of the way. And like so. Now the controls for these fans, many times you'll just have a switch on the wall, and we can do that. Or it may be switched with the lights. So we will deal with the controls for these fans when we get to the lighting plans. And just know that we are only showing device layouts right now. This is kind of a preliminary layout. You might call it a schematic design, design development. Those are the fancy terms for this. But a lot of time architects may only show this much. They may just show a layout and not go further. We are going to go further as the electrical designers. We are actually going to circuit these things up to a panel similar to a commercial project and assign loads that way. We will also do a load summary in the residential way so you can see how those contrast with each other. One other thing I just realized we haven't addressed is on the first floor, we also have a bathroom, and we need to get a bath fan there. So let's right click, create similar, back to the first floor, and let's get that bath fan. And let's get that labeled. Let's say our HVAC design put a fan in here. And let's say that this one is a different wattage fan, a different kind of fan. So let us create yet another type because we want to change some of the type parameters. So we need a different type. Let's go laundry fan. And let's say it's a little bigger, it's 200 VA. So we've created a separate type for that. And we will label this guy. Click this, hold out. Seeing this section line reminds me that when you print this to a PDF or to paper, you have the option to not show these section indicators if they are not actually dragged onto a sheet. There's no need for this to print with an empty sheet and detail number. So that will not actually show up in our final print. So don't get concerned that this line cuts right through our words and such. It's not going to show up. Like I say, unless we turn it into an actual section or elevation that we want to show up. One more piece of mechanical equipment that we need to show is the cooling unit that goes with the furnace. I also noticed we did not label this furnace, so we need to label that. Again, in custom symbols, we would have a tag that does that for us. And I'll point to a video up above that shows how we can create custom tags and make them show the parameters that we want. So we're going to say the mechanical unit is located outside, and let's say that they just put it out here. So we will show, create similar, get that on the wall. So I think this is a foundation and the actual wall is here. So we will do that. Edit this. Again, it needs different type parameters. It's a different piece of equipment. We will duplicate this and call this condensing unit. And you would look at a cut sheet for the unit you're dealing with, and it's 2 poles. Revit considers 240 a 2-phase connection. Even though it's line to line, and sometimes we call that a single phase, it's really phase to phase. So there's 2 phases involved. Revit deals with it as a 2-phase connection. It's HVAC, and then we're going to say this is, it's like 3,000 watts. Apply that. And we will call this condensing unit. Like that. Okay, guys, I would say that we have our receptacle layouts done for both floors. So next time, we will jump into laying out our lighting. Before we circuit anything, I want to get all this laid out. Hey guys, this is Rob and welcome to episode 4 of the Residential Electrical Revit series. In this one, we are going to cover how to circuit these receptacles that we installed, how to find and install a 122/40 volt split phase panel board, and how to connect these devices up to it. We'll also show how to start drawing a single line, one line diagram of our system, and how to more efficiently do that. So if that interests you, stick around. Let's get right into it. So here we are again in our residential tutorial electrical project that we are treating like a commercial level of development. And we have already placed receptacles and equipment connections for the first floor and the second floor. So we've already got all those placed. And now we are going to look at getting some of these things circuited up to a panel. This is where the real magic of Revit can shine in an electrical project, is the systems that we create and connect all of these together to form calculations and load summaries that we can use to size things. So let us get right into placing a panel board for this project, or since it's residential, we can call it a load center style of panel, which are typically used in residential. The details are, instead of having a bolt-on circuit breaker like a commercial panel board, it is a plug-on circuit breaker for residential use. It's a cheaper panel. Electrically, though, it's going to just have a set voltage phase and current capacity. So let's see if we can find one of those. In this example project, I'm trying to use as many of the built-in Revit families as I can. In our commercial work, we use a lot of custom families. In fact, that's kind of the first stepping stone into getting into Revit, is to get your families created and customized. But in this case, for learning how to use Revit and connect things together, we're going to use what it comes with as much as we can. So let us go look over here at our electrical equipment that is already in our model. And we started with Revit's built-in template. So there's not much in here. There's a transformer, Ethernet switch, we're not dealing with that. And we've got 2 panel boards. Now these are typically 3-phase panel boards for commercial use. 208 is a 3-phase voltage for commercial, and so is 480. We are looking for a 120/240 volt split phase panel, which is common in the United States and elsewhere in North America. So we need to find a 120/240 single phase split phase panel. So let's go up to our insert. And remember, this second load family is Load Autodesk family. It's got a little cloud in it. This is where we can get to the out-of-the-box Revit families that used to be loaded into your hard drive when you loaded Revit. And I have a whole video, which I'll link a card above, that shows a lot of these different families and what's available. So if you go into all results, you'll see that you have a lot of categories. We'll go down to electrical, and then remember that there's an architectural electrical section for architects to use in their designs, which does not have all of the electrical connectors that we need. So we were going to skip past the architectural and go right to the MEP section. Connectors, power, appliances, distribution. Now we want distribution. Go to distribution. And you will see we have transfer switches, circuit breakers, switchboards, starters, a bunch of things. So we want to go down, lighting and appliance, and if you hover over the name here, you can see the full name right here. That's a lighting and appliance panel board 208. That's what we already have. It's also an MCB, main circuit breaker. Well, we don't have one of those either. If we're doing commercial work and needed a main circuit breaker, we would load that. We have lighting and appliance 208 surface. So this one, by not saying surface, means recessed. So there's different families for different types of mounting even. This one is a lighting and appliance 208 main lug only, MLO. 208, 480, 480, 480, 480. Now we have a metering switchboard, motor control center, more commercial industrial work, motor control center, our good old round plane junction box. Look at this, single phase panel. It says 120 volt, main circuit breaker, recessed. Well, other than the 120 volt part, we do need single phase, even though it's going to be 122/40 split phase. They call it single phase because it doesn't have a third phase. Revit calls it 2-phase. And this one is a 120 volt main circuit breaker surface. So it sounds like these are typically made for residential use. We're going to take the main circuit breaker version because we need a main circuit breaker in our house. Let's load this into our model. It'll pop up down here under electrical equipment, and there it is. Single phase, 120 volt. Let's hope it is just mislabeled. Now, before we drag this in, we have to figure out where is this thing going to go. A lot of houses have a garage attached or separate, and many times a panel or load center will be placed in that garage. It's a very common place. We don't have a garage. In fact, let's look at this site again. Let's go up and 3D view it. Up here up the top at the quick axis, you can go to default 3D view. Click on that, and it pops you into a 3D view. And you can change the appearance of this. Down at the bottom, you can go to what level of detail you want. And architecturally, it may not show much of a difference, but if you go down to fine, you'll see you get a little more refinement. Let's say on these solar panels, you'll get a little more detail. And then also you can change whether it's a wireframe, hidden line, shaded, colors, or realistic. Right now, I think it's set on shaded. If you go to wireframe, it's indeed just a wireframe, and you can see right through it. And you can see a lot of our electrical boxes in here that we placed already. But we want to look at more of what does realistic do? It takes a while to render a realistic. And it'll apply things like materials and lighting and all of that stuff to make it more of a realistic view, maybe for a rendering. Architects use this to provide their 3D rendering of the project. That took a while. And so it'll probably take a while to pan around it. So I'm going to go back to just shaded, which I find is enough for our purposes. We just want to get an idea of what this place looks like and what we have. So we have, looks like kind of a narrow driveway coming into probably just a parking area. There's no structure here, no garage. So it doesn't make sense really to put the panel out here and have to run, think of all the branch circuits that have to run into the house. Plus this is outside, it would need to be weatherproof. That is not a great idea. We need to put the panel in this house somewhere. Now this is all part of the kind of a water collection system. We don't want it out in here. We don't want it outside. Let's find a place inside. Now, the trick is this has to be coordinated with your architect, your interiors people, with your owner for appearance. Not many people want to see that panel face right when you walk into the building. So second floor is where we enter from this raised walkway. So that's the main entrance to the structure, second floor. So a panel in this main entry hall would be unsightly. You don't want to put it in a bedroom or master bedroom. Sometimes apartments will have one thrown in a bedroom, but in a house, I find it best to put it in more of a utility space. So what do we have on the first floor for utility spaces? We have this mechanical space, but we already have a furnace in here, and we found out from our plumbing designer that there's going to be a water heater in here that we need to add. So that's not a good place because looking at the NEC, you need clearance in front of a panel board to service it and maintain it. You have to have safety clearance, working clearance in front of that. So we need a place that has some clearance. This will be full of equipment. So it cannot be located in a bathroom, but this is actually a separate laundry room, which should work. The panel door has to be able to swing at least 90 degrees open. We have to have clearance. So what I'm thinking here is this wall right here facing into the laundry room would be clear. Yes, the washer is accessed in the front, but there's nothing going to be really sitting here. There's no clothes hanging here in front of this. We can't be in a closet. Any of the rest of the laundry functions would happen in this area. So I'm going to declare that the panel can be located right here on this wall facing into this laundry room. And it is nice and close electrically to a lot of the equipment. The kitchen has a lot of equipment and it's close to there. So this makes it an economical choice. Now, we also have to think of how power is going to get into this panel from outside. And back to the 3D view we just did, we don't have information for where power would come into this site yet. But let's say that we talk to our utility company and we find out that there's a pole on the street. They'll set a little transformer out here nearby for us. Let's say they're going to put it somewhere it's somewhat flat because they don't want it on a grade. Let's say they'll put it here. So it's going to come from out here and it needs to hit a meter. Now that meter location is something we also have to deal with. It has to comply with utility requirements for reading the meter, access to the meter if they need to work on it, change it out. So it needs to be outside. Now, if the power comes from out here, the meter is rated for outdoors, so it could be placed somewhere out here. And the meter typically has to be on the front of the house, along the side, within 5 feet of the front. There's many different utility rules for this. So we're just going to say, for the sake of this example, that the meter is actually going to be located out here on some kind of a strut riser on this wall here so that they can walk up, read the meter. So we will hit from the transformer to the meter, and then from the meter we will go into our panel board. We will deal with the site electrical later, but we just want to make sure that this is feasible. So let's go back to our first floor plan. We're going to come in under the slab so that we have to stay outside of the building. Again, a lot of code rules here. We have to stay outside the building, and under the slab is considered outside the building, and then up into our panel board. So long story short, we're going to put our panel right here. We're going to put a 200 amp panel right here. Now, you want to make sure that you have the right selection up here. It is a hosted family, which means it has to attach to a wall, hosted by a wall, and a vertical face. If you place on face here, it's trying to place it on the floor or ceiling. Place on face typically means a horizontal face. And sometimes here, look, it's placing on top of that washer. We don't want that. Place on vertical face, and then you'll see that it's recessing it, kind of like we did receptacles, but it's recessing it into the wall. So we need to keep a little bit away from the end here because there's usually a stud on the end of this if you look at the construction. So we'll place it somewhere around here. And the built-in panel board from Revit doesn't have a door, doesn't have much of a symbol, it's just a box. But it serves its purpose. It will let us connect things. Let's make sure we have the right settings in here. So click on that, and there's a bunch of settings over here for a panel. And this is single phase panel 120. Now, let's go look at this. It is electrical data 120 volt single phase. You don't often see a 120 volt single phase panel. We want to see if we can modify this to be a 120/240 split phase. We see that we cannot change this electrical data. It's built in. There's nowhere here. The distribution system, in fact, is none because we don't have a 120 volt only distribution system in our model. In fact, let's look at that to make sure. If you go up to Manage, there is MEP settings right here. And go down to Electrical Settings, and this has a bunch of settings that you deal with as you need to as you get more advanced. And these are typically set up inside the template that you end up using. So let's go to Distribution Systems. Now this shows the built-in distribution systems. We can always add more. Right now it has a 120/208Y 3-phase 4-wire for commercial use. There's our 120/240 single 3-wire system, split phase. So it's 240 line to line, 120 line to ground or line to neutral. So that is what we use for residential. So that's good we have this in here. And then there's a 480 3-phase 277Y system. Now, in other commercial jobs, and I show this in a separate video, we have to add a 120/208 single phase system if we have apartments because they are 208, not 240. That's a whole nother story. But we're good here. We have the right one. But we do not have a 120 volt only single phase distribution system. So this panel out of the box does not work. Let's see how to fix that without having to go into the editor. So let's go to Edit Type. Maybe it's a type parameter. If you recall, all of these in here are called instance parameters. If we had two panels in here of the same kind of panel, these could vary between them because they're related to just that one instance. So let's go to the actual type. 225 amp is the type. Here are the parameters we can change. Luckily, we can change the panel voltage and the number of poles. So we're going to make this 240. We need to get the line-to-line voltage. It's 240. Number of poles, it's 2 poles. It's 2 phases. So again, Revit calls this a 2-phase panel because it has 2 lines, 2 line voltage phases. If you recall, split voltage has 2 hots and a neutral. So this is a 240 volt, 2-pole panel. Now here's a bunch of dimensions, and it includes different heights. Default elevation was 4, and we can move it around. So now we have the voltage set up. Let's go make sure that applies down here. So down here, electrical data, good. 240 volt, 2-phase, we're set. And look, it assigned the proper distribution system automatically when we set it up properly. So we are set now for 120 and 240 volt connections. Let's give this panel a name. And not many people have a name to their panel in their house, but we will just call this, let's just call it panel. Some people call it the breaker box, the fuse box. So we're going to call it a panel, even though it might be a load center style construction. And then we're going to move this out of the way, and I'd like to put a tag on this. We had to use dumb text labels here because there's no tag. Let's see if we have a tag for a piece of electrical equipment like a panel. So let's go up to the tag by category shortcut up here and click on that and see what we get. And look at that. It pops up with the name of our panel, which we called excitingly panel. There's that. It has a leader. Now we could get rid of this. We could put this in without a leader, go to the tag, and then up here at the top, you can deal with leader. You can undo the leader, and then when you put it in, it just centers it on the panel, and then I pull this out right in front of it. So that's another way. And is actually tagged so that it's a smart tag. And this is what we want as much as we can in Revit, is for the tag itself to relay what is the information inside the family that we tagged. So if we were to change this to P1, apply, you see that the tag automatically reflects that change. We can also change it here in the tag. Go back to Panel and click on this family, and you will see that the name got changed to Panel. So these are interrelated. They are tied together, and that is a huge benefit in Revit as we change things. We only change it once. So the panel is set. Now we can start connecting our equipment. Hey, and if you find this information useful, I'd love it if you hit that like button down below to help propagate it to others. And if you want to stick around for more electrical only Revit videos, please hit subscribe and even leave a comment if you like. Now we have a lot of standard 120 volt receptacles. We have some 240 volt equipment. How do we connect all this? Now, I'll mention again that there's a lot of NEC, National Electrical Code, rules for residences or dwelling units, as they call them. So again, I'm not trying to teach a whole code class here, but just remember that what you do here has to relate and comply with the National Electrical Code and any local modifications that you may have in your state or even in your city. So I will point again in my description below to a great YouTube channel for Ryan Jackson, who covers a lot of NEC things and specifically has a 3-part video series on residential receptacle type codes. So you can check that out if you want to learn more about those codes. But the basics are, in a kitchen, for example, let's start here. We have to have 2 small appliance branch circuits that service the countertop equipment and can also service things like the refrigerator. Now, you can go above and beyond those 2, but nothing else can be on those 2 circuits. So one tool, we already used the default 3D. You can also use the second one called Camera. Now, it drops a kind of a perspective view of what we're looking at, but you can do that inside. So I'm going to hit Camera, and let's say I want to take a picture of this kitchen. Now, where's a good point? This happens to be a giant column in the middle of the room, so that's not good. Let's take a picture from way down here, and we'll click it, and then you aim where you want to look, and it's showing your field of view. Aim clear down to past the end of this kitchen. There, that's our kitchen. Now, it's a mess. The default view is an electrical view where you can see through the walls, and you can see all our equipment. Now, we can change that to different kinds of views. Go to shaded. So that makes it look a little different, but I want to make this so I can't see all this through the wall stuff. One easy way is to go up to the discipline up top. It's electrical. Just go to coordination, and that will change settings if you hit apply. That'll change all the settings so that the walls are not transparent. So there we go. And that really shows what our kitchen looks like. It's a nice view. You can also hit F8 right here, and you can use the look tool right here. Click on that and hold it down, and you can drag around and look around your model, and you can even drag it off the screen. And so we can look around and see what this thing looks like in 3D, which will really help to visualize the space you're dealing with. You can even apply a walk, but I warn you that if you barely move the mouse forward, like just creep it, it moves fairly quickly. So let me go just a little bit beyond my circle, and you can see that I can do a slow walk through this. So this gives you another good idea of what's going on. You can also do sections, elevations, but I find that this 3D view really helps. And it depends on how well the architect did at modeling, of course. But you can see our cooktop here that we hooked up. You can see our dishwasher. This helps to find those appliances that we had to find last time. And there's this hood that's sticking down from the ceiling, exhaust hood. Hit F8 again, we can look around. This shows that we have these 2 countertops that I'm saying we need to get circuited. We could share, we could put one circuit on this countertop and another circuit on this countertop, which is probably the most efficient way to do it. And let's go that route. I mean, you could split 2 circuits between them, but let's just go with the separate circuit. So back to first floor. So here we are with our countertops. And these are our out-of-the-box countertop receptacles. Let's get started by circuiting these up. We're going to hook all 4 of these countertop receptacles up to one circuit. Well, how do we do that? If you click on one receptacle, you will see the power button up here. This creates a circuit. Think of it as connecting upstream. If you're thinking about your panel's the top and it feeds down to the receptacles, so the panel is upstream from you, we're connecting an upstream connection. So we can click on this, and then we can edit the circuit. Well, right now we just need to connect it to a panel. We can select the panel visually by hitting this, clicking on this, and then find the panel in the model. And our panel is close enough where that may work. The other thing we can do is just hit the drop down for panel. Now, panels that have the appropriate distribution system set up that we can connect to will show up in the drop down. If this was a commercial job and we had 480 volt panels and 208 volt panels, only the panels of the voltage of the receptacle, the 120 volt panels, 120, 208 volt panels would show up in this list. So that's an indication also that you have things set up properly. So we can, again, click on that. Now, if you've already hit power and you re-click on it again, you can't get to the power button again because it already assigned that to a circuit, even though you haven't picked a panel. So go back up to the electrical circuit box. Now you get this box again. Let's go to panel and let's set our panel called panel there. And it put a little blue little arrow thing on it, which ends up being a home run symbol, the arc with an arrow, which we will add later. Right now we've connected this receptacle to a circuit in the panel, and this is still highlighted. Over here you can see that I'm on circuit number 1, and it's set up with a breaker type connection. The load name, the name that will pop up in the panel schedule, is just receptacle. I like to name these here because it's easiest to do while I'm connecting things up and I remember what area of the building am I in. So I'm going to call this receptacle kitchen. So it's one of the kitchen circuits. And then you can set ratings and frames here for that breaker. Kitchen circuits, or small appliance branch circuits as they're technically called, must be a 20 amp circuit. You'll have other circuits in the house that'll be 15 amp. This is a 20, so leave it as 20. We don't worry about wire types and all that kind of stuff right now. So we will just get the load name and the rating of the breaker and all that right now. All this can be changed later, but I like to do as much of this as I can as I'm going. I find it easy to do as I'm circuiting. So that's great. Now I could just be done with this and have that circuited, but I want to add the rest of these receptacles onto this circuit. Now, when I already have this highlighted, I can simply go to this electrical circuits and say edit circuit. And then it automatically pops up with add to the circuit. So now I'm in add mode and I'm in kind of a sketch mode, adding, and I can just hover over. You can see these receptacles are somewhat grayed out if they're not on the circuit. Mine is a little darker than these are. So this means that these are not on my circuit. But as I select and click on one, it darkens. Now that's going to be added to my circuit. So I'm selecting these receptacles that I want. And I find this a nice, easy way to do this. And when I'm done selecting those, finish editing the circuit, and now they're all connected. Well, how can I tell they don't look any different now? The way you can get to a circuit is to hover over something that's on the circuit and then hit tab. And sometimes it takes a couple hits, but when I hit tab, you can see that the little help button, hit tab again, says electrical circuits. I'm actually hovering over the circuit, not the receptacle. So now if I click, I have selected the circuit, the little dashed blue arcs and the little blue arrow. And over here it says electrical circuits. So now I know that I have selected the circuit. And up top now I have the option to add an arc or a chamfered wire to this. Now they call it wire. It's really conduit or a cable, a multi-wire cable in this case. But they call it wiring. So if I click on that, Revit will automatically connect these with arcs. Now, if that's the way you want to show your plan, this works great. We do a lot of arcs in our commercial work. I think it helps to convey what's on what circuit. The other thing you can do, of course, is have no arcs and just put a tag on each receptacle to say what circuit it's on. So either way. Now, I must say that Revit doesn't have a built-in circuit tag for a receptacle, so you would have to make that. But in this case, we're going to use arcs. And you can modify these arcs. I mean, modifying the arcs is kind of a whole trick in itself. You can change the center point of that arc, so you can bend it to whatever kind of shape you want. And you can actually add more of these points. If you right-click on it and say, Insert Vertex, it will put another vertex. Now I'm going to say where to put it, right there. So now I have another grip for a vertex. So I can make this complex if I need to get around something. If I'm going around, a lot of times outside the house, you want to go around corners to show lighting. You can bend this to your will. Now I can also get rid of a vertex, right click and delete a vertex. Let's delete this one. And now I'm back to a single vertex. You can change where this attaches to the receptacle. Now it's hard to see with these thick lines. So oftentimes I will jump up to the top to this thin lines button. And if you make it thinner, then you select it. Then the little circle shows up a little better. And you can move, that's the attachment point. You can move it around. So if for some reason I was going across this aisle to this other one, I could, move this where I want it to hit on here. Personally, I like an arc to be kind of like that. I like it to hit as if it's going to the center. Where would it intersect the outside of the circle? Again, you'll probably have your own standards you want this to meet. You can make it show in the middle if you want. I showed at the edge, but a lot of options. Now there's a plus and minus here. This would be for adding conductors inside this cable or conduit. Now I have this set up in my options to only show wires on the home run back to the panel. But you can set this so it shows wires everywhere. But even on this home run, if I click on it, there's a plus and minus. I can add additional hot conductors to this. It would automatically do that for multiple circuits in one home run. But even in my case, if I had, let's say in a bedroom, I had some of these switched and I needed a switched hot and a non-switched hot, I could show multiple hots. So you have the option to show additional hot wires in there. This is the ground symbol. You can change it to different symbols if you want. We just use the circle. So that's the home run. And even the home run, you can move this around how you want, change the shape of this arc. Lots of variety. I like to try to point it somewhat in the direction of my panel board. That's my preference. Some places do things differently, and there's a lot of variety here. So there, I have that circuit. Go back to normal lines. Now I want to tag this home run to indicate what circuit this is. Again, you can tag each receptacle if you have the right tag, but we have a built-in tag for this. So let's go back up to tag by category and see what the default tag is. Right, click on that. It puts all in parentheses, panel-1. Maybe that's not the way you want to show it. And I'm going to change this panel name just because I think it gets confusing being called panel. So we're going to put it back to P1. That way we know that we're getting the name of our panel. Do we have options here? If you click on that tag and go up to properties, you'll find that there's sometimes multiple types of wire tags. So this is a wire tag panel, and this is just a wire tag. This wire tag is just the circuit. Now this may be more appropriate for this residential project when we only have one panel. So I think that works. If you want different kinds of tags, I'll point to a video above that I've done on customizing your tags. You can have different kinds of tags for the same kind of equipment, or in this case, for the home run, you could have different kinds of tags that you choose from. But that's the basics of wiring. And so we're going to go through here and just wire this place up. I'll do the other kitchen the same. I'm not going to go through all this here, but let me show you a 240 volt connection. Let's review this cooktop. Over here, edit the type. We set this up for a 240 volt 2-pole connection, and we set it up as a 5 kW load. So that's set up. Now we just need to power it up. Here's the power button. Power it up. We want to go to panel. Remember, it's the last panel you connected to. So that's P1. And there's no other receptacles on this circuit. It's only going to have the cooktop. So we, from here, can easily just say, arc that wire. One thing I forgot to do is put in all the data here. So escape out of here. Again, if I hover over this receptacle, hit tab, and this is going to take a couple tabs before I get my circuit. Now I'm hitting the circuit. See, it says electrical circuits 2.4. Now I can click on my electrical circuit, and I'm editing this. The breaker type is a connection. Now, it could be a feed-through lug, things like that, but breaker is what we want. And then again, I'm going to call this receptacle cooktop so that it's labeled on the panel schedule, and it's going to be a 30 amp connection. Apply that. And then I want to move this home run away from this and get this arced. And if I need to, I can move where this guy hits. This is adjustable. Now, the only trick is if this guy was down here, you've got to be careful because this little square is the actual electrical connector point. And you don't want to pull a wire off of that because then you lose its connection, you lose the home run, and this wire is just floating in space. So you have to be careful that you leave that guy connected to the receptacle's connection point. But there, I'd put our two hots in there and our neutral. And let's label this. We changed this tag after we installed it. So it still remembers the default tag. Now you can change the default tag a few different ways. If we go to annotate, here's the tag panel. So if you go to the tag dropdown right here, loaded tags and symbols, you can take a look at all of the tags that are loaded and set up as default tags when you tag by category. Let's go down to the wiring. Wires. Wire tag panel was that one that has the panel and the circuit. We want to change it to wire tag by default and say, okay, now we set the default for when we hit tag by category. Now we get our little circuit tag that we can drag around. The other thing you can do is if you have different kinds of tags and you want to be able to choose between different ones, you can just find a tag you like, right click it, create similar, and you will create that tag also. So a couple different ways to do this. And once you've attached the tag, then you click on this and move around. The tag goes with you. So there. You can go around, decide how many circuits you want. We're going above and beyond what is typically shown for a house. Usually the electricians take a plan like this of just receptacles and they will apply, it's a design build type thing where they will apply the circuiting and divide things up. But, in-house, they would probably have to produce a plan like this showing the circuiting. So that's kind of the level of detail we're going to here is we're showing the actual circuiting for the receptacles. The loads for these receptacles aren't done on a per receptacle basis. They are done more on a square footage basis, but that is the basics of how you circuit this up. Now let's take a look at the panel schedule that Revit automatically fills in for us. And that's another huge benefit to Revit for electrical is that it does our panel schedules for us. No more Excel panel schedules. So if we go under the Analyze tab, it's under the Analyze tab. It's kind of an analysis of loads is the way I think of it. That's why it's up here. Schedules are analysis. If you go to panel schedules right here, click on there, and panel schedules are created using the default templates. Now there's templates for everything in Revit. There's panel schedule templates. So it's listing all of our panels. We only have one, and it's put in check mark. Yes, we want to create a panel schedule for panel P1. Say okay. And it made it, and it brings it up for us. So it uses the default panel schedule, which looks like this. This can be customized. In fact, what happens is some of these panels are too wide when I throw them on a sheet, so you can narrow them up. And that's a whole nother lesson is how to edit panel schedules. There's also separate schedules for switchboards and other kinds of equipment like that. But we're going to stay with the basics. It's a 12240 single, It calls it single phase here. Revit gets confusing because it says single phase here, but as you saw before, when we clicked on the panel, it showed a 2. So it depends on where you look. You have to understand that it's a single phase 3-wire system. Mains are rated 225, and we may end up having just a 200 amp circuit breaker, which is the case for residential. And what it did is it circuited up our circuits that we connected in numerical order. 1, and then it went to 2, 2 and 4 because it's combined. Next one would be 3, then it would jump to 4, it's already filled, jump to 5. That can also be customized. In commercial work, we like to circuit 1, 3, 5, 7. We like to go this way first and then jump over to the other side of the panel. Again, there's ways to set all that up. We're going to go with the default for now. And the other thing it does is it gives you a load classification at the bottom by load type that we set up. And we have these all set up as receptacle. Now, we could change the cooktop to be more of a range type connection so that it would show up separately. It also applies a demand factor. Now, right now it's just 100%, but commercially, if you end up with over 10,000 watts of receptacle, it'll only take 50% of the rest. So that's all done for you as well. But anyway, this gives us a running total of how many amps we have calculated commercially on this panel. And we already have our 30 amp trip set up. In our 20 amp, we have this name set up. That's why I do it when I connect them. So that shows how the system is interconnected between loads and panels. Another thing I'd like to show is a diagram of this electrical system. Now, residential, again, it's very simple, but it's still worth having a little bit of a single line or one line diagram. So how do we do that? Let us go up to a drafting view. Now, we don't have any drafting views here because we need to make some. There's none out of the box in this template. So let's go up to view, and you'll see here, there's our plan views. Here's drafting view. Drafting view is a view showing details that are not directly associated with the building model. They're just like dumb lines. It's like CAD. That's what we're going to do for our one-line diagram because there's no way in Revit to automatically generate a one-line diagram. Now, I must say that there are third-party applications that you'll find out there that can produce a one-line diagram from your model if you want to go that route. And that may be good for you. There's licensing and all that for those things. So if you just want to do your own, you can just draw your own. They need a name for this drafting view. I'm going to call it one line diagram. Now, some people call it single line. Same thing. And it applies just a random scale. I like to just go these at 12 inch to the foot, 1:1. And there's my blank drafting view. Not much to it. There's no symbols in Revit for doing single line diagrams. Like if we go all results, even if you go to annotations and go down to electrical, you'll find a number of switches, a lot of tags, conduit size tag, conduit fitting size tag, receptacle annotations, but you won't find any panel board or switchboard or circuit breaker, any kind of symbols that we can really use in a one-line diagram. So we just have to draw it ourselves. You can either draw it, like for example, if you go up to annotate, we're in annotative mode now, and go to detail line. Over here, you have a choice of different kinds of line types or line styles that are built into Revit. And right now there's not many. We have a thin line, a wide line, an MEP hidden, a medium line. These are all built in. Medium line seems to be okay. Now you can create your own line styles, but for now we're just going to use, again, out of the box, medium line. And then you have a number of tools that you can use to draw these lines. And you can just start drawing lines, or let's create a box. We want to create a one-line symbol for our panel. You click here, and then you start drawing, and it's giving you some dimensions. Now, what size do you want this? Well, if you look at a piece of paper and you want a panel to be a certain size on your sheet, you don't want it huge. We're talking real units here, real inches. So I like a symbol that's maybe a 1/2 inch wide. So you have to zoom in to get that small. A 1/2 inch wide, and it's kind of giving us some dimensions at the bottom, and it's going by 256 of an inch, which is pretty fine. You can change that around too. But the further out you go, the less precise it gets. So there's a 1/2 inch. And then I want 3/4 down. So 1/2 inch wide by 3/4. You can also just draw this, click on it, and then you can click on here and change the dimension to 3/4 inch. That's sometimes easier. And let's throw some text in here. Now this tells you how you can justify the text. Top and then left justified. We can also go middle, up and down, aligned middle, a middle, aligned bottom, and we can center. Let's go ahead and do top, but let's do a center. And let's put that here. And let's write panel. Put that right here. And then we need a name for that panel. Again, we're going to be centered. Let's call it P1. So there, panel P1. That's our panel. And then we can draw detail line. I just clicked on the line tool, which is default. I'm still in medium lines. And I can go up here. And we're going to say that the meter, the self-contained residential meter, is here. So we need to draw another symbol. So go to text. And let's put an M somewhere here. And then we can draw a box around it, detail line, use our square, use our rectangle tool. Now, if you get too close to a text, the text itself will blot out your lines. Unless you go over here. Now, here's the text tool on the right. You'll see that there's a few different types. We have 3/32 aerial and a 1/4 inch aerial built in, and there's something used for a schedule. So we're going 3/32. This, like most things, can be changed. You can create your own type. We can go to X, edit type, duplicate this 3/32 aerial, and we will call this 3/32 aerial, and it applies a 2 automatically. I'm going to call this transparent. And we can change the background from opaque to transparent and say, okay, there's a bunch of other things here you can do. Okay. Now what that does is it makes the background opaque so it doesn't obscure our line work. The other thing we can do is make our box bigger. Or sometimes the meter will just be shown as a circle. And when you're selecting these lines, you have to make sure you're not selecting the text. You got to get in here and it highlights. If you hover over a line and hit tab, now you will select the entire chain, it's called, of lines. You can delete that. Let's put a circle in. Say we decided our symbol is a circle. So center it somewhat there. Draw a circle. And there's a minimum size, like this is too small. Minimum size you can draw. Let's just draw it like that. And now this is all pieces, so if you want to window it and move the whole thing, you can move pieces. Like that. And then we want to draw, we can right click and do create similar for this line again. Get it somewhat close. And now we want to go out to our transformer, which is, we're going to say it's a little pad mount, like a ranch runner they call it, little 120/240 pad mount. So we can draw a symbol for a pad mount transformer. And so we can do something like, let's just say like this is the pad, and then we will do some lines to make it look like a pad mount, whatever symbol you want to use for this. Some people will use an actual kind of a transformer symbol that has windings and the core and all that. You can draw whatever you want. This is simple. So that shows a transformer to a meter to a panel, and then we can apply notes to these things. We can call this utility transformer or utility pad mount. Now again, this is being left justified. I can change this back to that. This is still center justified. I can change it to left justified, or actually when I create a new one, I can make it also left justified. You can stretch your window to make this fit how you want. And then also, if you click on there, up here you can add a leader like we did on the plan. This is the same as the plan view. Leader, and get down here, utility transformer. And you can start labeling your one line. So again, there's no symbols built in. This gives me an opportunity for a shameless plug for a set of one-line, single-line diagram symbols that I'm offering for sale. If you don't want to have to make all these, you can just buy them for a reasonable price and use them. So I will just point you to where that is. In the description below, I'll have a link to the whole one-line diagram pack that's on the MEP Guy website for sale. And as you can see here, it includes circuit breakers and fuse switches and transformers and panels and all the pieces you would need, and you just drag those in. So let me show you really quick how that would go. Again, if you're interested in not having to make all of your own, you can simply go that route. So what we do is we would open up the library, and it's going to convert it up because they were done in 2020 so that they're compatible with 2020 and above. Open this up and you can see here, it's one giant group. I also in here have a sample drawings that can be brought in. So a variety of complexity. Even this is kind of like what we're doing now. And you can see here, these are dashed because they're existing now. We're not using existing, but this whole setup right here is pretty much what we need. But let's go ahead and just bring in the whole thing. If you open up the groups at the very bottom on the left, you'll get to the symbols and the samples. If you click one line symbols, right click and say copy to clipboard. Now, if I go back into my one line diagram and just hit Control V paste, and it says the following types are already here, fill patterns and some materials, that's okay. Now that whole group is put in. And all of the symbols associated with that are in here now. So if we go up to annotations, you will find all of the ER for electric rub, all the one line symbols. So for example, now I just take one line, panel, main lug only, drag it in. There it is. It's a label-based system where now I can just type this P1. Now, what about a meter? One line meter, drag this in. There's our meter. It's kind of a box and a square. And then we need a transformer. One line pad mount. They're alphabetical. Pad mount transformer. Drag that in. It's a little bigger, but there it is. So now I just have to throw my lines on. And we have, in just seconds, completed one line. And these are copyable. If this was an existing panel, click on it. Over to the right, it says up here under graphics, it says existing. Click on existing, and it's dashed automatically for you. If I was to bring in that whole group of existing, then it would give me an existing line type. But again, just a little plug for that system if that's something that interests you. If you're going to be doing a lot of these diagrams for even something more complicated than like a house, that may turn out to be a quick way for you to get up and running on your symbols. Because it takes a lot of time, frankly. It takes a lot of time for you to draw these symbols. Even if you create these as families, if you learn the family editor and all that, it can be done. So there's a couple ways you can go. So we will just go with the out of the box. And that's our one line diagram, start of it. We will be sizing these wires and such later as we go. But this gives us the basics. So back to our first floor. Not in this video, but elsewhere, we will get all the rest of this connected. And the same with the second floor. We'll go through and we will just connect all of these to that panel that we have in there and get that all done. I highly recommend that you jump in and actually practice this. If you're learning Revit, get in here. Like I said before, you can download this architectural model directly from Autodesk. You can use the built-in Revit families to start showing receptacles, bring in that panel like I showed you, start connecting it, and get familiar with how to connect. And another thing is you'll need to get familiar with how to connect, how to add receptacles. How do you remove a receptacle? Let's say we want to get rid of this receptacle. Well, if I hover over this and select the circuit like I did, I can go up to Edit Circuit. Now, instead of the default Add to Circuit, I can do Remove from Circuit. Click that button. Now, I will be unhighlighting these. So that just showed that I removed it. Finish editing. Now, the wire stays here, which is tricky, and that can mess you up. So you want to make sure you manually get rid of the wire. But this is no longer circuited to that panel. And as you can see, I have my power button back again. And the load on this panel, if we go back to our panel schedules, which are over here, the load on the panel has changed. I don't know if you paid attention, but now it's only 540. So that's the basics of circuiting and getting a one-line diagram started. Hey guys, this is Rob. Welcome to episode 5 of the residential Revit Electrical series. In this one, we're going to finalize some of the circuiting of the receptacles. We still have a floor receptacle that we need to add an electrical connector to. And as you'll see, it gets a little bit complex and we find visibility issues and things like that. So stay tuned for that, as well as how we are going to deal with the bath fans. So just a shorter episode this time, but hopefully it shows you some basics of family editing and how to deal with some visibility issues with your families. So here we are back in our Revit Electrical residential tutorial project. Where we left off in the previous episode was finishing up circuiting the receptacles in this two-story project. So let's review some of that. I want to show you a few things that I didn't cover, but I would like to specifically cover. Here in our kitchen dining area, you can see I have things circuited up. I ended up circuiting these receptacles to one of the kitchen circuits. I have dishwasher disposal all circuited separately. I tied the hood into this kitchen circuit. So I made use of our circuits, but what I did not do yet is circuit up these floor receptacles. Now the reason I didn't is you recall back in, episode 2, I think, when we installed these, we realized that they actually do not have electrical connections. We had to dive into the architectural Revit built-in families to find a floor box, but like most architectural pieces, it does not have an electrical connector that we need to connect to our panel. So we need to actually edit a family. Now, this is an advanced topic. It will become essential to your success in Revit to learn how to at least do modifications of existing families, because out of the box, Revit's not really made for full production. It's kind of a skeleton that you need to build upon. Anyway, so let's get into some minor family editing. We're going to look at this receptacle, and it's an outlet floor duplex. And we're just going to go to Edit Family up here. And it jumps you into the Family Editor. And right now, it doesn't look very exciting. I can't see a thing. I hit ZA, Zoom All, there's nothing here. So we need to find a view where there's something to look at. So on the left, it's kind of like a mini project itself. It has a project browser. It has your properties on the right. And there's other tools up top to help us build and modify families. And we'll cover some of that as we need it. But if you go to the floor plans, ceiling plans, 3D plans, elevations, those are your views that are set up. Right now, there's no 3D view for this device. So that means that it's probably just a symbol. So go to the reference level, and there we go. We see that this family just has a symbol. And if you hover over it, you can see it highlights all one piece. If you click on that, it is a generic annotation. And it's its own family because now we have the edit family available. So the way things are done in Revit is you have a 3D object, which is part of the model, and then you have an annotative symbol or a generic annotation that is nested into this family to give you the look of that symbol that you want in 2 dimensions. So that's how this works. So this is a 2D family, but our purpose here is to add an electrical connection. Let's see how we can do that. So let's just go up to Create. And over here, you'll see all these connectors. Electrical connectors, duct, pipes, cable trays, conduit. So all the system connectors for MEP, we want the electrical connector. So we click on that. It adds an electrical connector to a component. And we have to add it to a face. You can see up here, it's hosted, they call it, to a face. Now, do we have any faces to host this to? That is going to be our biggest issue, is there is no 3D faces in this family to even host an electrical connector. So we are actually going to have to add a 3D element to this. So this will get you really kicked off on your family editing experience. So let's see, how do we even do that? So Family Editing 101. A lot of times you'll start off a family's 3D aspect by creating a 3D cube or a box. So that is what we're going to do. We're just going to create a 3D box for this family. Now we could just start off and hit these buttons here, do shapes, extrusions, blends, revolves. There are different kind of 3D shapes that we can do. You can even, this void forms will even let you cut a hole into a 3D object. We're going to start with the basic extrusion. Now, normally in a family, we would draw some reference planes, reference lines, which are like construction lines that form a skeleton to attach a 3D shape to. We would normally do that if we want to make it parametric and editable in your model. If we want a box under this floor receptacle that we can change once it's in our family, then we need to do all of this stuff. Again, I want to make this very basic. I'm trying to show this project specifically using as much out of the box as I can. So I'm going to do the minimum needed to get this connector in. So we are just going to build an extrusion. So hit the extrusion, and then they want you to draw a shape. We're in sketch mode because there's a check mark and an X. Hit the rectangle tool. We're just going to create a box around this. Dimensions don't matter so much. It's going to be about 8 inches square, which works. And when you draw this extrusion, it wants to know how deep is it. So how far into or out of the screen is it going to be? And up here, the depth is 1 foot by default. We can leave that as 1 foot, and then we can adjust it later. Say, okay, let's see what we get. Now, at this scale, the line type is just super fat. That's why it's just a big blob. Like if you click thin lines, you can see that it's just lines. But the other way to deal with this is in a family, you can easily change the scale that you're looking at it. It won't change anything other than how it's viewed. But it, of course, does change the scale of the symbol because symbols are always the same size in paper on the sheet. So it shrunk it down, which is fine. For now, we just want to see our shape. We're looking at kind of a top view of it, if you will, looking down on it because it's looking at the floor. We need to look at a side view. So let's go to the front. We can go down here and look at the front. Double click front. We need to change its scale as well. Now we see it. And there's this thing here called a reference level. In our case, we're going to be placing it on the floor. We really want it to be below the floor here. If we look at the reference level, we are going to see this box in our model when we put this family in there. In normal two-dimensional view, plan view, I don't want to see this extrusion. I only want to see the symbol. So we can set this box up to be viewed only in certain situations. So what I mean is, if you recall down here, there's different detail levels that you can set your view to, fine, medium, or coarse. And that will allow you to change the level of detail that you see in these families. So what we can do is click on this extrusion, and over on the right, there's a visibility graphics overrides for that. Hit this, and now here's some view-specific displays. We're going to display this extrusion because we clicked on the extrusion, not the symbol. We're going to display this extrusion in 3D, and do you want it to show up in the plan or ceiling plan? No. Do you want it to show up in a front or back elevation, the left or right elevation? Yes, that's fine. And then the detail level. We want to be able to control whether we see this extrusion at different detail levels. I want to see it at fine, because fine means super detailed. So I want to see all that. Medium is, you can decide whether you want to see that or not. And I definitely don't want to see it in coarse. So do that okay. So that should set up this extrusion to be only visible in 3D views and sections, elevations, and especially only if it's set up to something other than coarse. So now we have the extrusion made. Now we can apply that electrical connector, which is the last piece. So back to create, back to electrical connector. Now you can see it highlights that extrusion. So that's a face that we can apply. So if I just click here somewhere, it put my electrical connector in there. That's what this symbol is, circle with a plus. So if we click on that symbol and look over to the right, you can see that it's a connector element for electrical loads. So we have a bunch of parameters for this electrical connection that we can set. You'll see a number of these in our model. When we clicked on a receptacle, we actually saw a voltage rating and a load rating and even a load classification. Now, we don't have all of this. We don't need all of this visible in our model. So we need to decide, what do we want to see? First of all, any kind of load like this, what I mean by a load is it's not a panel, it's not a distribution piece, it's actually a load. I want to make it balanced, which means if I make it multi-pole, the load, the watts will be divided among all of the poles evenly, which is how loads typically work. Now, number of poles is 1, which is perfect for a 120 volt receptacle. If that's all I'm ever going to make this floor box is 120 volt receptacle, then I can just leave it at 1 and I don't need to change it. The trick is, if I do want to be able to adjust this in my model, then I need to, what I call is map these parameters to the family, or they also call it associate it. So associate this with a family parameter so that I can get to it when I'm in my model. And I'll show you how that works. That's why we can change the voltage and pole of some of these things that are in our model. I like to go ahead and associate poles as well, just in case I want to change this guy to a 240 volt floor outlet for some reason. I just get in the habit of that. So I'm going to associate it with a family parameter, and it's asking if there's an existing family parameter of a compatible type. There are none. I need to create a new parameter. Again, if this is all new to you, you will have to go through this and try it a few times to get familiar with it. There's a few basic things to learn on basic families. So we're going to call this parameter the same thing. We're going to call it poles, and we can say number of poles or just poles typically works. Now it's an electrical discipline. It's a number of poles. It already knows that. Now, where do I want to group this? You know, when we open up the edit type, there's grouping of all of these parameters. I like to group this just under raw electrical rather than circuiting, lighting, loads. And it could be under loads, but I like to just call it electrical so they're grouped together. So I'm grouping it under electrical. I want this to be a type parameter because I want to set it once, and I want all of my instances of this floor box to be the same. So I want it to be a type parameter. Okay. And then okay. Now we've created a type parameter. And if we go over to this box up here, the family types, the little blue, click on that. Now it shows us what we would see in the edit type box. An elevation, which is 0 is fine. And here's our number of poles that we just added. So now that means that we can get to this parameter within our family. Now we can't get to voltage, we can't get to load. So we need to continue mapping or associating these connector parameters to our family. So okay, we need to reselect our connector. Now power factor, I'm not going to change that in the field. Lagging is normal. Load classification, I do want that available. So again, create a new parameter. Load classification. And we're adding this as a family parameter. It's going to be a type again, and I want this again, it put under loads, but I want it under electrical. So they're all together and say, okay, okay. Let's check again, make sure. There it is. Load classification now is here. Okay, let's do another one. We want voltage available. Same thing. Voltage, type. We would have all of these parameters under all different headings if we just left the default. So we want to force it to go to electrical. Okay, okay, I like to verify that it is where I want. There it is. And I'll set it to 120 volt as a default. And then the load classification, not all of our load classifications that we find in our model are actually in this family. As you can see, there's only a few. So just leave it as other for now, and then when we put it in our model, we can actually set that. What else do we need to map or associate? We want the apparent load. Now that they've been associated or mapped, they have little equals. So let's click on this little teeny button over here. And this one is a new parameter again called apparent load. And this will be under electrical. Okay. So now you're learning how to edit a family. And again, this is key to your success in Revit, and we will cover more of this. I have a bunch of other videos on editing families. The true power of Revit happens when you create or obtain these custom families, and it makes your life so much easier because they're already set up. You can make them look exactly how you want in your model and go from there. So we just want to make sure we have the data here available. So that should be it. And let's just double check. We have number of poles, a load, and let's put this at a standard receptacle, commercial at least. And there's the defaults. We are good to go. Now we can save this as a separate file if we want. But for now, I'm just going to load this into my project, and I don't even want to save it outside of my project as a separate family for now. Now, if you're trying to create a library of custom families, then you would go ahead and save this and give it a proper name and things like that. But for now, for this project, I'm not going to save it externally. We're just going to load it, and I'm going to overwrite the existing version. Now, do I just want to overwrite it, or do I want to overwrite it and its parameter values? Now, if I'd already set up some parameter values in my model for this receptacle, then I may not want to overwrite the existing parameter values. So that's why I typically go with overwrite the existing version, but not its parameters if they were set. And then this just says it's not editable. Do you want to make it editable? Sure. Let's edit that. And that just means that it let me change it. And the receptacles disappeared. Well, let us figure out what happened here. They worked fine before we added that extrusion. There's one here. What is this? Let's look at this one. Over here, it's on level 2 at 0, 0. So we are seeing the level 2 receptacle, floor box, while we're in level 1. Well, first of all, that issue will be a view range issue because, as you recall, this floor box is an extrusion now that sticks down below the floor. What is our view range set up in this view? Under the view template. So let's go look at view range. And the bottom is our associated level at 0 offset. And the top is the level above at 0 offset. If the floor box above is mounted to level 2, it protrudes down in below level 2 by 5 or 6 inches. So that's why it is visible. We need to lower the top of our range to eliminate seeing the floor box. So we'll need to come down, I would say about 6 inches. So minus 6 inches. Apply that. And that is often needed, as we find out. And there we go. Now we do not see level 2. That fixes that issue. But we still can't see our floor boxes. We can investigate this a number of ways. Is it a view range issue? Did we mess up the family? What's going on? We can look at view range as an issue, but we didn't change where that symbol is. We didn't really change anything that should affect it, but let's just play around with that. So let's go into our view range again. And let's look at the view range, the bottom of our view range. We are at the associated with 0. We know this box goes down below the floor. It appears that it got mounted to the right level because level 2 was there. Let's reduce the bottom of our floor. Let's go minus 1 inch. Say apply. Okay. Now they showed up. Well, why is that? We had to go below the floor to see them. Well, what it turns out to be is that the extrusion starts at 0 and goes down below the floor. So the view range doesn't see the extrusion exactly at the level, even though the top of our extrusion is right at the level. So in effect, adding an extrusion to this family has changed its visibility properties from when it was just a symbol. It's a very obscure issue that I frankly have never run into before. So let's go back into our editor, edit family, and go to our front view. As you recall, this extrusion only goes up to the reference level, and we need to pop that up just above the reference level so that it can be seen, this extrusion can be seen within our view range that we set up. So just, again, adding an extrusion to this symbol made it behave differently in Revit. Simply moving that up above the floor will make it visible. So load into the project. We don't want to save it. Let's just overwrite the existing. Now, if we set our view range back to exactly at floor level, bottom associated level with 0 offset, apply, we should still be able to see our floor boxes. And there we go. So we just had to pop that extrusion up just up into our space a little bit. So we're going to circuit these up now. I'm going to figure that these receptacles are part of the kitchen and dining area, which need to be on kitchen small appliance circuits. And then the rest of this I'm going to call just living space. So let's get these guys circuited like we did before. Now we have our power button because we added the power connector. Power. And then I like to call this receptacle dining. Apply that. And then I like to edit the circuit and add the rest of these, and they're easily added now. You can see them highlight up, just like I did before. Finish circuiting. And then I hover over one, hit tab until I see the dashed circuiting. Click on that. Now I've selected the circuit. Arc wire, and there's our arcs. And we can adjust these as we see fit. We can move where they're attached. Those look fine. They're attaching nicely, and let me get out of the thin lines. They're attaching nicely to this symbol, which is nice. Sometimes they don't. So let's get this, and I like to play with the arc. I get picky about these things. And there's our circuit. And then I want to attach these guys to this hallway circuit. So again, hover over till I get the circuiting, click on it. Now I'm in the circuit. Then I can edit circuit and by default add to the circuit these other receptacles. Those are added. Finish editing. Go back to one of them, hit tab, select the dash, click it, and arc wire it. And then I can adjust my arc. Now, one thing I noticed when I was putting these in is we did not yet assign, let's go to edit type for this floor box. We did not yet assign a load classification since we edited it. So we're going to go to receptacle. Okay, and now we apply the correct load classification, which applies the correct demand factor and separately labels it down in our panel schedule. So let's take a look at our panel schedule. Since last time we saw it, we've added a lot of circuits. Here we go, see that. I also want to show you, in case there's a few here like I did, where I forgot to name the circuit description as I was placing it. Now I need to go back and figure out what was circuit 3. Well, I can go back to my plan, and on a simple plan like this, it doesn't take long to find it. Like, for example, I just found it here. But on a complicated building, you can imagine, with multiple floors or, hundreds of thousands of square feet of school, finding that circuit would be a nightmare. So let me show you a trick. You can go to the panel. As long as you have these plans already tabbed, click on this circuit, escape out. Click on this circuit. It's selected. Now if I go to first floor plan, it highlights in blue. And so if you're out here, you can kind of see some of it starting to turn blue. This is the panel. And the circuit is surrounded by this blue dash. So this will help you narrow in on where it is. And here's the blue receptacles that indicate those are on that circuit 3. So that will help you find it. So now, again, let's escape out of there, tab into the circuit, click on it. And from here, which I should have done, I can type receptacle, and this is another kitchen receptacle circuit. We have a few other circuits. Let's see what we have. Down here, 13, click on 13, go back to first floor plan. There's the panel lit up. Do we see any blue lines? Oh, here it is. A little bit of blue down here with a little bit of blue line. So that is in our laundry. We can highlight this and take receptacle, another laundry circuit. And then the final one that I saw that was not labeled is this guy. And where is he? First floor, 21 right there. There's the blue highlights. And that is just the circuit we were dealing with, which is kind of extended hall. So we'll just call this hall. Tab, receptacle, hall. Okay, so that finishes those. So then to deal with this circuiting in this kind of order, down the left, down the right, let me show you where that's taken care of. Under Manage, go to MEP Settings, go to Electrical Settings, and then you would think it'd be down here with panel schedules, but that's not where it is. Now, one thing you can do with panel schedules is we can merge multi-poled circuits into a single cell. I like the visibility of that, so let's do that. But under a General, there's all these different electrical settings and how you want to display your circuit settings, name by phases, capitalization of names, and then we get to circuit sequence, which is what I changed. Now, the default is typically just numerical, 1, 2, 3, in order. I like to move it down to odd, then even. So it goes down the left side and then down the right side. You can set this however you like, but that's what I like to do, and that's helps with the circuiting for me, so I don't need to move things around. And as far as moving things around, I have a whole video, which I'll link above, which talks about how distribution systems work and how to do some panel editing. You can edit templates, but I'm going to show you how you can move things around. You can just click on a circuit, and then up left, you have some move tools here. You can move it up, move it down, or move it absolutely to an exact place. So if I just move down, you can see that just keeps dropping over here. I can move it up. Now, if I move this down, this entry hall, move it down, it will actually swap with the dining right there and continue moving down. Now I can move this to an absolute. So the green one is what I'm moving, and I'm going to move it to there. So you can move things to places. I can move it to this place, and that will swap it. So there's a lot you can do with the circuits. And since Revit automatically assigns circuits for you, that you need to have this flexibility to arrange things the way that you would like. You can change the template of this, and we'll get into that later. That's more advanced, is how to mess with the templates for these things. But for now, the basics of this are we can move things around. We can also create spares and spaces in here. So quite a bit we can do with the panel schedule, but I just wanted to show you some of the basics. But the other thing I want to show you here is on these bath fans, I did not circuit them to the bath receptacle. I've decided that I would like them connected to the lighting circuit. Now they can either be on the same switch as the lights when I get to circuit the lighting, or there'll be a separate switch, but either way, I want them on the lighting circuit so that in my switch box, I only have the one circuit in there. So to do that, I will eventually connect this to the lighting circuit, but for now I don't have a circuit. So I'm just going to use the wire tool, systems, way over here, wherever these can move around. So right here is wire. If you click on wire, now I can pick the connector of this bath fan. I don't have to use the automatic wire feature. This is the manual wire feature. Right here, you'll find something highlight. That's the connector for this bath fan, the electrical connector. One point, and then here's the midpoint of the arc, and then I'll draw the end of the arc right there, and then it hooks it to the middle. It doesn't draw a home run because it's not assigned to a circuit. So I can still just put a little text note here, and it says 2 lights, something like that, to indicate on the power plan that this goes to the lighting circuit and refers the installer to look at the lighting circuit. So that works for that. And I've already done that up here on the second floor, bath fans to lights to lights. So you can see the second floor, I still have a floor box to hook up. Luckily, we went through and fixed it so it has a power connector. We want to connect that to the master bedroom circuit. So let's highlight this circuit with tab a couple times. There it is. Edit circuit, add to circuit, right there, finish it, and then we have to get back into it with tab to get the arcs, and it decided that this is the closest place for an arc. So that completes that. And one thing I want to show you here that I did, in this hallway, this receptacle and this receptacle are around the corner, and to have a single arc, it was really cumbersome. I didn't want the arc cutting through the middle of the room. So I used, like I showed in a previous episode, I used the add a vertex. So if you right click on here, you can insert a vertex into your arc, and this little dot shows you where it's going to be, like right there. So now I have extra control of this arc shape to start getting it to bend around a corner. So keep that in mind when you need to do some interesting geometry. Now this one here, I didn't mind it cutting through here because it's not cutting across any text or any other lines. So back to first floor, one more thing I want to add is I want to get a receptacle out here by this condensing unit for servicing it. And at least in commercial buildings, you have to have a receptacle within a certain distance. I think like within 25 feet. So let's go ahead and right click, create similar. Let's get a receptacle out here near this condensing unit, and we'll just attach it to this receptacle circuit. So just get into the circuit, edit circuit, and click there, finish it, tab, arc. Bam, there it is. So once you get familiar with this, it goes fairly quickly. You can move these around. Again, if you need to, go thin lines so that you can see this little grip. And there's the grip. So you want this grip to hit the circle, not there. So use thin lines to your advantage. So that should complete the circuiting of our receptacles, including that floor receptacle that we had to edit. And that concludes this episode. Next time we will get into installing some lighting fixtures and getting those circuited eventually as well. So, by the way, if you're getting some value out of this video, I'd sure appreciate you hitting that thumbs up like button down below. And if you want to see more electrical only future videos, please hit the subscribe button. Thanks a lot. I appreciate you. In this episode, we're going to be creating our lighting plans. We're going to look at the architectural model to see what kind of lights are in there and what kind of ceilings we have. We're going to then copy some of those lights and put them into our electrical model and see what kind of troubles we run into trying to find ceilings within a linked architectural model. We're going to learn how to load different Revit out-of-the-box light fixtures and how to pick different kinds of light fixture tags. We're going to show how to create a lighting schedule and get that started. So a full episode coming your way. Stay tuned. So we're starting this episode off back into the architectural model that we downloaded back in episode 1. If you can recall, we are using an out-of-the-box Autodesk Revit project that they give you in their downloads area. You can go back to episode 1 to check that out if you need to. We're looking in this model to see what the architects have planned for lighting. Now, you'll often have an architectural plan that has some lighting in it, maybe from the architect or from an interior designer. Perhaps they have a lighting designer on board, or even some projects they will have the electrical designers do some of the lighting design if that is your wheelhouse. Let's take a look and see what they have. We're going to look right now at some of their renderings that they did to get an idea what's going on in here. And in here, as you recall, we have a kitchen, and we have a couple lights shown. We have some suspended linear lighting here with aircraft cable, and another one here over the kitchen. That's all we see in this view. And let's take a look at this view down here. This is the sunken living room, as you recall from previous episodes. And they have what looks to be ceiling mounted track lighting. And these are just flat level ceilings in both of those areas. And we're just going to deal with the first level in this episode. But in the future, we will see that the second story has some vaulted ceilings. So that's another type of ceiling that we'll have to deal with and get some lighting up in the vaults and see how we deal with that. But we're going to look at the first level right now. They don't show anything here, at least in the renderings, for exterior lighting. There's no lights out here by this parking area. So we will have to add some lighting. And again, we can assume that we've got some lighting information from somewhere else. We'll also look in here to see what they have for plans. Now on the left, you see we have floor plans, 3Ds, elevations, sections, detail views, renderings. We do not have any plans called ceiling plans or lighting plans. We just have the raw floor plans. So to actually see the lighting in plan view, we're going to need to create some ceiling plans in this model, at least to see what they've done. So the way you do that is you go up to View and Plan Views. There's a floor plan view, and then there's a ceiling plan view. Back in an early episode, we set up some lighting plans based on reflected ceiling plan views. So that's what we're going to do here, just to see what they have. So reflected ceiling plan, and it gives you the option to select which levels. Let's do level 1 and see what we have for lighting. So it creates a ceiling plan. And there's no view template assigned to this, and it's just assigning a view range, some preset view range. But it appears that it works for this kitchen area because these look like lights here. So in the architectural model, we can easily just hover over these and see what it is. Lighting fixture, SH lighting, pendant, light control, mod 66. So this looks to be a vendor's lighting family that was brought in. And if you click on it, we can see there's a power button, which is a good sign as far as connecting it. But we actually need to bring lights into our electrical model so that we can connect them. We can't connect a linked light. So we're looking at a few things. We want to see where they're putting lights and how they're mounted. And also, is there a possibility we can actually kind of steal these lights and put them in our own model to connect them? So a power button is a good sign. And if we look at the type parameters of this light, we can see that we have some voltage selectors, and they've got 277 selected now, but you can, looks like, change it to 120 with this button. And there's some apparent load. There's an apparent load spot here. So we have electrical data in here that we can use to connect it, which again is a good sign. There's that light, and then, so we can't see lights down in this area here. So let us take a look at our view range to see what we're dealing with. And we'll also cut a section so we can compare that view range to the section. So cut a section right here. You have to be out of the section. Then you can double click the head to see the section. And we've got level 1, level 2, and there's our lights right there. So we can make these levels a little more visible, readable by changing the scale. And we're in metric in this architectural model. So let's change it down to 1 to 50. Let's go down to 1 to 25. And get that text reduced so we can read these. So we have our level 1 living room, which is the sunken living room. And we're not worried about that part right now because in our ceiling plan, we're looking up at the ceiling. We're not looking down at the floor. So the floor line is not as critical. We have level 1 and we have a ceiling in a level 2 and ceilings up at 2700. Let's look at our view range. Now we have to go back to a plan to do that. So go back to our ceiling plan, look at the view range. What do we have? The bottom is at the associated level, level 1, and it applies the same offset as our cut plane. So the cut plane is here, and then the top is at level 2. So we've got level 1 to level 2, which makes sense. But let's take note of the cut plane. They're cutting it at 2300. Where is 2300? So we have level 1 to level 2. We're in that range, but where is the cut? It's cutting the wall like a section. Well, 2700 is the ceiling, so 2300 is pretty close. If we were to draw a line, let's just draw a line up here. And let's move it. Let's see what the dimension is. Dimension, ceiling to here. And we need that to be, what, 400? Click this and move it up to 400. Our cut plane is actually above our ceiling. So the ceiling of this dropped living room is also dropped. The cut plane is way up high. So typically on a cut plane, on a plan, I usually have down around 4 feet. And so let's get that cut plane down below, because what we're doing in this level is we are cutting horizontally above our ceiling. And so like if we click on that, we're actually seeing a roof. So we are way too high. Let us change this view range down to something like 500. And voila, there they are. It was all about the cut plane. So we are down around 500. We're cutting right there. And that's why we can also see this television, is because we're cutting through it. So we got the cut line right. Now we can see these lights. So if you have trouble finding things, check that view range. It is the culprit for many of these issues. That third dimension is very tricky. We have these lights, and it looks like they're individual track and one head. And this guy, if I can select it, tab it, track with one head. So this is all track with one head. And it is the style. It's a Cooper RSA Profile Series. Okay, so it's another vendor lighting. And we have a power button. Again, a good sign. Let's make sure it has all the connections we need. Voltage, wattage, actual parent loads here, and voltage. We'll have to see which one's which. There's a couple different voltages. That gets confusing. But that's what you get when you bring in a vendor's light. Sometimes it's a little messy. But we'll see if we can use that. We know what lights are in this thing. Now let's take a look and see what else is going on. What do we have for ceilings in these other rooms? And we can drag this section around. Let's look. We're going to be looking at this. This ends up being the laundry room we recall from before. And it looks like, here's the washer, tumbler, and we have just flat, hard ceilings tied up against this floor joist. And I think we'll have the same in the mechanical room and the bathroom. We can just go to our section. In the bathroom, there we go. Look at the sink, hard ceiling. And the mechanical room here, hard ceiling. So, and even the hallway out here is a hard ceiling until we get to the stairs. Here's the stairs going up. So we know that the whole first level is all flat gypboard looking ceiling. So that's good to know. The last thing we want to do is let's try to bring these lights into our model and try to use them. They have electrical connectors and we can see how that goes. If not, we have other options. Now, one way you can bring these in is you could click on it and we could go to Edit Family. We're in the Family Editor and then we can save it from there and then we can load it into our model. Another way we can do is go directly to the project browser and go down under Families and go find those lights. Now, I'm using 2023 Revit, so it has a nice feature in it that isn't in some of the earlier ones. If we click on a light and right click, we can say Find in Project Browser. That's a nice shortcut. It will open it up over here on the left for you and highlight it. So here's our, we can't click on the one of the types, but we can click on the family itself, right click, we can just save it and save it directly into our project folder. So I'm just going to save it with this name with an option. I like one backup. Okay. So hit 1 and then we have to actually hit save and it will save it. Now this says the light source is inside solid geometry. No light will be emitted. That just means if I'm trying to do some kind of a zonal cavity, they call it lighting calculations with this, it's not going to work. Well, we're not using this for lighting calcs. Personally, I use Visual, a lighting program by Acuity outside of Revit to do my lighting calcs, my point-by-points. But you can do some rudimentary lighting calcs in Revit if you set it up properly, and I may cover that in the future. Now this track, same thing, right-click the track and hit the Save button. And save it into our project folder with option of 1 backup. Okay, and then hit save to actually save it. Now those are in our project folder and we can bring those into our electrical model. So I can say right now we are done looking at this architectural file. We can close it. We don't want to save any changes. So we hit open, override existing copy. Again, this is a work shared project, so we have a central model on our server and we create a local copy every time we open it up. And then we synchronize with that central now and then. So here we have our lighting plan where we left off before. We had created these in an earlier episode, just a couple lighting plans. And a reminder that these are called ceiling plans because they look up at the ceiling. They're not looking down at the floor. They're actually looking up at the ceiling. It's, the model's looking up at the ceiling. So we see things up from our cut plane like we just saw in the architectural model. Now, one thing I do notice is that I do see some receptacles in here. And I see some motors. So we have some categories turned on in our lighting view template over here that we need to turn off. And again, this is something you would set up in your project template. When you set up view templates in a project template, you want those set up to have the proper visibility right at the get-go when you open up your project template to start a project. And we'll cover project templates in a future video. But right now, let's deal with the view template. And there's a lot of different kind of templates in Revit, so it can get confusing. In the view template, we want to turn off the electrical fixtures category. So we go into our model and we go down to electrical fixtures and you can see they're turned on. Turn those off. And then electrical equipment, we're going to leave on because I like to see my panels and switchboards and stuff and such in my lighting views as well. because I'm connecting to those. So say OK, and that will turn off those electrical fixtures or devices. Another thing I'd like to do now is get some room names into these room tags like we did in our power plans. So power floor plan, for example, here, we had these room tags. We want to put those into our lighting plan. Now, in CAD, you might go around and copy these and paste them, things like that, but we just want to use the room tag directly in our plan. So let's go up to the annotate. Over here under tags, we have room tag. Click on room tag. Now, the first thing we get is an error, a warning. Rooms are not currently visible in this view. A view template is assigned to the view. In order to make rooms available, the view template needs to be edited or removed. So this view template doesn't have rooms turned on, which is actually a 3D entity, a model entity. So let's manage our view template again. We need to turn rooms on in our model. So let's go down to, it's actually a model category, not an annotation. The tag is an annotation, but the room itself is a 3D entity. So down here in the rooms, we can see it's turned off by default in the Revit lighting template. So, okay. And let's check the annotation, and I could also get to it from up here. The annotation, and make sure we have room tags turned on. So room tags are turned on. Let's see if that helps. So now we can see our room tag, and we can place it where we want, right here. And then we get another warning. Now I'm leaving all these warnings in to show you that this is real life in Revit, frankly. A lot of videos, I think, gloss over some of this. They will cover, just throwing room tags in, throwing lights in, this and that, and without any warnings or anything like that. But in reality, you're going to run into instances like this, need to know how to fix them. Warning, none of the created elements are visible in this reflected ceiling plan. You may want to check the active view, its parameters, visibility settings, as well as any plan regions and their settings. Okay, so there's a whole list of things to check. Let's start with this active view and look at some visibility settings. Now we're dealing with rooms. We already turned rooms on. So that seemed to do something, but let's go check rooms elsewhere. Remember, we have a linked architectural model. Let's go check rooms in there. So down here, the visibility graphics override, and the reason it's called override is because you can override a number of the built-in settings. See all these overrides? You can click in here and override things. So that's where that comes from. But let's look for rooms in the we're in the Revit link display now to remember where you are. Let's check the rooms. Now rooms are turned off in the Revit link. Let's turn those on here also. There's a lot of places to turn things on and off. Voila. There it is. It turns that on. So that was the issue. So now we can place our room tags. And also something we do in our project template is I like these room tags to not be so bold. So let's see how to fix those to be lighter. Those are in our model. They are an annotative element, the tag itself. So if we go down to room tag, there's a halftone column. And that's the way we can dim this down. So under room tags, if we click the halftone, that'll automatically shade it for you. And see how that's not as dark. So that's what the look I want. Again, it's something we would fix in a project template. Let's go ahead and do the rest. And I can just right click and say create similar. And we can do the rest of the rooms. And we can move these around as we need to when we install our lighting. Get the living room. So those are the major rooms. Any area that's blue is a room that we can tag. This is just an interstitial space, part of the kitchen, so we're good there. So we've got those in. Escape out of that. Okay, now we want to start bringing in some lighting fixture families. Now remember that we saved the fixtures from the architectural model, so let's bring those in. We bring those in with the insert. And we're going to load a family. Let's load a family, and it drops you into its default location. So I'll just navigate here to our actual location, our project location where we saved them. So here we are in our project location. Let's go find those. And here is the SH lighting pendant, and then the track, and we're going to hold control and click that. So now we have both of these selected, and just say open, and it's going to load them into our project. So now we should find them down here under families. I have families open, And we know these are lighting fixtures. And here they are. Model. So the way we pull these into our model is we can drag one of these. You can also go up here to the systems and go to lighting fixture and go that way. I like to use, if you've seen my videos before, you know I like to just drag things from the project browser, kind of like a tool palette. Drag it in and place it. Now, let's see what's going on here. It looks like a super long fixture. So there's something going on with this model that makes it look strange. And we can click on it, hit plus to turn it, move it around. Let's use our section. Now we have one long section here. We can make it longer by dragging that circle. Double click and then see what we have. Well, we moved the section, but it didn't actually move the visibility settings. So let's move that over. So here we are. Now, I can highlight over this is ours. This is the architectural. Ours came in with a little gap. And it does say it's hosted to our linked model. So this is a face hosted type of fixture. But it's not hitting the ceiling, and it has an extra length. We can close the power plan. So I think I'm going to not use this fixture. It looks like it's got some crazy things going on. So after all, we're just going to get rid of this fixture. So what are we going to use instead? Well, in our projects, we use a whole bunch of custom light fixtures that we use, that we like, that are simple shapes and things like that, made for our plans, because we're not doing photorealistic rendered type of lighting drawings electrically. We're mainly looking at connections and get a relative 3D object in there for doing some clash detection. So we use a lot of custom, but for this tutorial, I'm trying to use out-of-the-box elements just so you can learn how to do this without a bunch of custom work. So let us go up to the insert again and go back to the Load Autodesk family from their cloud. I've shown this before on the power side of things. Let's look at the lighting side. So it puts you into their cloud-based families. And let's go down to lighting category. And you get a bunch of different lighting, both architectural and MEP. Now the architectural ones typically do not have electrical connectors. And they could be ceiling hosted. We don't have an actual ceiling in our model. We have a linked architectural model. And in Revit, that linked ceiling isn't a ceiling entity anymore. It's just a face. So it's kind of an anomaly about Revit. So we don't want ceiling hosted things either. We can have face hosted, but not ceiling. So let's go to the MEP, and they have exterior, external, and internal. So exterior and interior. Look at the interior. Now we have a bunch of different kind of lights here, and you may want to bring a bunch of these in and play with them and get a feeling for what they are, how they're hosted. Some are not hosted, some are floating. So you take a look at quite a few of these, but let's see what we have. We have a ceiling light flat round. We may be using that. A downlight recessed can. Well, we may do some recessed cans. Let's try that. We have a downlight strip, under cabinet, and these are hard to see in these tiny little thumbnails. Floor lamps, pendant, disc, pendant hemisphere, pendant linear, 2 lamp, and here's just a pendant lighting fixture. Let's try that. And we have some recessed lighting, surface lighting. So let's just try those for now. And it should load them over here. Here we go. Let's look at this pendant. It looks like a pendant linear. And it's set up with sizes and voltages. So let us try the 8-foot 120 volt. And bring it in. And we can use spacebar to flip it around. So let's put it just in here somewhere to look at it. Where did it put it? If you click on it, it says it's hosted, and it put it at 8 foot 10 and a fraction. So it sounds like it put it on a ceiling. Now this is a hosted fixture, it just automatically connects to a surface. Look at our section, and this looks like our fixture. It looks like it did attach it directly to the ceiling. And this is their fixture. So we can tweak this. It looks like we have a pendant length that we can change. And then if we go to edit type, we can get in here to the actual cross-sectional dimensions and the length and vary all that. So we have a lot of variety, and we have all of our loads and voltages and such that we need to connect it because it has a power button. So that's all good. So I think this is going to work. Now let me show you a contrast of putting a light fixture in a floor plan versus a ceiling plan. Let's go back to that floor plan. This is a good exercise. Now I can see the light. I'm going to put this light in again. I'm going to drag it in. And if I put it in here, it looks the same. I'll put it over here. I'm in my floor plan now. Where did it go? Where did it connect? Oh, look at that. Now it's at 0 elevation. It's hosted to what? It's hosted to the floor. So a floor plan looks down. It sees the floor as the surface to connect this light to. In a ceiling plan, it's looking up, it sees the ceiling. That is the exact difference between ceiling plan and floor plan. So that is why we use a ceiling plan to mount our lights. So get rid of that guy. Now this is nice to be able to see the architectural lighting in here to compare it, but I can't see it in my lighting plan. I like to make the architect's lighting visible as I'm constructing my lighting plans. I will want to turn those off eventually when I present these on a sheet for a final drawing. I don't want them to clash. But how can I turn them on in the meantime? Well, I could just go to my view template and turn on those lights, but then I have to turn them off again. So what I do is I create a separate view template for what I call coordination. I can coordinate my lights with their lights. If I have a plumbing and HVAC plan, I can bring that in and also coordinate that way. So I can use a coordination view template to change the view. So how do we do that? We already have our normal lighting ceiling view. We can just copy this and then change the name and then change some parameters to create a coordination view. Now, a little trick I use, if I just go to duplicate, for some reason Revit doesn't give you the old name for you to change. You'd have to type it in. I'm lazy. Instead of typing all that in, I like to just go to a trick and do rename, right click, copy that, cancel out, and then go to duplicate and paste it right in. And then I can change it easily. That's just a little trick I use. So I'm going to do coordination. So I'm creating another view template called coordination, and I want to turn on the lighting fixtures in the Revit link. So go to Edit, Custom. Let's go to the model category and down to lighting fixtures. We will turn those on. Now we could turn lighting devices too. They may have, which is like switches and sensors. They may have those turned on. So let's do that in our coordination view. Okay. Okay. Now you can see that pops the fixtures on. Now we must have our view range set up properly in this view because I can see all of my lights. So that's a good sign too. We don't have a crazy cut plane issue like we did in the architectural. So now we have theirs to look at, and in ours are different. Some people like to turn their lights a different color so you can compare them, so we can do that as well. Now that I'm in the coordination view, I can go into my model and turn my lighting. This is where you can do actual overrides. So this is projection or surface, so we get lines, patterns, transparency. Now I'm not cutting the light fixture, it's projecting onto my plan. So I want to change the projection, override it, and put a color into it. So I'm going to color these blue. So my lights are blue. And I can just do that for my coordination view. I don't need them blue in the final, but it's nice when I'm coordinating to keep track of what's what. One more thing I'll say about this coordination view. You can either switch view templates back and forth in our lighting plan, and we've done that before, but sometimes you can forget to switch it back to your actual production or sheet view. So what we do instead is we just go ahead and create another view, another ceiling plan called a coordination view that always has the coordination view template assigned to it. So this production view, I want to go back to my normal ceiling view. This is my sheet view that I'm going to drag onto a sheet. And then I want to duplicate this, duplicate view, to create a coordination view. So I don't have to swap templates back and forth anymore. So I can just duplicate the view, and that just duplicates the model elements of the view. Or I can duplicate the view with the detailing, which means 2D annotative elements like the room tags and any fixture tags, things like that. So I'll go ahead and duplicate with the detailing. I might as well have my room tags on it. So you can see here it made a copy. I can go through and hit F2 and just rename this. And now I create a whole nother set of digits here. I'll do the 10 series. So I'll make it 11. This is just to help organize it. And I'm going to use lowercase because it's not a sheet or production view. First floor, plan. I like to say coordination. Emphasize that this is a coordination view. So I'm in my coordination view, and this is the view that I want to apply the coordination view template. So now I don't have to change views. When I drag this on a sheet, there's no chance that my coordination view will end up showing. Anyway, a couple tips on on how we deal with view templates. And offices do different things, but this is pretty common, is to have a set of coordination or working views. Now, let's line this thing up. We looked at the section. We want to get the height correct. We can drag this around. Now, I can't go up and down with it because it's actually connected to the ceiling, which is called hosted. So I'm going to move this around, and I just want to get it the right height. And I can do some measurements and things, but it looks like it's, if this is 1.5 feet now for a stem length, pendant length, let's go 2 feet and see if that gets us close. Some fixtures you can actually specify a bottom height. And in fact, our custom suspended fixture that we use, which I will show a link above how to build that, this is free floating, it's not connected to the ceiling, and we can set the bottom height and we can extend each pendant individually up to the ceiling. But in this, out of the box, this is what we get. Now I can't change the stem width. It's going to be kind of like a, like a rigid stem, not an aircraft cable. And then the width of this, I can change as a type parameter. And the width of this is 1 foot. Let's go back. Let's go down to 6 inches and see if that gets us closer to, like I say, I don't need a photorealistic fixture, but I want it somewhat close just for comparison. So that looks decent. Now let's go back to, I can close the power plan, go back to our coordination view. Now we want to get the length the same. Now the length is another type parameter, so I can't just drag the length, but let's see what length this fixture is. You can go up here with your dimensions, and you can see I highlight the end, not the middle, but I highlight the end, and then go down here and highlight this end, drag it out, and we can see we're 13 feet 9 and some inches, so 13.9. So let's go ahead and edit type, make this thing 13 foot 9, 13 space 9 is one way to do that. Apply it, okay, and it stretches it from the middle, so we need to get it down. And what I'm going to do is place it right on top. Now, why didn't I drag my light directly on top of that fixture to begin with? Well, we'll show you. Let me get rid of that. I'm going to do the same thing over here. Now, I already have my fixture, and it's already got the right length. I can actually just create another one from here. Place this fixture, create similar. And I'm not going to line it up directly. I'm just going to put it in over this fixture somewhere like this. Now, let's see what happens. Okay, this is what can happen. Is it saw this existing light fixture, the bottom of the light fixture, as a surface. It saw that as the ceiling, and it placed it on this fixture. So that's another reason that I don't place fixtures right on top of the architectural fixture, because you'll get this. Now, how do I get it up here? I can try picking a new plane, but I can't do it from the section. Picks a wall, I just can't pick the ceiling. So I need to do it from here. I can do this, click it, say pick new, and then put it away from the fixture. And now let's see where that ended up. Ended up 8 foot 10. So it looks like that corrected it. So here it is over here. And then now we can drag it in place. So just another tip on lights, place it nearby and then drag it on. So there, and that looks right on top. So those are the only two lights. Another thing I'll mention about these lights is we want to give them a type name that we can schedule. And lights are typically called things like ABC, or they'll have another like L1, L2, or if it's a pendant, it'll be a P1. Lots of different schemes. So whatever scheme you're using, we want to call the fixture by that. So how do we do that? Well, this fixture, I can click on it. And right now, it has this built-in name. We want to change that name to our own. So we want to duplicate this and create a new type and call this, let's just call it L1. Go with the L's. L1, and we also want to change its load. Now, let's say we looked at the cut sheet for this thing and we found out that it's 30 VA per 4 feet and it's just over 3 sets of 4 feet. So let's say it's a 120. Again, you want to coordinate that with your fixture cut sheets and things like that. And then we also want to put type mark. This is what is used in tags. So the type mark we also want to call L1. And that way, when we tag it, it will be an L1 fixture. Now, we only changed this one fixture to be an L1. This fixture over here was still the 1x8 out of the box. So we want to change it to be an L1. And once we've already created L1, we can just go down here and change it to an L1. Now that's an L1. Let's look at tagging when we're talking about tagging. So let's go ahead and try to tag this thing. If we go up to the tag by category, it's going to tag it with the default tag that's set for a light fixture. So we'll see what we get. Click on that. What do we get? We get a box with a question mark. We've got a leader on it. What is this actually tagging? We go up here to the properties. It's a lighting fixture circuit tag. Okay, so it's trying to tag the circuit. Well, we don't have the circuited yet. Furthermore, we don't want to tag the circuit, we want to tag the type, the L1. Well, you can see from this drop-down, there's no other kinds of tags. I mean, we can do boxed or standard, unboxed. Either way, it's still a circuit tag. So we need to create or load in a fixture type tag. Let's go back to our load Autodesk family and see what we have for tags. Let's go back to all results. And this is an annotative element, so annotations. And go to electrical. And we'll see here there's switches, and these are all annotations. Let's see if we can find a tag. Now, to help with us here, we can just type in a search. And go lighting and see if that helps. There we go, lighting. Light switch tag, lighting fixture circuit tag, that's what we have. Lighting fixture tag, it doesn't say what it's tagging, but it's different. Let's try this. It'll be under family in the project browser. Or we can also just click on a tag and now see what we have for dropdowns. It added that new tag to the dropdown. Let's try a standard, and we can just change this by going here. There we go. That actually tags the fixture type. And we can turn this leader off over here. And then we can just move this down to next to our fixture wherever you want it. Let's tag this guy. So we go back to fixture tag and do that. Now it's doing a boxed. We can change the default behavior of a light fixture tag up here. There's a couple ways to do that. Annotate under tags. You'll hit the little drop down tag, and this will show you all the loaded tags and symbols, and it also means it's going to show you what the default tag is. So look at all these categories, and there's some tags, area tags, cable tray tags, conduit tags. Let's go down to lighting. Lighting devices like switches are a switch tag, and then lighting fixtures is a lighting fixture tag boxed. So we can actually set this up as a default from the box. We can set it up to the standard. So what that does is it lets us now, when we hit tag by category, it will use that setup that we want. And the leader, we can just up here at the top here, this bar, we can just turn off the leader. And now we can just click it. It puts it right in the middle of the fixture, and we can move it around. Another way you can do this, let me delete that. If you already have a tag set up that you like, and that's the tag you want, because you can have multiple kinds of tags loaded. As we know, we have a circuit tag and a type tag. Right click on the tag you want, create similar, and it will use that tag independent of what you have as default. to tag your fixture. So on some projects, you may want both a circuit tag and a type tag, and you can just create similar for each of those and tag your heart out. So that's those. Now the other fixtures that we know of are these track lights. Now these are the architect's track lights. We need to bring our track lights in. So let us see what we can do about that. So down here with our track, open that up. Let's see if we can use this. Or just left click it, hold it, drag it in, and let go. And I'm going to place it on a ceiling in here. Now let's see, I'm getting a do not enter sign. Means I can't find a ceiling. Can't find a ceiling. Now, this is another huge issue that you run into working as a lighting designer in an architectural model. Why can't I see the ceiling? Oh, wait, I see it up here. Okay, I can see it there, but I see that? I cross over. There's something in the way. I just saw it in here a minute ago. There it is. So I can see it some places, and other places I can't. So this one drove me nuts for a long time when I was a beginner. And so let me show you what's going on here. I can do it down here. I can't do it here. So something's in the way of our ceiling. I looked around at different view settings. I looked at, is there furniture in the way? What's going on? I'll tell you what I learned. I'm going to put this right at the edge where it lets me, right there. So that tip. I'll show you what's going on here. Associated with lights, and let me just edit this light to show you. Associated with a light, edit this family, is this big cone looking thing coming out of the track light. So it says edit family, but it will not let us edit this family. Again, this is a vendor created family and it won't let us edit it. But what's going on is this cone is called a light source. It is actually a 3D entity. So when it's brought into our model, it thinks it's part of the light fixture. So we go to this model here. Let's turn on the light source category. So go here, and it's in our link. It's our linked model, custom, model categories. Go down to lighting fixtures. And under lighting fixtures, you see light source. It's off by default. Turn that on. See all those yellow lines? Those are the cones of that light source. Look how far they extend. And what's interesting, again, let me try to right click this to create similar. If I cross into that yellow zone, that's where I can't see the ceiling. So these light sources are blocking the ceiling. So I can't place a single light anywhere within this yellow zone. So how do you deal with that? Well, I often do what I just did here. I'll place it where I can in the ceiling and then drag it in where I want it. Just by turning those off doesn't eliminate them. It just turns off their visibility. To really deal with these, we need the light source in the family itself. You can shrink it down to a smaller size so that it's not blocking most of the room. Well, as you can see, I couldn't get into that family to edit it. I couldn't change its size. So we are limited in this situation to just having to put lights on the ceiling wherever we can. In some projects, you'll have architectural lights all over. There will be no ceiling left to put this in. So you'll have to somehow edit that model, shrink it down. But anyway, just light sources are a huge issue on lighting plans. So we can leave that on here. This is just our coordination view, but that's a huge issue with lights. So let's go ahead and we're going to hit space bar and move this guy around. We want it to kind of line up with what we've got over here. It's not super critical. We really just need to get these in here. And it lines up. And then we can just take these and copy them. And you can kind of pick exact point to copy if you want to get super critical about it. And turn thin lines on sometimes helps. So if we go to copy it from here, and I have multiple on. So I'll copy it from there. That's kind of an insertion point or a midpoint to this midpoint to this midpoint. And again, we're just getting close. It's not exactly lined up with the heads, but again, we're just doing this for circuiting reasons, really. Put one there and there. We'll just go on, get these close. So there we have 4 lights. And again, we're not doing a rendering with this, but it does resemble, if we draw a section, it will resemble the architectural situation. So we have our lights and their lights. And when we turn theirs off, all you'll see is ours, and they're representative of what's going on here. And we want to tag these as well. Now, what I should have done is, before I copied this around, I should have created my L2 type. Duplicate this. I'm going to call this one L2. And again, I need to put in my load. Track is typically loaded by its length. It's calculated differently than just the watts. So I'm just going to say this is about 400, about 100 watts per foot. And because it's set up, someone could throw incandescent lights on there. So we'll put that to 400 per 4-foot section. This voltage appears, we don't know which voltage is which. Let's try this one. And let's hope that that's the right one for our connection. If not, we can change them up here. But because it's under loads, I'm thinking that's what's going on. And then again, the type mark we want to call L2, call this L2. Okay. And we actually want all of these to be. Now, what you can do is you can right click on this and say, select all instances visible in this view. Now, they don't mean in this window, but in this entire lighting plan view. Select them all. And now we have all the other 7 light fixtures that are just named this. And now we can take all these and turn them into L2s. So that right click, select all instances visible in view, or you can do the entire project if you want to do it that way. And that will catch it throughout the entire model. A very powerful selection tool. So now we can tag these with our tag. And remember, our last tag is the type. So we can put that and just put an L2 by each one of these fixtures. And make sure that we're tagging our fixture, not the architectural. Now, if we were to try to tag the architectural fixture, what do we get? We get a question mark because it doesn't have a type. So this makes sure we have ours, L2, and so on. Okay, so we're getting these. We're about done installing the architectural fixtures that we know about, but we have areas in this building that need more lights. So again, let's say that we were talking with our interior designers and our architect and maybe a lighting designer, and we found out that they want to add some other lights in these areas. They want to add a surface circular decorative light fixture. They want just a surface circular LED fixture, utility type in the mechanical room. So we can start adding those in. So let's see what we did. We brought in a recessed can, but we're going to say they want all surface mount fixtures here. So a flat round ceiling mount, because nowadays you can get a nice shallow down can that's surface mounted. Maybe it's only 3/4 of an inch tall. Let's say that's what we're going to use. So we'll just pick a 120 volt model. These look like incandescent wattages, which doesn't matter. We can change them. But let's bring that in. And there's a nice circular fixture. And we'll put that in the mechanical room. Save the project every chance you can. And let's look at this section again that we had here. And look in the mechanical room, see how that looks. It looks like it did place it on the ceiling. And it's a taller fixture than we want. And can we change its height? See, we cannot. On this fixture, they did not associate the dimensions to the type, so we can't change it. Again, custom fixtures, we put the dimensions in here so that we can tweak them and change them. But this is what we're stuck with for now, which works. We'll duplicate this and give it a type name. We're going to call this L3. And don't forget to put that in the type mark so it can be tagged. And then parent load, we're going to say this is an LED down around 15 watts, 120 volt works. So that's that fixture. Now, we start losing track of L2, L3, wherever we are. If you open these all up, you can find these over here, L3, L1, L2. That helps. But also, we can create a schedule in Revit that will list all of our fixtures for us. So we might as well learn right now how to create a schedule. So let's go ahead and create a lighting schedule. How do we do that? Under the Analyze tab, we can get to all the schedules. And we've got panel schedules here. Now here's regular schedules. The schedule, create that. And there's all different categories. And we want to do a lighting schedule. So let's go down to lighting fixtures. And we're going to say, okay. And now what we do is we're in the schedule properties box. Now on the left are the available fields. What that means is these are the available parameters within our lighting fixtures that we can drag into a schedule. So you can schedule quite a few parameters here. I mean, you've got height and keynotes, what lamp. You've got things like lumen depreciation and number of poles, number of lamps, all these things. So let's start off our lighting schedule. We can always add to it, but for now, let's at least get the type mark. And what we do is do this little arrow to add the parameter to our schedule. So type mark, and then what else do we want to do? Let's get the lumens in there. Now luminous flux is the lumens, the output of it. And then let's also get the wattage in there, which this is wattage here, but we typically want the actual VA, the volt amps. So that's the apparent load. So we'll do that. And there's other things that we might want to include later. Like I like to include the housing type, the optics, driver, all that. Now we don't have all that in here, so we may have to repurpose some of these parameters unless we start customizing our lights and adding shared parameters, which is a whole nother video. So for now, let's just do this, and this will let us at least see our fixtures. So here we go, and you can hold Control down and zoom in on this to make it larger if you want. I'll do that so we can see it. But we have our type mark, our luminous flux, and our apparent load. Now, you can change these headings. You can just say type, and this can here, you can change that heading just to say lumens. And this one here we'll just call load. So you can change the headings. We also notice that we see every single instance of our fixture. We don't need that in a lighting schedule because we just need these fixtures once. Well, how can we fix that? Well, over on the right, you can get to the fields, which we just added. You can get to a filter to turn things on and off. You can sort and group. You can change the formatting, the text and such, and other things like appearance, thin lines, things like that. But let's just go into the sorting and grouping. Because under sorting and grouping, down at the bottom, it says itemize every instance. Now, that's what we have now. We're seeing every instance. If we uncheck that, then we only see each type once, not every instance. And then we want to sort them by type mark. There we go. So now we have each type, L1, L2, L3, and the lumens and the load, and these can all be changed here as well as in the family types itself. So I can change this lumens and say that this guy is 12,000 lumens, for example. And again, we base this on the cut sheet. We'll say that the lumens on our track is, now this is for the whole 4 feet, and it depends on how many track heads, so it's really not applicable to this track. We can have other notes that describe what the actual track heads are, but this represents the entire 4 foot of track. And then L3, we're going to say this one's 1500 lumens. But all that can be changed here as well as in the model, and that's what's nice about this, is that any place you change it, reflects it everywhere. So anyway, that's how a lighting fixture works. So that lets us know that we have L1 through L3 already. So as we label these. Now, the other thing I'll note is I'm being very careful here to tag all these lights, but I'm in my coordination view. Now, this is something that you can realize too, that if I tag it in the coordination view, the tags are a 2D element a detailing element that did not show up in the other views. So now, in reality, when I go back to my first floor lighting plan, there's no tags. So my mistake there can show you one of the pitfalls you can fall into is it forgetting which view you're in. So all I need to do is I need to retag these here. So I will do that really quick. And there we go. So we just need to remember which view we're in. Now I can go back to coordination view. If I need to see the architectural lighting, well, I don't need to see the architectural lighting anymore because I'm just putting my own lights in. So I'm going to go back to my floor plan view to do the rest. And we've already got the light here. And we can move this. Now, if you're selecting the model by accident, you can actually go here and turn off, unselect check links, select underlay, select pinned. You can also get to those tools down here at the bottom where you can select links. You can turn that on and off here. And so you can get to those down here as well. And we can turn off our thin lines. So let's go ahead and tag this guy. L3, we set him up. Now we'll say the hallway is a similar fixture. It's a surface mount round, but it's going to be more decorative. So, and to select this, you have to make sure you get right on top of it. Create similar, and it's placing on a face. If we go vertical face, it's going to try to put it on a wall, which we don't want. So make sure you have face selected. And we can see our ceilings here, which is nice. So the designer told us that they're going to put one here. Well, before we move on, I want to change this type. This is a more decorative type. It may not look any different in our model, but in reality, it's a different specification of a fixture. So let us create its own type. Duplicate this. This is going to be L4. Same wattage, same VA, L4. So now we have L4 is a different fixture from L3, and we can create similar and put these where the designers told us to put them there. They want one down here. And the little blue dashes will help you line things up. And then they want one out here in the middle. And you can dimension these to set them up if you want to get exact, if you don't have something to draw over. And then we can tag these. And now that we have our tag set up, it's really quick. Now the bathroom, the designer said they want to use a vanity fixture over the sink. Now I can't see the sink. Let's take a look at our section and see what's going on with that. Toilet and a sink. Now, if I tab over this, now I have to make sure actually that I have select links on. Now, if I tab over this, I can select that sink. And sometimes you can get a drop down, sometimes you can't, but it is a plumbing fixture. So it's on the plumbing fixture category. So if I go back to my floor plan, I should be able to turn on plumbing fixtures and see that guy. So let's go into our view template, our model overrides, and let's turn on plumbing fixtures in our model. They are. And let's make sure we turn them on in our link as well, because that's where that guy lives. So plumbing fixtures there. Let's see if that helps. It did not. Now, this may be another cut plane issue. Let's check our view range. Now, we can't get to view range here because it's actually in our template. So we have to get to view range within the template, because the view range is included because of this check mark. Edit the view range, and we're at 4 feet. Let's see where that bathroom fixture is. From here, 2'9". So it is below our cut plane, but we would have to lower our cut plane to see this, clear down to 2'9". And so let's see what happens if we do that. Go down to 2 feet, see what happens. Okay, now we're seeing furniture and everything, which, we may want to have on to show relative locations. So I'm going to leave furniture on, and that bathroom shows up. Now, we don't see the toilet. And one thing we can do is we get a lot of tabs open. Every time you change something, it's trying to change things in all these views, and it can affect performance, but it also gets messy. So you can go up here to this button up here, close inactive views, and just close all the views. Now this view 1 was this family that we were looking at. We're just going to close that without saving. Now we can go back to this section, and it's section 5, and see, why can't we see this toilet? Hover over it with tab, click on it. Okay, so it is a generic model. It's not even a plumbing fixture, and it's low, so it's not going to be hitting the cut plane. So we won't worry about that so much in this view. As long as I see the sink, I can place my light above it. So now we need a vanity light. We need a wall mount. Let's go back to our Autodesk families in the cloud. We're in lighting. We were in lighting tags. Let's go back to lighting, electrical lighting, MEP, interior. Now we want some kind of a wall mount. Here's a sconce, flat round, sconce sphere, sconce uplight. So sconce typically means wall mounted. Oh, and then there's a wall bracket. Well, let's see what we have. We're going to load some of these sconces and load this wall bracket and see what we have to play with. Again, we're not trying to make an accurate rendering of this, but we want to get something that's approximately the right size and shape so we can do some interference checking. So down under our lights, we have a sconce flat round, sconce sphere, and a sconce uplight. We may end up just putting this wall bracket in. Let's see what that looks like. And you can see, trying to place it on the ceiling. We want to place it on the wall. So it's kind of that symbol. Let's use that and place it on the wall. Now, sometimes the sink's in the way, so place it on the wall nearby. And then we want to give it a height. It comes in at 4 feet. That's a little low. Let's get it up at 6 feet. And then we'll move it over above the sink. And let's see what that looks like. Okay, yeah, it looks like an exterior kind of a decorative light. So, you can play around with these and change it to a sconce. Once it's in here, we can change it to that. A round light. Or an actual sphere with a dome. If you want to just kind of a horizontal bar, we may have to make that. Again, that's a custom symbol, or bring it in from a vendor. But right now, we're just going to keep it as this. It's just uplight. We're going to keep it as this round for now. This dome. And I can get to it from the edge here. Let us give it a type. Now remember, what's our next type? Let's open our lighting fixture schedule again. So it's out here under schedules. And here's our lighting. This is an old one. We can get rid of that. And here's our lighting fixture schedule. We already have 4. So we're going to call this fixture 5, L5. Edit that, duplicate it, L5. And we're going to say that it's also a 15 watt LED and L5. Again, later on, we're going to go back and add some more details about lumens or lamp types, things like that, housing. But for now, we're just getting the basic skeleton in here for kind of a schematic design level. We can tag this and make sure we're tagging the fixture. Right now, it wants to tag a sink. It's trying to tag the wall. There's the fixture, L5. Now for our lighting plan, we may want to turn that plumbing back off just so we can actually see the lights. So plumbing may be only showing up. We may only want the plumbing showing up in our coordination view. So again, those are some decisions you'll have to make for visibility issues. We'll turn it back off. It's good practice to learn how to turn things on and off, though. Okay. Here's our panel. Let's go ahead and label that. And then the laundry room, the designer said they want some of these utility lights just in here on the ceiling. So we can copy or create similar, this L3. Now, by creating similar, it is actually trying to place it on a face. Once I have one in, then I could actually do a copy because it's all the same ceiling. long as you're in the same ceiling, it will copy properly. And if you click on it, it is actually hosted to the ceiling at the proper height. It will host it. But if you're copying from one ceiling to another, one room to another, I would actually place it and let it find the ceiling. And so let's just make sure that these are all done properly. Check section 5. Looks good. The other thing I like to do, and sometimes like we did in the architectural model, is do some 3D views of this. What I'm going to do is I'm going to put a camera, drop a camera in here, at this doorway, right inside the door, drag it to this corner here beyond the edge and click camera. Now, it comes up with this default view. I actually want this to be a coordination view. So go to coordination. That will get rid of the X-ray walls. And then I also want a consistent colors. So let's go with F8 will let us look around. And what we're seeing now is get out of there, hover over that. That's our receptacle. And this guy is our exhaust fan we put in, and it ended up putting it on the wall, so we can mess around with that later. But F8, we can look around. Here's our laundry equipment. Look up, and there's our lights on the ceiling. And you can say they're just gray. There's no material associated with them. Again, we're not creating a photorealistic rendering. We're just trying to get the systems diagrammatically shown and somewhat shown in 3D for coordination purposes. So we can go ahead and tag these. We are in our lighting floor plan view. Save it, tag it, and we can turn thin lines off. Also, this living area here is pretty dark on these ends, and the designers told us that they want to put some of these decorative fixtures, get out of the tag, in here as well. So let's go create similar, because we are a different ceiling, and they want them in line with these. So we're going to put it there and in line with that guy and in line with that. And then also they want some down here on either side of this fireplace. So we're going to put those here and here. Get these tagged as well. All 4. Hover over it. L4. Same up here. L4 and L4. And then finally, our lighting designers have decided that we want some lights out on these walls. So if we go back to this 3D view, this is this end. We're going to look at this other end. So let's go to here. And so we're outside on this outside balcony here. We've got these walls. They want to put some lights up on these walls at about 6 feet. So we'll go back to our plan view. To represent those, we're going to use that decorative wall bracket we found. So drag this guy in. And it's trying to put a ceiling. Let's go to our vertical face. And they want them right here. And let's say they want those up at 6 feet. And they want it right in the middle of this wall. Now, sometimes you can't find the wall. It's because there's sometimes different wall elements are stacked on top of each other. So if you get hovered over right there and hit your tab, remember tab cycles through stacked elements. So as I'm hitting tab, it's finding different surfaces. So right there is the one I want. And then I come over here and get that somewhat in line with this guy. And again, I didn't label these. We're going to label these. What's our next one? Lighting fixture schedule. L6 would be our next tag, our next type. Duplicate L6. And these are also 15 VA LEDs. L6. Apply it. And then this guy needs to be an L6 as well. So I can just go down and choose him, change him to an L6 like that and get these tagged. And then out of this other balcony, let's take a look at that and see what the designer had in mind for us to put. Now you can see that we have these nice fixtures installed on the wall. It looks somewhat representative in 3D of what we want. Let's go to this other corner. Look at this end of the building. Now, upstairs we have this balcony with walls, but what happens down here on this level? Let's do a left view and just look at the elevation of underneath. We can also look at the section of this and make sure we're seeing to the wall. Click. And there's no walls, we just have flat ceilings. So the designer said that they want to put some ceiling lights out here that are exterior rated. So it's going to be similar to these L4s, but it's going to be an exterior. So create similar. We want not vertical face, we want horizontal face. And they said they're going to put them right here. And this one's going to be called an L7. Another different type. It has a different spec. 15 VA and L7. Apply it. Okay, and then we can just create another one down here. Vertical face. Right there, and tag these. And that is all we need for this exterior, for the exterior lighting on the first floor. When we get to second floor, we've got this walkway and an outside terrace type place, and we have parking area and things like that that will want to be lit. So when we get to second floor, we'll have a lot more lighting to do. But this should wrap it up for our level 1 lighting plan. In the future, of course, we need to circuit these up, but that'll be in a future episode. So hopefully you've learned something in this one. We covered a lot. In this episode, we are going to do the rest of the lighting up on the second floor. We're going to take a look at the architectural model to see what the ceilings look like. We're going to cut sections. We're going to cut 3D views so we can figure out what is the architecture of this second floor. And then we're going to look at placing light fixtures onto these vaulted ceilings and deal with hosted versus unhosted lights. We're going to look at even a custom light fixture that we end up using to make this thing work. Then we're going to show how to add light switches or lighting controls to our plan to indicate how things are switched. So stick around for a packed episode. We're starting off this episode with more lighting. We're going to start looking at the architectural model and look at the second level of this out-of-the-box Autodesk Revit example project, which I showed back in episode 1, how to download. We have this 2-story building, as we've been looking at, and we have a parking area, a walkway to the second level, and we can see that it has a very steep roof. And down here at some of the renderings, we can see on the second level, it's very vaulted. And this is outside. And even at the other end of this, you can see it's vaulted here for this covered balcony. And it looks like it's vaulted inside the building itself. What we can do is jump into this architectural model. Again, we're in the architectural model itself, not our electrical model. And these 3D views they've already created are really just first floor and some exterior. So we're going to need to create some of our own. And let's go into level 2 floor plan. They have not created any lighting or ceiling plans for us to look at. There's no lights placed on the second level in this model either. So as we discussed previously, for lighting design, we typically get a lighting design from the architect or an interior designer or a separate lighting designer. In this case, we're going to assume that we have, behind the scenes, received some lighting design from a designer. So we're going to insert lights and connect those up. Now, we'd like them to be inserted into this model in a 3D fashion, even though we're really only going to present 2-dimensional blueprints or drawings, if you will, for the installers. But it's a good habit to get used to doing things in 3 dimensions when you can, to use one of the powers of Revit to help coordinate with other trades, and to help visualize what's going on in this building. So what we can do is we can create some sections to take a look at this. That's kind of the old-fashioned way. And then we can also, in Revit, create 3D views. And one way we can do that is up top, there's a default 3D view, but if you click the drop-down, you can get to a camera. And this little camera will create a 3D perspective view of whatever you place it. So let's start here right in this master bedroom. We're going to pick a place, and here's where the doors go in and out on the deck. let us put a camera and click right there and let go, and then just move your cursor to let's say a corner and go a little bit beyond. And as you can see, it drops a kind of a wireframe by default. Now we can fix this up by going over and changing the discipline to coordination, which will automatically get rid of the X-ray view. And then down at the bottom, we can change this to a consistent colors. First try shaded, and that'll give you, a little more realistic view. And you can also go to consistent colors. So a couple different views. If you go clear down to realistic, it'll apply some nice materials, textures, but it takes up some processing time. So I'm fine with consistent colors. We're just looking to get an idea of what's going on in here. The other thing you can do is hit this F8. Your F8 key by default sets up this little view heads up display. And we can hit look and hold it down. And now we can move our mouse around and look up. And here we can start seeing this framework of the doors and the windows. And we can also see that we have the peak of the vault. And even looking down this short little entry into this room, we have that. We also have a peak of a vault. So everything is vaulted in this room at least. We can hit the walk button and slowly is the key here, barely move the mouse forward to get a little bit of a walk going on. You can stop, hit the look again, move around, and start looking in this bathroom. Now, it looks pretty dark in here, and I think what's going on is I think we have approached a door, and you can see if I move it too fast. Oh yeah, there we go. There's the door. So go inside here, hit our look again, look up, and again, it's vaulted up there. You can look around. We could just reset the camera as well. But I kind of like walking through my project. And we're seeing some 3D things here. We've got shower. We've got the toilet. And we can continue walking slowly. It's a little hard to steer this thing. There's the tub. So this architect has actually modeled in 3D some of these objects. And again, we're mainly looking at ceilings right now, and we can also see there's no lights in here. So I think we can conclude that ceilings are vaulted throughout this entire level. If we go back to level 2, let's do the old section just as another method. So up top, you'll see this button called section up here in your quick access toolbar. You can also get it through all these things up at the ribbon through the view tab. And here's a 3D view drop down sections and things like that, even elevations. Now, you can try elevations interior. I find them a little tricky, and I like using this section personally. But let's go into this bedroom and see if we have the same issue. So we're going to drop a section symbol, and you'll see this little dashed line that comes out here. This is showing the extents of the section, and you can see there's a little double arrow to move it. It goes way over here. So this section is looking way beyond the section marker. Now, for an elevation view from a section cut, I like to pull this back to just get to the wall. And we can pull this in and kind of narrow down our section. If you double click, you got to be clear out of it, escape out, and then double click the head. And now we've drawn a section in that room. And here's our lower floor we've already done. Section again, there's no ceilings that we can see. This is just a dashed line for the roof line level indicator. We have vaulted ceilings there too. We can get rid of the title sheet. And we can now move this section along, and it's still showing vaulted. And we have some skylights that we are going to need to dodge as we place lights in here. Let's hope our designers kept that in mind. And back to level 2. And continue with the section here that I'm using again kind of as an elevation. And that's all good there. And then let's look at this entry hall. And we have our stair railings going down. This is all vaulted. So yep, we are entirely vaulted second floor. Another thing we can do is create a little 3D view just of an isolated area. So if you can get to a point where you can just window over an area, let's say we'll take these bathrooms and the bedrooms. And then up here under view, there's this little box called selection box that isolates selected elements in the current view. and it draws a little box of that area. Now, there's a thing called a section box where you can drag the edges of this around. Sometimes you cut a view like this and you can't see that section box. There's no box here. So you want to make sure your visibility settings are set first. Escape out of here, and we do not have a view template, so we are just going to go to Visibility Graphics Overrides. It's an annotative element. So go down to S and make sure that section boxes are turned on, and indeed they are. So we're good there. That's the first check. So it must be hidden in some other way. Well, go down to the bottom here, and there's a little light bulb. It says Reveal Hidden Elements. Now, you can use this anytime you've, let's say, hidden something by right-clicking it and saying Hide in View. Elements, categories, things like that. Well, to undo that, you can go down to the light bulb, Reveal Hidden Elements, and it turns everything red that has been hidden. And so levels have been hidden. This right here, hidden element, is a section box. Now, why that's hidden, who knows? But if you right-click on it, you can say, not hide in view, but unhide these elements in the view. And then you can go down and turn off this little light bulb. Now we have our section box unhidden. A little trick there for some visibility issues you may run into. We can click on the section box, and there's little drag arrows to drag the cut plane of that section. So as you can see, it really helps us see into this model what's going on in a 3D section. So you can drag this through your building. You can pull the top down and start to see things up here below the peak. You can see that these walls go all the way up. So this is a very handy tool, not only for analyzing a model, but even for presenting a 3D view in your model. So just want to show that to you as another tool in your arsenal of figuring out what's going on in these 3D models. So now that we know that we have vaulted ceilings throughout, we're going to have to apply our light fixtures that the lighting designer has told us they're going to use in here. But we have to get those into our model. So we're going to get out of the architectural model now. So close that, and we don't need to save it. And we are going to open up our own electrical model that we've been working on. So we will go into our electrical model. This is my residential tutorial. Open that. Again, override existing. We are in a work shared model, and it just takes a minute to open. Opens us at this 3D view. Now, normally in our project template, we have a starting view, which is a easier view for the computer to process, but we will show that when we get to the video on creating a project template, which is a very important part as you further ready your office or your practice for using Revit. But for right now, we're going to go back to our second floor lighting plan. So we under here, lighting, second floor. We can close some of these that we're not using to help our scrolling. Second floor lighting. Here we are with just a blank old lighting plan. Let us go ahead and put in some room tags like we did before. Remember up here, annotate, go to room tag. And we've already set this model up to accept rooms, accept room tags. We've done that on the first floor. So now it's simply placing these tags within the model. Now you can also go to annotate, go over here to tag all objects, and you want to hit room tags. So try that, and it didn't work. Well, let's see what's going on here. Try it again. Annotate, tag all. Include elements from linked files. Well, the elements that we are talking about are rooms, which are actually part of the linked architectural file. We're going to include elements from this linked file, and then go down and say room tags, and apply that, and say OK, and there they are. And like we did on our power plan, it just places them kind of in the center of each room, and we can move things around as we like. And we'll probably further move them as we start placing lights. So now we get into the placing lights in your model. The first thing we need to do is, what kind of lights are we going to put in here? There were none in the architectural model for us to copy and try to reuse. So now we're going to need to find some lights to put in. Now, if you don't already have a set of custom fixtures that you would use, like we do in our firm, you will have to find some light fixtures somewhere. Well, we can try what I would call the out-of-the-box Revit fixtures that are in the cloud. So if we go to insert, like we've done with other things, load Autodesk family right here in their little cloud. They have all the families that were previously loaded with earlier versions of Revit. Now they're in the cloud. So you'll see all results, and we want to go down to lighting. And we did this on first floor. We don't want to use the architectural versions again because they don't have typically electrical connectors, which we need. So go to the MEP category, and here's a bunch of different lights. Now, because we have slope ceilings, vaulted ceilings, we've decided we're not going to use surface-mounted lights. We're not going to use recessed lights. We want to hang some pendants down from that vaulted ceiling. And sometimes they can have, a fan attached to them or just be a light. We're going to hang some pendant lights. So we need to find some pendant or suspended light fixtures. Now, these are all surface downlights, things like that, floor lamps. Now we get to a pendant light. And again, you can't see very well in these thumbnails, but a pendant light disc. Let's click all of the pendant lights, select them so we can see how they work and see which ones we like. So we've got 5 different pendant lights we can try, and there's other ones that are recessed. If you go through the whole list, you'll find sconces and even street lights, things like that, but we want to go with the pendants, so load those. Now, what we're concerned with is how do these attach to the architectural file. We do not have a flat level ceiling like we did on first floor. So how is that going to work? It will depend on whether these lighting families are hosted to a face or whether they're what I would call free floating, non-hosted. So let's see what we get. A pendant disc will start there, and these are set up for incandescent, but we can change those. Drag a 100 watt 120 volt into our model, and we get the little crosshair, which shows where we're putting it. Up here, we can place on the vertical face, and you can see if I put it on the vertical wall, it's showing a disc pendant, but mounted horizontally, which we don't want. We want vertical. So let's place on face is our other option, and it will find any kind of face. Now, as I'm down here, I'm seeing, kind of a slanted view of it. And what's happening is placing it on the face of this vault. I'm going to move this section into this room and make sure we can see clear past the wall with this section view drag. Now let's look at this section view. So this is what we've done. We've installed this pendant light and it hosts it to this slanted ceiling and puts it perpendicular. Well, that's not what we're looking for. We would like this guy to hang straight down. And before we try another one, let's look at our visibility issue we were having. As we drag this guy, we lose it right there. Why can't we see it? Well, again, first thing to check, like we've done in the other episodes, is let's check our view range. Perhaps we are not looking high enough because the ceiling gets higher. There it is. It's there. It's just that we can't see it. So we need to take a look at our view range and see what levels we're at. And again, remember this architectural model comes in metric, and we have it set up for imperial, so we can use either of these. But let's see what our view range is set up at. Escape out of here. So we need to go to our floor plan and look at the view range of this floor plan. And if you recall, we have a view template assigned to this lighting plan. Let's look at the view range inside it, because we can't get to view range here. It's grayed out because it's included in this view template. So we will go here down to view range within the view template, and it is included. As you can see, this checkbox means that it is included within the template. Hit edit, and here's what we have. We set this up on the first floor to make things look right. We have the bottom, which is just automatically associated level with the same offset is our cut plane. So we are cutting our geometry 2 feet above the floor, which lets us see some furniture, sinks, things like that. But the top is our associated level, which in this case is level 2, and 9 foot 10 inches above that. So 9 foot 10 inches above is, and we'll draw a line right here, and it won't extend because I have it cropped. But we can look at the dimensions, go up here to dimensions, from this level up to there. That's 6 foot. Our cut plane is up around 9 foot 6, 9 foot 10. So actually our cut plane is at this roof line. So if a light fixture doesn't extend below this top end of our view range, we won't see it. So again, we don't see it until we drag a piece of it just touching or extending. Let's see if we see it now below this line. There we go. So that's how visibility is determined with this view range. And I have a video all about view range and that I'll point to up above if you want to check it out in more detail. But what we need to do is fix our view range so we can see clear up to the peak and beyond. So let's go back here and fix that view range. Now, if we fix the view range here in this template, it will change that same view range in our first floor. So this is an instance, and it happens quite often, where different floors, different levels, different floors have different needs for view range. So you'll find yourself possibly creating separate templates for different floors. And a lot of times on a commercial building, the first floor may be extra tall, and the rest of the floors 2 through 5, for example, would be the same. So you can have one template for first level, first floor, and a separate template for 2 through 5. The other thing you can do when you only have 2 floors and you don't need a bunch of templates is you can just disconnect the view range from the template. So go back to the template, and again, this include, and that's how I will do it for this project as an example. There's multiple ways to do things. In this case, because I only have 2 levels, I'm just going to disconnect the view range from the view template. I do that, now I can get to my view range independently of the view template from here. So that way, I'm not messing with the view range that's on my first level. It is disconnected also, but it stays the way it was before I disconnected it. But now we just have to realize that view range now is separate. We can get to it from here. Now the top can be changed. Should I change that to a higher offset? I can. And so what kind of offset am I looking for? My little line here. Let's get up past this peak. And we're at 19 feet 6. So I could set the top for like 20 feet. The other thing I can do, if I don't mind seeing what's on the roof and above, is I can set it to unlimited. So let's see what happens there. View range. And let's just go to unlimited. Now, the view depth is set below the top clip plane. This is the thing you have to keep track of when you at the top of a ceiling plan, as we know this is a ceiling plan, at the top, above the top is this view depth. So it has to also be set at least as high as the top. So you'll have to go down and also set it to unlimited. So it doesn't really affect how we see it. We can see the skylights. Now it really doesn't have an issue with what we can see. There's no lights on the roof that are causing us a problem. So we should be good there. Now, as we move this light in the room, we see it all the way across, because now our top of our view range is way up here. So we're good there now. Got that fixed. Now we still have the issue of the light fixture diagonal. Let's try some other lights. And this is a good example of what comes out of the box from Revit. And it makes you realize that whoever put these together must have thought all we have is flat level ceilings. Here's a 100-watt hemisphere. I'm sensing the same issue. Yep. Let's try this linear. And it can go that way, this way, or that way. We'll try both. There we go. We've got our diagonal mounted light. I'm sensing a pattern here. Here's another linear, well, it's 2 lamp. It can be the same type. It might be a different cross section. So there we go. Yeah, it's a different look. Same thing, diagonal. And we have this good old pendant light fixture. What does it do? So this is the one we used. This is the one we used downstairs. And it's also the same deal. Hit the space bar to rotate it. Let's say we want it to go to span. What happens there? Well, it picks which one it wants, and it's stuck to there. It went by center line, so it's stuck to that one. So, as it turns out, we can't use these. These are all hosted light fixtures. And in reality, we need a non-hosted light that we can just place in our space that doesn't attach to a ceiling. Now, there's other solutions. Some people will say, well, you can just drop a work plane in here. You could do that. And what it does is it puts just a fake ceiling in here that you can attach things to. And we can try that as an example. So we can place a work plane, go to architecture, go over here to reference plane. Now this creates a reference plane vertically. So we would have to go to our section and create a reference plane. And let's put a reference plane wherever we want it, like right here. Now the only thing I would say is that note is that this reference plane goes now throughout the entire building. It doesn't stop at these lines. It's infinite. So now we have a work plane throughout everywhere. So if I need a different ceiling mounting height in here that I do in here and here and here, I'm going to have multiple work planes. They're all going to be stacked on top of each other. How do I get the right one? This is not an ideal solution. So what we need to do is we need to find a light fixture that is not hosted, that's pendant. I can't find one in Revit's out of the box. So now we are stuck with needing to create some custom content. I'll link a video right now of how you can do this yourself. So you can either do it yourself or you can find a package of some that are made and buy those. But for electrical, we really just need a fixture that has a pendant that we can stretch up to the ceiling. And that works for our situation. It gives a good representation in 3D of that fixture without being too detailed. And it has all the electrical connectors we need. So let's get rid of all of these crazy lights. And we're going to just go ahead and bring in one of my custom lights and we'll show you how that works. And again, I have a video to show you how to create something like this so you can do it for yourself. And it's a good exercise. Someone in your firm or in your circle is going to need to learn to do some of this family editing anyway. So might as well jump into it. I'm going to go ahead and insert load a family. And down here, I have a pendant circular, and it's just a bare bones circular style light fixture that's pendant, and it loaded it. I need to go find it. Pendant circular, and I put ER in front, electric rob in front to indicate that it's a custom light fixture. So we will drag this in. Now it comes in at 0. Now this is not hosted. You can see that it's not saying it's hosted to level 2. But that's all. It's not hosted to a surface. So we need to say, how high do we want to mount this? Let's start at like 8 feet. Hit 8, enter. It's placing this light at 8 feet. And let's just say the designer wants to place it right in the middle of the room. Let's go to our section. And we see nothing. Okay, another visibility issue. Let's deal with this. Why don't we see anything in this view? We saw those other lights. Well, those other lights, if you get into the internals of the family, you can set which level of coarseness or which type of views it is visible in. Right now, we see this light fixture. But what we see is a symbol. We don't see the 3D geometry of this light fixture. And similar to the receptacle, when you place a receptacle and you see a symbol for the receptacle, you don't see the actual box and the cover plate, the 3D elements, the extrusions of it. Same with my custom light fixtures. I want to see a symbol. And in fact, my symbol has another circle in it that over here you hit emergency and you can click emergency. It darkens in that circle. And we use this mainly in commercial work where this may have an emergency battery in it, or it may be connected to a generator, things like that. Not so critical in residential. But it just shows that this is a symbol, and you can't see symbols in sections. That's the first instance. But I'm also not seeing any extrusion. Well, if we look over here at this section right now, the detail level of the section can be anywhere from coarse, medium to fine. This will let you control the level of detail of the objects. Now, this receptacle that came from Revit out of the box shows the extrusion geometry even at a coarse level. In my custom fixtures, I don't always want to see a fixture at coarse. I only want to see it at fine. So if I go to fine, now I can see my fixture. Now you may want to change that where you see it at medium and fine, but our decision is I only want to see 3D geometry when I turn this to be a fine level of detail. And this also brings up a good issue on this section, that instead of having to make all these settings every time I cut a section, you can also create a view template of a section, or an elevation view, if you want to call this elevation. So this is a good time to, let's create our elevation view the way we want it every time we cut one. So we can go to now this section view, which we're in, and we can't see it here. We need to expand something. It happens to be right here, this darkened one. And you can also name this section. But if I right click on this section, I can either apply a template to it, or I can say create a view template from this view, the way I have it set up now. Scale, everything. Create a view template from here. And I'm just going to call this, and for a custom view, I'm going to put the ER in front of it. I'm going to say elevation. Elevation electrical. Just to remind me that this is my electrical elevation. There it is. Okay, and I can set this view to that elevation. I do it in all caps so it stands out. So now I can do that with any section I cut. So now we have our light fixture, and we put it at 8 feet. And this is a pretty high vault, so let's go ahead and say that the designers want us to put this up at 9 feet. So we're going to go up at 9. And it should pop up. There it goes. And this is set up for 9 feet to the bottom, not 9 feet to the top like the other pendant down here. But what this pendant has is, if I click on it, this stem has a little up and down arrow. And let me turn the thin lines on. You can see it better. Click on it. There's a little up and down arrow. What I can do is I can drag this pendant up to the ceiling. So now in a 3D or a section, it looks like it should. It doesn't have a canopy and all the details. It doesn't have screws or anything like that, but it is a good representation of this light. Now it's just a circular but flat top and bottom. This is a very basic shape, but I can change the height of it. So the stem length then, because I can drag it, is an instance parameter. So if you go over here, stem length, see how I can change it here as an instance. So each light that I put in, I can change the stem length. But it also has type parameters, which I can only change as I edit the type itself. And so this is where I want to duplicate, like I did on the first level. I want to give this a name. So we had already started our fixture schedule down below. And let's review that. Go down to schedules, and we have lighting fixture. It's lighting fixture schedule 2 because I already had one. But here again, we can expand this out, hold Control down and scroll. You can expand this out to see it. It's easier to see in the video. But we left off with L7 as our light fixture. And we can just keep numbering these. If you want to get creative, you can call it P1 for pendant, things like that. Whatever you want to do, get the thin lines off. We're going to call this L8. And we're going to give it the wattage or VA that's on the cut sheet. And we'll find out this guy was only a 15 VA fixture. We can change the depth. Let's make this a nice thin. So let's give it like a 2-inch height. The diameter is 1 foot. And we're going to make this a larger fixture. It's a 2-foot diameter. The light source symbol isn't as important for us as it was in the architectural model, but I like to make it a little smaller. We don't see it, but it just won't clash with other stuff. And the stem diameter, you can get this as tight as you want. Right now, 1 inch works. If you were doing like an aircraft cable hanger, you could take it down to maybe the smallest dimension might be 1/32 of an inch. We'll see how that works. And then type mark again is L8, so we can tag it. Okay. And let's look at the section. And let me move a little bit away from this edge, this wall corner. Because we made the fixture thinner, the bottom is still at the same height, but it brought our stem down because the stem is attached to the top of the fixture. So we will pull this up to the ceiling. So now we can take a look at what this looks like in 3D as well. So let's go back to our lighting plan. And like we learned in the architectural plan, and be careful where you pick. If you pick here, you're going to grab stuff. So you might want to turn off how you select things. But if we pick here and drag across this room and do our little box, create a 3D view. And we need to zoom in. We have our section that we can start playing with. And we have our ceiling in the way. But what we can do is we can turn our view to that side, or even spin it. Or if you hold down the shift and use your middle mouse, you can orbit. So there's a bunch of different ways you can navigate. You can orbit. But that shows our fixture. Let's go down a little bit. That shows our light hanging there. It's kind of a disc light. It's got the pendant. And in 3D, it gives us a good representation, hold shift, of what it will look like in this space. Pull that ceiling up. There we go. So that will help you visualize what's going on in this space. So we can continue on now, placing lights. And we can also tag this one. We already created a tag that tags the fixture type. We can turn the leader off as we put it in right here. That's an L8. And then we can just continue on. We can copy this because this one especially, it's not hosted. That's the joy of unhosted objects. You can copy them around. They're not attached to anything. There's quite an argument by many people that says we should use unhosted families all the time. I still think there's a purpose for them here and there, like on receptacles. It will help cut a hole in the wall if you want to see it visually. So you have to make those decisions. But especially on certain lights, I really find that the unhosted lights makes your life so much better, because you'll end up with models early in the design process that don't even have ceilings yet at all. And so, there's nowhere to place a light fixture. So unhosted lights, you'll find, are very helpful. So that's what we're using in this second story. Now, the designers also want one as you come in here. So we're going to copy one over here. And they've decided that this 2-foot diameter one is too large for this little entry. They want the same kind of family, but they only want it 1 foot diameter. So what that means is we need another type. So we can take this one, do edit type, duplicate it again, make this an L9. And because it's a type parameter, we can change its fixture diameter. And L9 for the type mark, so it gets tagged appropriately. And there. Now our symbol, I mentioned that this is just a symbol. The symbol is tied to the geometry so that it ends up being the same size as the actual fixture extrusion. And then we also want this fixture, let's get it tagged. We also want this smaller fixture in this closet. So do this, copy it right there. So this will be represented the same way throughout the bedrooms. I'm not going to show every single insertion of that through the bedrooms. You get the picture. But in the bathrooms, we want some wall-mounted fixtures above the plumbing. We had the issue downstairs where we couldn't see some of the plumbing. We do have our view range down at 2 feet, so it should cut any plumbing that's in here. But we ended up turning off our plumbing. We don't want plumbing interrupting with our light fixture. But we can turn it on briefly, or we can turn it on in our coordination view. Now, we've not created a coordination view for this level because we're not trying to match up lights, but we still could create a coordination view for other reasons. But for this example, I'm just going to simply turn on the plumbing in the linked architectural. We're in the Revit link. In the linked architectural model, go down to the plumbing category. Plumbing fixtures, turn that on so we can see some plumbing. And all we'll see is the sink. And like I mentioned before, I do create an architectural PDF so I can refer to it without having to open the model. So here's our PDF. So we can go to the plan and look upstairs, and we can see here, there it is. The shower's in here, the toilet's in here, and our designers have decided we want a vanity light over the sink and just pendants in these rooms. This pendant is going to be rated for a wet environment, like a shower, and we also want a pendant over this tub. And let's go ahead and tag this guy. We can right click and create similar. It brings it the same height as the one we're grading from. And we can always change this height if we need to, but we're going to put that over the tub. We're going to put one in here in the toilet room and another one in the shower. So what we're going to do is this guy is going to be yet another light fixture that's rated for a wet environment, wet label it's called. So we are going to create an L10, simply copy an L10. It's the same size, 1 foot diameter, L10. Simple as that. And as we tag it, it gets the L10. The rest of these are still L9s. And we need to get this vanity light. Now we already had one from level 1. So if we go to our schedule, we can try to find it. Our schedule is just a start of a schedule. It doesn't have anything in here about the description of what kind of light this is, which would sure help right now when we're trying to figure out which is our bathroom vanity light. So we can add another field to this lighting fixture schedule. Remember, our fields are selected from the available lighting fixture parameters that are in our lighting fixture families. So we need to find a field that has some kind of a description. This is where if you don't have custom parameters in your families, which you won't out of the box, you'll have to maybe repurpose one. Now we have one here called description. Perhaps we can use that. So let's try description and put that in here. And we'll change this to be all caps to match our headings. Description. And now in here, we can write the description. Well, it's going to be hard to do from this schedule view, but remember, we can do it from any of our views and it will still be documented here because it is just reading the database. Let's go to our first floor lighting plan and L1, and we can start filling these in. L1. Let's go to edit type, and we can edit the description in here. While we're looking at the light, while we know what it is, we can say it's a suspended linear, something like that. This is just a rough description to help us remember what's what. Eventually in this schedule, we'll have things like the housings being out of extruded aluminum, things like that. But for now, that's the basics. So L1, and then when we get down here, to L2 was our track. Click on L2, edit this type. Description, we will put in track. Again, just a basic description so we can keep track of these things. The mechanical, we're going to call this surface circular utility style. And then L4 is the more decorative. Go here and edit its description. Surface, circular, decorative. L5 is our bath vanity. And to get to that, we have to come over here. There we go. Edit that. Bath vanity. And we can keep going. So now you can see when we go to our light fixture schedule, now we have some description for these things so we know what's what. And we can do the same for our fixtures on the second floor. But for right now, we know that bath vanity is L5. So now we can place an L5 now. So let's go down and we can see our fixtures. Here's the L's. So it may be closed. We want L5. There he is. Drag that in. And now it will let me select which method I want. So place on vertical face in this instance. I want to place it to this face. And I'll do it here where the geometry is a little less cluttered than all this sink. Place it there. And let's see what height we're at. 6'4". And we'll drag that over there. So now that light should be in there. So let's take a look at in 3D and see if we've done this correctly. We will select this little area, hit our 3D box, and then we're zoomed in. We can use this box to pick different views. I'm going to pick this other corner. We can play around with the section cut. And we're seeing the light. We can do it even from a left-hand side. Now, this seems low, but I think we don't have our section. There we go. We don't have our section going clear down to the floor. So there's our light on the wall. Here's our little lights hanging down. Now, one thing I notice here is in 3D is that these stems just did the same stem length as the ones that I copied or created from. So now I have to go in here independently and I can move these stems around. However, in the 3D view, you can't get to this instance parameter this way. We have to do it from a section. So there's a limitation with that. So in my section, I'm going to pull a section into this room. Now I can get to these and start adjusting these. So that's a limitation with a 3D view, is you can't modify these instance parameters directly. Now I could type it in. Wow, that's a long suspended light fixture. A very high ceiling. But again, that gives us the 3D look we're looking for. So we'll just go ahead and put the rest of these fixtures in. But let's say in this entry hall, they've decided to use yet another kind of light fixture that's more decorative. So we're going to take one of these and bring it over into this space. And in this space, they've decided to use a nice 3-foot diameter chandelier style fixture. So let's create yet another type, duplicate. Now, where did we leave off? Light fixture says we left off with L10. So we're going to make this L11. And this is a higher output light, and it's 3 foot in diameter. And let's go ahead and put L11. And let's go ahead and put the description in as we do these now. So this is a suspended circular chandelier. There it pops out larger. And we can look at the section first. Now we have another section we can use here. Click on that. Now this one we can't see lights because again it's not set for our fine detail. Let's apply that view template that we made already. And this is the power of the view template. Just click on that and voila, there it is. Simple. Once you've made that view template, you can apply it anywhere. So there's our light. It's the right, it's about the right height. Close, it's close. And we can copy one. And we can actually copy it from here to here. So you can copy it from here. And there's our light. And we can get it tagged. Like that. So we'll do the rest of these like we just did. Now we also have some exterior lighting to deal with. As we recall from looking at that architectural model, we have a walkway here we may want to deal with. We'll say that the designers have decided that we're going to light this walkway just here at this end. So let's see what that looks like. So we will draw a section and use it as an elevation. Make sure our line, yep, we are there. Let's draw a section of this wall and apply our template. So what we're seeing here, this is concrete. This is our walkway, and here's the railings. So if we go to the 3D view, default, we'll find that it applies our section box. So let's turn off the section box in this view. We should save this exterior view with its settings so we can get to it again. We'll say exterior. And this way we can see again what's going on. Let's go ahead and orbit around. So here we can see what's going on. There's that walkway. It goes out to this car parking area. So we want to get a light near this doorway to light this entry. And what the designers have told us they want to do is to put it right here beside the door. So that would be about right here on this wall. And we're going to use the light fixtures that we used on the first level. So go down to first floor. And we're going to use this guy. right click, create similar, second floor, and it's a wall hosted. So we need to host it to that wall, and we don't have a grid line in the way. So this should host nicely, and it's set up right now at 6 feet. We're going to put that up at 7. Mount it right there. And let's go back to that section, and you can see that light nicely mounts right there. Get it typed. It's the same one as down below. And then they've also decided to put one outside this door. Now we can cut another section, or we can drag this section and use the little flippy up and down arrows to make it look that direction. Go back to the section. Now we're looking at this other deck, which from here we can see this other side is this deck. Now we have a lot of glass here, not many places to mount a light. So they've decided to mount it way over here. So in our section, it's going to be on this view. Here's the railing. So it's going to be right here outside this window. So in second floor, that ends up being right here. So let's right click, create similar. They're putting it right there. And then finally, the other exterior building mounted lighting we're going to do is out here on this deck. So again, look at the exterior plan. And this is interesting. The orientation of the 3D must be locked before you can add tags or keynotes. That's a good point. If you're going to do a 3D view, you have to actually lock it down here. There's a little lock button, this little house, click on it. Right now it's an unlocked 3D view. You would have to lock it to add tags. So if you're ever going to do a 3D view that you want to tag or add text to, you'll have to lock it first. But we're looking at this balcony here, and we have walls and we have ceilings. So we're going to say the designers decided just to go wall mount lights out here rather than ceiling lights. So we're going to use these same decorative exterior lights on this balcony. And they want to put it just beyond the door so it doesn't hit. And another one down there. Now this one here, we have a grid line. As you recall from previous videos, grid lines can get in the way of mounting things. So we need to hit tab to tab through all these stacked wall lines, grid lines, chipboard lines, all these things. So we want to get it close, hit tab until it flips the right direction. Now we know we're hitting the wall. So we have those mounted, and we can label these as well or tag them. Remember, these are smart tags. They're not just text. So there we go. We just need to finish the rest of these interior lights. Now, another thing I wanted to deal with in this video is lighting controls. We have not touched things like switches or dimmers or things like that yet. So I wanted to just quickly show you how that can be done. We can use Revit's built-in light switch family. So if we go down to lighting devices, lighting switches, and this is typically loaded with this template, this project template. If not, again, you can go to Load Autodesk Family and find the light switches. Now this one has a variety of switches, and these are line voltage, typically line voltage switches like you would use residential, unless, you know, a high-end residential may have some digital lighting controls, things like that. But we're going to say this one's just going to be wired with line voltage, you know, toggle switches, 3 ways, 4 ways, that kind of thing. So we can represent that with these symbols. And let's say that this master bedroom is just set up for a single light switch. As you enter the space, it turns on everything in this master bedroom. So we can just hit this single pole light switch, drag it in, and see what we get. Now, because it's not showing up, it's most likely a hosted family, and we're going to go on a vertical face. So as we get close to a wall, just like a receptacle, it's drawing this kind of a backward S style of symbol for a switch, $sign. And we're just going to mount it to this wall right there. And it wants to host to a wall right there. And it's simple as that. Now there's a switch in this room. Now, Revit does have a built-in switch system type of feature where you can assign lights to a switch. If you have a three-way setup where you have a three-way switch and a three-way switch, you cannot connect both of those switches to the switch system anyway. So, in my opinion, it's not very useful. I don't use it, but I do at least, of course, show some switches in a space. And when I circuit it, I'll have actually an arc or a wire, a cable between the two to indicate what it controls. But anyway, let's go ahead and put some more switches in here. So let's say we're right inside the closet. They're going to have a switch, and it's hard to get to this now. Look what happens here. It's wrong side of the wall. It's kind of like the receptacle situation. I can sort of get to it here. But if you have that problem, then what happens is there's probably a shelf in here or cabinets that it's interfering. Again, get it close to where it should be and use your tab. There it switched. Now, another thing you can do, right click, create similar. A space bar will rotate it to different sides, but it also mirrors the symbol. So now that looks like a regular S instead of a backwards S. So it changes your symbol on you. So instead of using the space bar, you're better off to use the tab to actually select the surface that you want it attached to. So that's what I do, is tab it through it. And then we can do the same thing. We have a pocket door, so our light switch should be on the latch side, not the hinge side. This is not a hinge, but it would be on the opening side. So again, we can just right click this, create similar, and it's putting them at 4 feet. You can change that height. And if you take a look at our section, here we have a section through here. We can see what that light switch looks like. Out of the box, they are just a box. Now this one got close to the frame. So if you want it to look right in 3D, you may move that away from the door frame. You know, it's a start. In our custom switches we've made and custom receptacles, we've added a little more detail to the 3D elements so that it looks more like a switch. It doesn't need to be a 3D toggle, or even if it's a rocker switch, it doesn't need to be a 3D rocker, but you can, in a sense, paint an image of lines on this to more look like a switch if you want it to look that way. So we can continue just placing switches in our model. If you want to do a three-way switch, there's a built-in three-way switch here. Let's try this in this hallway. Let's say we're going to have a three-way switch in this hallway here, and we want one at the end of this hall so that these two bedrooms can turn it off or on. This bedroom here can get to the one here. And then we also have a space out here that we'd like to switch. So we're really looking at a three-way and a four-way and a three-way, if you recall how that's all done. So let's try three-way. And what it does, as you can see, there's actually, I missed it. Try it again. Get to the wall. Oh, it's trying to put it on the grid. That's why it gave me an issue. Now it found the wall. It puts a 3, but the 3 gets buried within the architecture. So again, my preference on these is not to use the built-in three-way that has a label that can't be moved. I change it, and you can do it here, instead to a standard single pole, and then I just add my own text. Get a little 3, and I can move it where I want. That's my preference. Keeps it readable. But we can put another switch. That's the 3. I need to get to tab through to get to the switch. Create similar. I want one down here. This is all glass, and this is the latch anyway. So put it here. Again, I'm having troubles. Hit tab. There we go. And then over here, we'll put it right there, and that one mounts fine. And then we can add our three-way to the end of this. And you can just drag that wherever you want. And then we need a little 4 for the four-way. Again, this is all line voltage switching. And so that's how you would do that. And we could go down to first floor and do the same thing. Put our switches where we want them. But that's simply how that's done. So with that, we are done with our lighting plan until we come back and actually circuit these lights like we did the power. Hey guys, this is Rob. Welcome to the next episode in this residential Revit Electrical series. In this one, we're going to look at circuiting these lights that we've put in on previous episodes. We'll look at how to deal with adjusting the floor plan brightness in the background. We will look at adjusting some heights of some of these lights that are on different floor levels. And then we'll look at actually circuiting these up, putting home runs to the panel, looking at the watts that are on the circuit. We will look at how to adjust all these little arcs that connect circuits and even the switches, and show how to adjust those and fine-tune those to make a nicely presented circuiting plan. So stay tuned for another packed episode. Here we are back in our Revit Electrical Residential Series project that we've been working on. And we are on the first floor lighting plan today. We're going to continue with lighting plan by circuiting up all of these lights that we've already installed in previous episodes. If you need to review that, go ahead and go back and check those out. We have a variety of lights in here, and they're installed and they are tagged with the smart tags. So we want to circuit them. Before I do that, I wanted to bring up a couple housekeeping items. One thing I like to do with my architectural floor plan background is help it to kind of be more faded in the plan. We did that in the power plan, but let's do that here. So remember, we're using a lighting view template. So any visibility graphics changes we make need to be in this template. So we click on the template and we go down to the VG overrides, visibility graphics override for the Revit links, hit edit there. And here we can see our architectural Revit link that we have, and we can set it to halftone, which, as you will see here, kind of grays it down. Now, if the halftone doesn't seem low enough, we can go into some options to modify that. If you go to Manage and then hit Additional Settings, you will see a number of settings in here, and this one's called Halftone Underlay. There's a slider, so we can modify this halftone. So if we put it down to like 13%, you will see that it nearly disappears. So this is a way you can deal with the halftone. And a lot of it has to do with your screen, and then eventually when you print to PDF, or if you even print to paper, it may have different appearances. So you'll want to get this dialed in for what works for you. We will try 60 right now, and that seems good for, at least for this screen. It kind of disappears and lets our electrical items like lighting and receptacles pop out. The other thing I would like to do for some cleanup is that underlay issue. Like right here, you can see that the light fixture here is obscured by the graphics of the sink. Let's go back to our lighting template. And this is good practice to get in and out of here, because this is something you will do quite often. It's good practice to get in here. Hit this underlay and say OK, and let's see what happens to the graphics. Now you can see that our light graphics ends up being placed on top of the graphics for the sink. And this is independent of the dashed status now. So it really helps your electrical items pop out, I think, from the background. So that's a little housekeeping I wanted to do on visual. The other thing I wanted to deal with that I didn't deal with back when I put these lights in is recall that this is a sunken living room. This whole living room and this balcony is below the level of level 1. Now the lights were okay because they're attached to the ceiling. So they just attach to the ceiling. However, these wall mount fixtures we installed over here as 6 feet above level 1. Well, that makes them even a couple feet higher than the sunken level, living room level. Let's take a look at a section, and I need to make sure my section is far enough over with this slider to get this light in there. Now, I've already fixed the switch. And what I mean is, look at the switch. I've already told it to be level 1 living room and 4 feet above that. So I need to do the same thing to this light. So let's look at that section. And notice it's way up here. Level 1 is right here. And let me pull these out so we can read these a little better, because they're overlapped with the architectural levels. Level 1 is at 0, and level 1 living room is down 1 foot 9. So our switch was way up here before I lowered it. Now the light needs to be lowered. So click on the light. And we're going to change its level from level 1 down to level 1 living room. Now that didn't move the light, did it? But what it did do is it redimensioned it from our new surface. So that light is now 7'9" above the living room, and this is where we want to make this 6 feet. So it doesn't move the light, it just changed its relative height and what it is relative to. So now this pulls it down, so now we're 6 feet above this living room floor, which is the same as this deck out here. So we want to do the same over here. Move it down to level 1 living room and get it down to 6 feet. And I believe I already did that with my switch. I finished putting switches in. Yep, it's 4 feet. So we're good there. We finished putting switches in off camera, but we showed how to do that up on the second level. And now we are going to start circuiting. Now, I also want to mention that this is a house, as we know, but in residential, you would many times, to save some money, lights will be circuited on the same circuit as receptacles that serve that room, other than, for example, the kitchen, because kitchen has special rules. But other places, like this hallway, an electrician would typically connect these lights to the same circuit as the receptacles in this room. So we could do that, but like I said at the beginning of this project, I want this to be more of a hybrid project where it's a house, but I'm going to wire it like a commercial building. So yes, it would be more costly, so it's not cost effective, but I do want to show how it's done. So that's how we're going to circuit this up. When it comes to circuiting lights, we have to, of course, pay attention to how many watts are on these circuits. When we put the lights in, we set their wattage, or VA, based on an imaginary cut sheet from our lighting designer. That's what we're going to base these loads on, is what we have here. And these are pretty typical loads for LED lights these days. I mean, this might even be only a 10-watt fixture versus a 15-watt fixture. But this is how we're going to go ahead and hook these up. We already have them set up at 120 volt. So the joy of Revit is it will tell us how many watts we have on a circuit as we go. We don't have to add anything up. So let us just start circuiting. We are going to circuit at least this kitchen and the outside lights, start those on the circuit, and we'll see how we end up. And let's recall that our panel is inside this laundry room. P1 is a recessed panel load center in the laundry room. So we're going to circuit up to that. We only have one panel in this building, so that makes that easy. So click on L1. Now we could select multiple fixtures holding Control key down, and that's one way to do it. My workflow is to get one circuited, and then you'll see the others are easier to circuit, because sometimes you will find yourself in a busy area where you're clicking on the room tag instead of the light fixture, or you're hitting other things. So this is the reason I do it in this order. I will circuit one fixture, and you go to the power button to circuit, like we did on the receptacles, and then you can pick which panel, and you can either pick it by using the drop down, and again, we don't have many choices here. In this small project, there's only one panel, but you can do a drop down, or you can hit the select panel button and then physically touch the panel. And either way, that selects panel P1. Then it will show a dash line, which indicates your circuit boundary. So we've got this fixture and this panel all kind of in this area. It's a circuit. It turns it blue. Now it is ready for me to hit a wire button, which is actually a cable or conduit with multiple wires. We can hit that button to show the home run. But what I also like to do while I have this circuit selected, and you can see I have a circuit selected now, not a light fixture, is I like to give a load name. And this is the name, not a load type, but it would actually be the name on the panel that would say, kitchen lighting. And I'm going to do it like we do with commercial loads. We will put lighting first, and then we go, or lights, and then we go kitchen. You can name it however you like, whatever works for you and your users. And I leave wiring till the end. So I've got that done. Now I can start adding other lights to this circuit easily by just saying edit circuit. Now it automatically defaults to add to circuit. I could jump over to remove from circuit if I want to start removing things, but I want to add things, so that's already picked. And now you will see that all the lights in here that are not on my circuit are grayed out. It's hard to see at that zoom. But this one's dark because it's already on the circuit. But also, now it won't let me select room tags. It won't let me select walls or any other things that might be in my way. It only allows me to pick lights and switches. So let me pick the rest of the lights easily. there, and I don't even have to hold control down in this mode. I'm in light selection mode. So I've got those. And I want to add the switch that controls this area onto the same circuit so that I can show an arc. So click that. That's my switch controlling here, and finish. I've finished circuiting those lights. Now, how can I tell? Well, you can't really tell by looking at it yet. But if you click on a light, and then over here in its instance parameters, down here under loads, you can see it's panel P1, circuit number 18. Revit automatically assigns the next available circuit based upon the rules you have already set up for which order to circuit things. So it's circuited on circuit 18. And let's go ahead and open our panel schedule to follow along with what it's doing. Down here on the left in our project browser, come down to panel schedules. And we already created panel 1 panel schedule back on the power plan. But double click that guy and open it. And you can see here we have our panel schedule. And we haven't gone through and fixed all these breakers yet. We haven't put any down to 15 amps yet. But we can fix that at the end. But here, right here, it's putting them in order down the right. We already went in order down the left. We're going in order down the right. Here's Lights Kitchen. It's our 20 amp circuit. And over here, there's 390 watts or VA on that circuit. So we've got plenty of room to add more lights. So let's go back to first floor and start adding rooms. Look at this hallway. And what I've set up for this one is I put a 3-way switch here. And I put a 4-way switch down here to control these lights. Well, why a 4-way? Well, that's because I'm also controlling up the stairway. There's a stairway up here. Look at the second floor. And you can't see it because this is a ceiling plan. In the floor plan, you can see the stairs. But there's a stairway that comes up here. And so I want these stairway lights and entry lights to also be controlled by those 2 switches below. So I actually have 4 switches controlling this area. So we'll keep that in mind when we circuit. So I'm going to leave those off of this circuit, but I do want to put in the rest of these circuits here. So how do I add to this circuit? I just need to hover over one of these lights that are already on a circuit. And if I hit tab once, it worked. Sometimes it takes a couple tabs, and as you hit tab, you'll cycle through different things. And if you tab, then click. Now I've selected the circuit up here. You can see you're on electrical circuit, and I have options to wire things now. But for now, we want to edit the circuit and add to this circuit. Again, add circuit is automatically up. So now we're back in that same add circuit we were before. We're not going to do the hallway, but let's go do the mechanical room and its switch. Let's do the bathroom and its switch. Now we have a bath fan in here also, which we will need to connect, which we will get to in a minute. We have fans, many small fans to connect. This switch, this light, and that's all I want to add to this circuit. Finish editing the circuit. So if we click on a light, again, we see that it's circuited, but we don't see the load of that circuit. We have to do the hover and tab and click to get into that circuit to now see its information. If we look at the circuit, we can see line by line some of the load information. Now, one thing that jumps out at me is that it's set up with a power factor 0.95. Now, that is set somewhere in one of our lights, I would assume, and it doesn't really need to be. I mean, lighting drivers and such, if you really dig into it, are so close to a unity power factor that it shouldn't be an issue. So that doesn't really matter too much to us, but what all it does is it inflates our apparent load to be a little higher, which is okay too. So we have plenty of room on this circuit to add more if we want. Now, while we're in this circuit, we can try to do some arcs now. Let's see what happens with arc wire. Hit arc. Now, Revit takes its best shot at drawing spaghetti. Now, of actually trying to draw arcs between things. It does a relatively good job. It depends on the geometry of your light fixtures and such. But as you can see, it's arcing all things together, and it kind of picks the shortest distance between them. It's not maybe how an electrician would actually wire it. But again, remember, our plans are diagrammatic. We are just trying to convey a design intent and show that all of these are circuited together. Some people don't even draw arcs on plans. They will just put circuit numbers beside each light. So you can do whichever way you do. But in my experience, I prefer arcs. They do lend some understanding to how things are circuited beyond just circuit numbers. So I'm going to leave them in. But we do want to move some of these tags around to avoid the arcs. Now we can move tags. We can also adjust arcs. And I showed this on the power plan. But there's some controls on these wiring arcs that you can grab this grip here and move it around and kind of shape your arc. I can actually move it over to this side if I want. Now, when I do this, I probably want to move where this arc attaches to my light. And you can see this little blue circle. And it's hard to see when you zoom in because of the lines. They go up to thin lines. And click on this again, you'll see that little grip better. So that grip is actually showing where this wire wants to hit that light. So if you do click on it, it'll move over to it. But you can move this grip around. Move it to the middle if you want. I like to hit the edge, personally, as if it's diving towards the center. But pick the graphics that you like. And this is how I do it. And I'll go back, turn these off. If you need to do some kind of a fancier arc, you can add vertices to this. For now, I'm just going to move things around and get this to look proper. So it takes a little drawing. It's still easier than actually going in and drawing arcs by hand, I believe. Now the light switches, it puts right to the middle of the switch, and I like that to be out at the end of the switch. Be as picky as you like. Now this one is not just a circle grip, thin lines. It's not just the circle. It's actually this square, which is the electrical connection point of this switch. If I was to pull it off of here, I have actually disconnected electrically the switch from the circuit, and we get this arrow like it's a home run. So I have to be careful about that. So we'll just leave that connected where it should. There, it's connected. Even though it's a little bit off of the switch, the connection point is down here rather than at the switch. It's an out-of-the-box switch from Revit. What can I say? So we have the lights. We have this light connected. It has a lot of things tied to it. We are going to be using arcs from switches to show control. So that part does matter. Now, Revit has a built-in switch system, and you can assign switches to lights, but it does not draw arc. It does not label the switches. It doesn't do anything, frankly, except behind the scenes, it's connected. So I don't use that system. I just use arcs. But what it can do is I can force this to connect to a different fixture. For example, this switch leg from this switch to this light, it's not controlling that light, it's controlling this light. I can pull its grip clear over to another light. Now I have to adjust this also. But now I've shown that that switch controls this light because of its arc. Now, does that mess up the automatic draw arcs? Let's see what happens. Hover over this. Now, if I hover over once, you can see electrical network. That's a network, not a system, a network of connected items that are connected to each other. Kind of like if you drew a box, all four lines are connected to each other. It's kind of a chain. That's all that's saying. It's a network. So if I click that, I'm not actually selecting a circuit. I've picked 26 pieces that are networked together in a chain. So I can move all of this stuff if I wanted to, which I don't want to do. And you can see that there's a number of errors that come up. But it's just showing that those are all connected together. I have to tab a number of times to get my circuit to light up. Now, when I'm so zoomed in, it's hard to see, but there's a blue line out here. That indicates that I've hit a circuit. You can also see as I hover, there's a little bit, oh, I'm back. I got off of it and back on, so now it's back to network. So I need to tab. There's the network. Tab again. There's the circuit, electrical circuits number 18. Then I can click it. So it takes a little finesse to get that figured out. I'm back in my circuit. And if I hit arc wire, it doesn't try to redraw this here. It knows there's already an arc connected to that switch, so it's leaving it alone. So this won't mess up your switching arcs. This switch actually controls this light. So now I'm pulling it over here somewhere. And I can put it near the same point. I want to adjust this arc. So again, take some fine tuning to get this done. You could instead just manually install wires. For example, down here in the laundry room, let me delete that wire. Now I can go up to Systems and go to the Wire tool, draws arced wire runs, and just click on the Wire tool. Now I can hover over the actual electrical connection point, which is right there. There's actually a box and an X. Go from there, pick a center point, and then hit the other one. I have to hit the connection point. Now it's electrically connected with the wire or cable. And it does the same thing as doing the automatic wiring. So you can go by hand if you want to. And again, if you do that and try to hit wiring again, it won't redo what you have. If you take it off completely and then go back to the wiring tool, see the dash, it wants to connect those. So it keeps track. It's pretty smart. It keeps track of what is wired and what is not. Now, this big guy here with the arrow ends up being my home run, of course, which means the run from the last fixture to the panel. And it points it towards the panel. In this case, it's putting it right on it. So we can move that to a place that may be better for indicating the circuit. Now, you can see this arc is way off the map. Luckily, they give you this grip so you can tame the arc. So let's do that. And speaking of home run, let's go ahead and tag this. Now, we've already pre-set up our wiring to only show wires on the home run. You can have it set up to show wires everywhere if you want. I find that gets tedious, so I leave it off. But go to tag and make sure your leader is off. And we're going to tag this actual home run. And it's set up like on the power plan just to show the circuit because we only have one panel. And commercially, I would have P1-18. I would have panel name dash circuit number. But in this case, with only one panel, we're just going to leave it simple. So let's see, go through the rest of these and you can tweak these arcs if you want. Again, I get kind of picky about this myself. That goes there, that's fine. And the rest looks good. All the tags are out of the way. So that is lighting circuiting 101. We're going to do the same to the rest of this house. Grab one fixture, hit the power button. P1 is the last panel I used, and it's the only panel I can use, so we're good there. Now I want to edit the circuit and add the rest of my lights. So I'm going to add this. Now these are all broken into individual 4-foot pieces. Now what happened here? Cannot add L2 to the circuit. The voltage for L2 is out of range for the voltage, 120 volt, for the circuit. Okay, you'll run into this now and then where your light fixture is set to a voltage, well, in this case, to the wrong voltage. And notice that on commercial buildings, lights can be, if you have a 480 volt system, you also have a 277 volt to neutral system. So lighting is often 277 volt in commercial, bigger commercial industrial buildings. We can't connect the wrong voltage fixture to this circuit. So we have to just X out of here and cancel editing the circuit. We need to fix this light. So let's edit L2, right here, L2 is our track. Edit and see what we have for voltage. Now, we looked at this when we installed it and noticed that this is a manufacturer's family. And in HIT, we noticed that they have an electrical section that has some voltage and wattage and power factor and poles. And then they have an electrical loads, supply voltage and apparent load. So this begs the question, which one do we use? I have to say this is one reason I don't like using vendor families is because I find this kind of thing happens often, that it gets confusing, and I like to boil things down to make it simple. So apparently this supply voltage is not really the right voltage. And is this even a number field? Yeah, it is a number field. It's not text. But it's not the voltage that the electrical connector inside this family is using. So it must be this voltage. Now, again, I would go in here and get rid of these extra voltages and loads that aren't correct, because I don't even think the load is working. We need to put 120 here, and the wattage we've set at 400. Let's try that. We can save the project every chance you get. So let's try that again. Which fixture? This guy wasn't connected. This guy is the one that's connected. So we want to hover over it and then click it. So we're into our circuit now. Edit circuit. That light works. Let's see if that light works now. That fixed it. That was the voltage we needed to fix. Well, because we fixed L2, which is a type, all L2s follow along. That's the joy of having a type, not an instance. So now we can select all of these. Now, I was just going to say that, remember, these are 400 watts each. That's going to add up quickly. And this is what happens in Revit. It warns you, the total connected load for circuit 20 is exceeding 80% of the defined rating 20 amps. So Revit keeps track of that for you, which is handy. It's a good little warning. And so what's happening is these are high wattage fixtures. So we're going to have to do something different with circuiting. So let's cancel out of this again. So we have 4 of these at 400. That's 1600 watts. That eats up a circuit by itself. I mean, a 20 amp circuit at 120 volt is good for 2400 watts, and 80% of that which is about 1920. So 1600 would work. So in reality, we really need each of these rows of track to be on their own circuit, and we could pop some of these on. So my suggestion would be maybe go 4 of these, and then that guy and that guy, and then we have to think about the switching. We're going to be switching each circuit independently too, and then same thing here. So let's do that, and then we'll adjust their switching. So we already have this circuit. Tab, click, edit circuit. Let's add these 4 and that guy and see how we do. And it doesn't give you a running total or anything like that. You just have to finish editing and then hover over the circuit, click it, and then look. We're at 1609. We are good with that circuit. Now we can label it. I like to do that while I'm here. Lights, living room, apply that. And then I'll hit my arc wire and see what I get. So I drew my home run. I might stretch that out a little bit, and then I'll deal with my arc. And where you put the arc affects how these wires look, as you can see. The other thing I'll note on the wire, a little plus and minus, you can add additional hot wires to this if you need additional wires. Sometimes you need an additional hot because you run a switch leg and a non-switch leg to a fixture and things like that. If we're showing wiring between switches, 3-ways and 4-ways, we would add what they call the travelers, the extra wires that are between switches. So that's a plus and minus for that. Let's go ahead and label this home run, circuit 20, and just check the arcing. Doesn't do a smooth arc depending on how zoomed in you are. What's interesting is that the track, which is from a vendor, the connection point for this track is way down here. See, for this light fixture, the connection point's way down here past the light fixture. So again, something strange in this built-in fixture. So I'm going to have to fix all of these. Again, I mentioned you can't pull this off of here. You get that problem. So what if I do want to change where that hits? If I zoom way in, I can find it. There we go. So sometimes it's a little tricky to get to that grip. But now I have both ends of this fixture, so I can connect it to this light and this light and get that way. So sometimes it is very much a challenge to find that little grip. Now you can see, zooming way in, I found it with thin lines on. We're going to play around with this. I'll go ahead and speed this up. And then this guy, who knows what he's doing. Got all sorts of things going on here. Wire's gone crazy here. But you want to find that circle grip. So something like that. And I'll do the same over here. We're going to wire this separately. Power. The next P1. Edit circuit. Add the rest of these. And you can see it's easy to pick these. I don't have to worry about the L2 in the way. L4, the tags. Finish editing. Hover again and pick it. You have to do a hover again to pick these. It doesn't stay picked, which is annoying. Lights. Living room also. And then also, once you start typing, you can just jump down and click on that and save yourself a type. And let's arc it. And I'll go through and do the same things I just did. I'll speed this up. And there we go. Now we need to get our switches adjusted. Now that we've had to go with 2 circuits, I mean, there's also, of course, a possibility you can use a 2-pole switch, which switches 2 circuits at once. But if you start doing that with 3 ways, it gets to be messy and expensive. So let me fix this arc, fix those wires. What I'm going to do is just put 2 sets of 3-way switches on here. Get back out of thin lines. Right click, let's create similar. Found the wall, and let's click this and hit copy. Recall that I don't use the built-in labels in 3-way switches because it would be inside that wall somewhere right now. The 3 wouldn't, you couldn't see it. So I just use text. However, I do need these to be connected, but let's look at the other end. Now, I had put switches and I hadn't put them 3-way yet, but I put switches at each exit. So if you're coming in from here, you can turn lights on, or if you're leaving, you can turn them off. I think doing it per row works. I could put 2 3-ways here for both and 2 3-ways, or 4 ways, of course, if I do all of that. But I'm just going to put a 3-way at each. We'll say that will work for this situation. As you know, switching can be very much a personal preference. So I just go with what I think makes sense, at the moment at least. So now we need to get these switches added to these circuits. So hover over here, connect it, edit circuit, pick that switch and that switch, finish, and then hover again and click, and now I get my dashes. Now it'll be interesting to see what happens. When you get close to the home run, and you pick another fixture or another switch, it may decide to put the home run from the closer. It did not. Luckily, it chose the fixture to home run, not the switch. And we can always change that around. And again, in reality, they may run a home run to the switch first and then go up to the lights with all the extra travelers, or they may hit the switch first. They may run clear down to this switch with the travelers and such, and then take the switch leg from here back up to the lights. So again, how they wire this is independent really of how we show our design intent of what's connected to what. These are not wiring diagrams. An electrician drawing this may end up drawing it like a wiring diagram, which is great too. This needs to be drawn to suit whoever the user of these plans are. Tab, let's edit circuit, select our switch. And also this is nice, it doesn't try to pick a 3, it lets us select the switch, finish it. Tab, select, arc it. And we can move the 3 out of the way for this guy. That's why I like that being its own thing. We can move the home run. The 22 follows, but we can still move it. And then down here, I don't like the arc that tight. 3 works. So there. Now we also have these exterior lights, which we may want to tie to one of these circuits. Now we've already decided that those lights are going to have built-in photocells, and they're far enough away where they're not going to affect each other in that regard. So we could add both of these just to one of these circuits. It would be the unswitched leg of a circuit, but we have enough room on one of these circuits to add it. So I'm going to go ahead and add them to this circuit. Tab, go to edit circuit, pick these 2 lights. We didn't get any warnings that we have too many amps on this circuit. Finish editing, then we have to select it again, of course, to do the wiring. Tab once was enough. And then do our arc wire. And then we want to fix the arc wire. Now it wanted to connect to that switch, which we don't need. And then we can do this. And fix our arcs. And again, it went from here to here. We could go from here to here. Let's go ahead and do that. So sometimes I like to make it a little more practical than what it's trying to indicate. And then here we have that same issue with the circle. Let's see if we can even find it way in here. Now they're so on top of each other. I'm zooming way in and I'm not seeing it. So, and it put me way over there for some reason. So that's going to be a tricky one. This is one where this may help to get this extended beyond. And then sometimes it'll put a circle out here for me. But I don't see it. Oh, there it is. I went clear over here and it decided that, oh, there's some other geometry you can attach to it. Now it gave me the circle I was looking for. So you have to kind of outsmart the grip. We're good there. This one is going to take some outsmarting. Pull it here so that it draws it over in that little guy there. And now we can get to that arc and draw it the way we like. Again, a little finesse to make that work and move our 3. So now let's go and see what we're going to do with the hall. We're going to make a circuit that spans 2 floors, 2 separate plans. So this is a good opportunity to show how to deal with that. So we can circuit these together first, and then we will go up and add the second floor items. So let's get this started. Pick one fixture, hit the power button. It's going to P1, of course. Let's call this. So upstairs, this is going to be called the entry hall. So I'm just going to call this entry hall, even though it comes down here. Apply that. Edit circuit and add the rest of these lights to the circuit. And we want the switch, the 3-way switches, 4-way switches for this added to that circuit. I can finish adding like that. So there. Now I want to make sure I add these also to upstairs. So how can I do that? I go up here. How can I add those to that circuit? I need to select the circuit first. Well, make sure you have both of these views on tabs so you can get to them. You don't want to have to click over here to get them open, although that works too, but it's easiest, I believe, if you have them both open. So you go first floor, hover over your circuit, select your circuit. If I go to second floor plan, I now, since circuiting is still selected, still open, I can edit the circuit now and finish adding my fixtures. So I've added these and my switches to that downstairs circuit. I'm done. And I'm going to call entry hall. I'm going to put the entry hall over here. Rather, this is kind of a hall just to the back bedrooms. So I'm going to now hover over this, click it, and let's select arc wire and see what it does. It gave me a home run on this level because it will do that per level. If I go downstairs and click and do arc wire, it gives me a home run down here as well, which is way over here. So my way to deal with that is, let's get this moved over where there's a little more room. And you can point home runs how you want. Some people like to point them to the panel. Some people just point them anywhere or all in the same direction. There's many schemes out there. I'll do that for that home run. But I also want to indicate that the circuit needs to continue upstairs. So what I will often do is manually draw my wire from the connection point and send it upstairs like that. And it'll do a home run because it's not connected. And I can just say, with a note, I can say up. And that just is kind of a indicator that this goes up, the circuit goes up to other lights. So now I go to my second floor plan. This home run can be a down. And I can move it over here. There's different ways to do this. So I'll put it over here and I'll just put a text on here and call it down. And that kind of points to each floor. When you're looking at this floor, you can see that that goes down. So to know what circuit this is on, you would have to go to first floor and look at that home run. Let's go ahead and get this arc Get all arced up here. And move the 3 around. This guy hit that. Okay, so looks like we're good there. So that's how you can do multi-floor circuiting. And I have a whole video I'll point to up above that deals with multi-floor circuiting. And it also deals with tagging the fixtures, or in that case, receptacles, for the circuit number that it's on, since you don't have a home run on each floor. Next, we're just going to circuit the rest of this floor, and I'm not going to do that here. I'll do this off camera because it's the same technique. The last thing I do want to show, though, and I can show on the first floor, is how to deal with all of these fans that are in the bathrooms. So let's go down to first floor, and we need to open a power plan because the fans are actually on the power plan, first floor power plan. So, for example, in this laundry room, we have a fan. And we want to connect that to the lighting circuit such that it is controlled with the lights. Now, also one thing I notice, I see all my switches on this power plan. I don't want that. So I need to turn the switches off in this view template. So go into power plan, view template, and let's go to, it's a model entity in our model. And down here, it ends up being, we don't want any lighting fixtures, and lighting devices are what those switches are. Turn both of those off so I don't see them in my power plan. There we go. Now, it does beg the question, if you did want to show a switch on a power plan, let's say I put an independent switch to control this fan. How would I show a non-lighting switch on here? Well, that gets tricky because now I need a switch that is actually an electrical fixture. So you can either find one somewhere or most likely go in and have to edit one and edit the category that it is. So if that's of interest, I can show a video on how to do that. But in this case, we're tying these to the lighting circuit. As you can see here, I already put some notes on this fan. It says to the lights. But I would actually like the load of this fan to be on that lighting circuit so that it is more accurate. So again, I need to go and I'm going to close some of these other plans. What you can do is just go up here to hit close inactive views, and then I can reopen my lighting plan. So I'm going to go to my lighting circuit here, tab till I get to the circuit, and then I'm going to jump over to the first floor power and say edit circuit, and I'm going to add this fan. As you can see, it lets me highlight it. And hopefully, oh, good, it's set up for the right voltage. And there. So now that laundry fan is connected to that lighting circuit. And if I was to hover over it and do a arc, it will try to do a home run. And that's where I can label this note to lights. I'll do it here. I'll just copy this one, copy. And up here, instead of just this dumb arc, I can actually connect that to my circuit and get my home run. First floor plan, again, bath, it's the same circuit actually. Once I select the circuit, go to first floor, edit the circuit to add it, select the fan, and there. Now, what happens if, now look, it wants to connect these two together because they're on the same circuit. So I can simply pull that off and just use what it's put in there as a home run, again, for to the lights, and get that arced. So you kind of have to, again, play around with the system and tweak it a bit to make it work. Now the furnace is its own circuit, so we're good there. And we have one bath fan, one laundry fan, we're good. And so you would do the same thing up on the second floor lighting, second floor power plan to get these fans connected to the lighting circuit. And one last thing I want to show you about the lights too is, I hadn't mentioned before, these switches have a voltage associated with them as well. Now, in this case, it happens to be an instance parameter over here, electrical switch voltage. A lot of these voltage and wattage parameters have been type parameters, so you'd have to go into edit type to fix it. Now, why would a switch be a instance parameter? Well, this is, again, the built-in out-of-the-box Revit switch, and they did it this way. I would say most likely because you can have switches, like I mentioned before, that are on a 277 volt circuit in commercial work. So this allows you to change each switch independently to be its own voltage. Now, our custom switches that I've made for our firm, I have separate types that have the switch voltage in the type, so I don't have to change them all independently. I can just change that type, or you just use the type that's the right voltage. So different ways to do it, but in this case, these are all set up as instance parameters, and luckily they're all set up at 120 volt, which is what we need on this project. So that wraps up the lighting circuiting. Hey guys, this is Rob. Welcome to episode 9. In this one, we are going to work on a site plan. We're going to take a look at that architectural PDF we made, and we're going to create a site floor plan in our electrical model, link that PDF of the site plan to establish the angle of our building from north so we can make that match. And then we're going to customize our view range for a site plan to get the right elevations, and we're going to have to rotate our view to match that angle. Then we're going to insert some out-of-the-box Revit transformer and disconnect families and get those situated in 3 dimensions, insert a custom meter family, and then get those all connected with 3D conduit modeling, including sloped conduits under our slab. And then we're going to finally put in an out-of-the-box site lighting pole fixture and get that elevated and connected to our panel. So an information-filled episode. I hope you enjoy it, and let's get right into it. And here we are in our residential electrical Revit project that we left off finishing up the interior lighting circuiting. So this is our second floor circuiting, and we got that all taken care of. Now we're going to look at a site plan. And so I have the full architectural set here. We can take a look at the 3D view of it, the rendering, and remember we have this second story walkway over to a parking area surrounded by concrete. And so on the site plan itself, first of all, we can see that the whole plan is tilted from north. Here's our north arrow down here, and it's tilted a bit from north. So our site plan is going to be oriented this way rather than the floor plans, which we have turned to a more of a project north so that our plan is vertical, if you recall, like this. So north is a little bit diagonal. So what are we going to have on our site? We have a few site items. Now, we're not doing a solar design in this project. Typically, at least in my experience, that's done by a specific solar expert, kind of a niche solar design firm. We may need to show a feed after their inverters down to maybe a 240 volt connection from here into our panel from their inverters. So we'll get that shown. And we'll say that they have an inverter and disconnect out here on this wall. And then we don't have utility coordination for this fictional project, but let's say that we've talked to them and they're going to set a little pad mount transformer here, a little 122/40 split phase. And then we are going to run it from this transformer to a meter. And we'll put the meter down here on this wall so that they could walk down the driveway and read the meter here without having to go clear over to the property. Some places the meter will be mounted on the building, but we don't have a good place to mount it here. So we'll mount it there. And then we need to run the service lateral from that meter, continue it on under the building, down this slope, into our panel, which is on level 1. Now, we are going to show the conduit run underground. And someone might wonder, well, why do we need to show that conduit run? You won't even see it. Well, we're going to do it for coordination reasons. And a lot of times, at least in our practice, we will show large conduit runs. Of course, not the exact run, because the contractor will figure out the exact run. But we're going to get something that's a possible design that could be built, because we just want to let other trades, and the architect and all the other trades, know that we need something from here to there, and there's going to be a big pipe in the way that they need to coordinate with the other piping, plumbing, the waste lines, and water into the building, and other systems coming into the building. So at least we want to get that in here for coordination purposes. And we'll also show an underground conduit heading out to this transformer. So that's kind of the overall plan of what we're going to be showing here. But let's get this plan set up. And that is sometimes a feat of its own. A lot of architects will draw this site plan with just detail lines or maybe a CAD background. Sometimes they'll actually do modeling where they'll model trees. They will model concrete walls, things like that. It will show up in our plan. So let's go into our project here, and Now, where do we start from? I typically do a site plan as a power floor plan rather than a ceiling plan because there's no ceiling outside, of course. But how do I want to start? I can copy, duplicate my first floor plan or my second floor plan. So part of it is decide what level do I want to base my site plan on. Because it's sloped, it may be tricky to find the proper cut plane. So we're going to start from scratch, and we're going to start it on level 1 and see how that looks. So let's go to View, let's go Plan Views, Floor Plan, and this little button here says Do not duplicate existing views. What it means is if I've already got a floor plan on level 1, don't make another one. Well, we do want to make another one because we're going to call it a site plan. So uncheck that. You can see all of your levels. So we'll click that, and first thing you notice is that, well, it didn't appear here. Well, Revit starts with a default view template, and it tried to make a mechanical plan out of it. So it's probably up here in a mechanical section way up here. So first thing I want to do is get this to the right location. Now, we don't have a site plan view template created, and we may not need one. If you only have one type of plan on your set, you may not need a view template for it. Sometimes I'll create a view template just to be in the habit of using view templates so that I don't wonder, do I go up here to change my view, or do I go down here to change visibility, for example? So we're going to create one. We're going to start with none for now, and then we will turn that into a view template. So the first thing I want to do is get this organized into our project browser. And that has to do with what discipline is under. So if you look over here on the right, go down, you can find discipline, and that's when it assigned a mechanical discipline. Let's change that to electrical. That's a good start. Hit apply. And then a subdiscipline way down here is HVAC. So they really wanted us to create an HVAC plan. Let's go down to power, hit apply. Now that sets up the organization in the project browser to get it down here under electrical, subcategory power, and there it is. And it just calls it level 1. So we can hit F2 and call this, I usually give it a 0 just to put it in the right order, site plan, all caps. And I call this electrical because it could have power and lighting typically on a site plan. Do I want to rename the corresponding level? No, just the view. Thank you. Okay, so there's that. Now an issue is we can't see any of the site stuff. A couple maybe walls here, some walls here, maybe because we're on level 1. So also we may be cropped. So let's see if we have a cropped view. We do not have a scope box associated with this, so it's not a scope box crop. But let's get the crop view, and it actually said no, don't crop it. But we can look at the crop view and see the crop region, and we'll find out that it's way out here. So it seems to be far enough away, this crop view, that we would see any site stuff. So I think it's going to come down to a level. Now, how do we affect the view based on the 3D view and the Z coordinate, the up coordinate? Also, we want it to be tilted like the architect's site plan. So at least to get the tilt right, we are going to need to know what angle this tilt is. So what we can actually do is if you have a PDF plan, and sometimes you'll have a CAD plan of the site or even a PDF, maybe from a civil engineer or your architect, you can actually bring this PDF in and underlay it into your project and draw on top of it and use it again as an underlay for drawing things, and then you can get rid of it when you're done. Some people will actually leave a PDF in the plan if they need it, if we don't have sufficient other information like a CAD plan. So let's see how to get this PDF in. So let's go ahead and up here in the Insert tab up here, where you can link in Revits and CADs, well, you can also link a PDF. So hit Link PDF, and then get to your folder where it is. And we have this one called the Basic Sample Project PDF, and open that. And it gives you a choice of which page do you want to bring in. So this looks like the site plan there. And you can go to a higher resolution. 300 seems to work. Say OK. And it's loading it. You can see the hourglass. And then it wants you to place it. Left click to place the raster image. Well, I can't see my image, so I don't know where it's going, but I'm just going to click in the middle somewhere, do that. And I get the warning, none of the created elements are visible in the floor plan. You may want to check active views, parameters. Okay, so we have a visibility issue. So a PDF happens to be a raster image, it's called. So let's go. We don't have a view template yet. We'll go to visibility graphics up here. And under model category, let's go down to raster images right there. Click on that, and there is our site plan. So it's in there, and we can move it around. Now, one issue is the scaling of it. It appears to be a little smaller than this. So how can we scale it? How can we get it to be the right size? It is just set up with a width and height, and a scale is set up for 96. Now, if you remember CAD days, you had to scale things. 1/8 inch was 8 times 12 is 96. We had a factor of 96. Well, this one is set up for 1 to 200, which is metric. Our plan is set up for 1/8 inch, and that's why it scaled it at 96. What we can do is, instead of being 96, let's just say we want 200 right off the bat. Directly. Hit enter, and there we go. Now let's see if that looks like it is the right size. And just kind of comparing them side by side, they tend to look proper. Well, now we need to rotate our model to match that. Well, you don't actually want to rotate your model itself. We want the model to be the way it came in. So what we actually need to do is rotate our view of the model. So the way you rotate a view of a model in Revit is a little counterintuitive. But you want to grab the crop region and rotate it in the opposite direction that you want to rotate your view. We also want to see what angle do we want to rotate this. So we need to figure out what angle this building is compared to horizontal or vertical. We need to find some lines on this background. So let's take this nice long, I'm going to move this out of the way. Take this nice long building line right here, and we are going to draw with the detail line right on top of this, and we're just going to, we just need to get close. So we'll draw this about right there, and also draw one vertical, and then we can put in a little, we can put an angular dimension. So angular from vertical to there is 37 degrees. So we want to rotate our crop region 37 degrees. But if I rotate it to the left, you'll see what happens. Let me do this. Click it, hit rotate. It wants a center point, so we can just use that center point. Click anywhere horizontal. And then you want to go up to 37 degrees. You can sort of see it in there, 37. When I do that, you can see that my building rotated to the right. It did the opposite of what I said. So I need to rotate my view. So I kind of think of view as rotating your camera. If you rotate your camera clockwise to the right, then the final image will look rotated to the left, counterclockwise. So take your camera, rotate it. Let's go from vertical, and we want to go 37 to the right. That ends up looking like our view is rotated. It also rotated our PDF. So now we need to rotate our PDF 37 degrees, actually to the right, to get it back in alignment. Our model appears rotated. We just rotated the view. So that just shows that we were able to get our view rotated. We can get rid of our construction lines here. And now we have the proper angle on our background. Now we're going to play with the elevation of this view range. So we can look at the north elevation and we can see what our levels are. Here's our levels over here. So we're looking at level 1, and these solar panels are just above level 1. And a lot of this stuff is up on level 2. So I think level 1's going to work. We don't want to draw a level 2 because then things will be underground. So we're at the level 1. So get back to our site plan. I'm going to close the rest of these plans. And we just need to mess with this view range. Remember, view range, bottom, cut, top, and then underneath the bottom is a view depth to see below that bottom level. So right now we're cutting at 4 and our top only goes to level 2. On a site plan, I typically like the top to be unlimited. I want to see clear up to the clouds. And then the cut plane, I typically might like to make it nice and high, way up high, above my building, so I'm seeing the roof on a site plan. It's as if I was looking down from a satellite or an airplane. So I'm going to make the site plan, I'm going to make it like 500 feet, cut plane. And now you can see what I'm talking about. We can see now the roof. We see some of the plumbing fixtures through. So, we see a variety of things, but even though the cut plane's high, we see clear down to the bottom of it. So we can tweak what we see on this plan individually if just the view range itself doesn't work. I notice that we don't see these solar panels. So we may need to take a look back at this elevation to see what category they are. So as long as you have things turned on, selectable here, or you can do the same thing down here, you can hover and tab and try to click on one. There we go. Okay, so it is actually an electrical equipment in the architectural model. So we need to turn electrical equipment back on in our linked Revit file to see those. So again, we don't have a view template. We'll do it up here. Let's go to the Revit links. And right now it's set up just by whatever our host view says. And this brings up a good point that even in our host view, we're going to need to have certain electrical items on so that we can see them on our site plan. When we put our meter in, put a transformer, things like that, we need electrical equipment, electrical devices turned on. So let's go into our model and get those turned on. Fixtures and equipment. That does mean we'll see every single device inside the building as well. And we're going to deal with that in a bit with a filter. But for now, because our link is set up to be visible, display settings by the host view, our model, our electrical model is the host. We are hosting that architectural. So our host view settings determine what we see in the architectural link. So now, as long as we keep it host view, we can see it. If we change this to custom, then we would need to start turning things on and off. But right now, it mimics whatever we do in our host. On a site plan, I don't need to see grids. So let's go in here under annotations and turn off the grids. That turns them off in our model and in the link model because the link is following the host as far as visibility. Now, we don't have contour lines. We may not need those in our plan. People can look at the architectural site plan to see the contours. And let's see what the west elevation looks like. And we can see this extreme slope we have from the parking area. Here's the walls slope. So when we put our conduit in, we're going to have to keep in mind that we have to slope it down to get it underneath the building. So let's go back to our site plan. I think we are good to go with modeling some of our site features. So I'm going to go ahead and get rid of the PDF, at least from here. It's still linked into the project. I just don't have it showing right now on this view. Again, we're going to be turning some of this stuff off here with a filter. So let's not worry about it showing right now, but we do want to get this tagged because I do want that showing in my site plan. So just do a leader tag, point to this, P1. And that also makes me think about, do we have the right scale for a site plan? Well, the architect did 1 to 200, so it was more like a 1/16 of an inch. A lot of site plans are based on civil units, so 1 inch equals 10 feet, 1 inch equals 20 feet, 30 feet, things like that. So it sounds like 1 inch equals 20 feet would be the closest to the scale they used. So we're going to go ahead and change the scale. And again, because I'm not in a view template, I can do all of this stuff directly. And here's all your scales. So you have both architectural scales, which are based on fractions of an inch, and then you have what I would call civil scales, which are based on 1 inch equals 10 feet. So let's go 1 inch equals 20 feet, So let's at least get service into this building. Now, what do we have for a transformer? This is where we're going to start finding out what Revit has out of the box for us to use. We're trying to use as much out of the box families as we can on this project. Again, I use mostly custom content in our own firm's work, but as you're learning Revit, you may find it's easier just to use some out of the box. So let's see what we have. We look down here and under electrical equipment, we have only a dry type transformer. We don't have like a pad mount that you would see out here. So let's go up to our Autodesk Cloud, insert load Autodesk family. We've done this in previous versions, and you'll start with all results, and you want to go down to electrical. And then under electrical, skip the architectural ones because they don't typically have electrical connectors. And down here under MEP, we have electrical power, appliances, distribution, generation, and transformation. So we are looking for a transformer. Here's generators, dry types, transformers, motors. There's a wet type transformer, looks like a pad mount. So we will click on that and load it into our project. And it shows up under electrical equipment right here. And it's a wet type, 12 kV down to 480. Well, we're not 480. So we may have to change all that, but we also are only showing this for the 3D rendition. And that's a point I want to make. As far as electrical connectivity, we've got things electrically, logically connected to the panel in previous episodes. Do we need to electrically connect it to a meter and electrically connect it to a transformer? Well, in this case, we don't need to because all of those devices will have the same load on them that the panel already does. So we don't need to do it for load calculation purposes. We are just going to be doing it for location purposes. You know, what size will we have? We would typically have by the utility for a house, you know, it may be down to 15 or 25 or 50, something like that, small. We're going to put the smallest transformer we can find just again for a little 3D representation. And here it is. I don't know if that's the front or the back. We're going to put it up in this corner here near the street, like right here. And let's look at our 3D view to see what this guy looks like. 3D view exterior down here. There we go. 3D exterior. That's it. And we look up here. And why can't we see anything? Well, where did we put it? Remember, we were on level 1. And we installed it at 0 feet. So it's underground. There it is. Because what's nice is if you click on it here and then jump to another plan, it will stay highlighted and will help you find it. So it's buried underneath the ground. And if we go to a different view, like a wireframe, then there it is. So we need to bring it up to the level of the ground. Well, what level is the ground at? Well, one thing you can do under annotate is you can go to a spot elevation and it should tell you the elevation of that surface. Now, this is an actual, if you tab over this, this is an actual topography called material grass, but it has a dimension associated with it. It's actually a 3D element. So if you use spot, not coordinate, spot elevation, you can get an idea where this is. And we're up at 11 feet. 6. So let's move our transformer up to 11 feet, space 6 is 11 feet 6, and apply. And that pops it up there. Now let's see how it looks with a non-wireframe. Let's go to even shaded. So there we go. Now those two, looks like the two doors of a transformer. So we want to turn this thing around. If you hit spacebar, it'll start rotating it. We may want it at a certain angle. So when you're installing it, let me right click and go to create similar. When you're installing it, if you hold it over an angled line and hit space, it will try to align with that existing line. So that's one trick you can get things angled. The other way is you can actually click on device, hit the rotate, and then start using the rotate. But I like to try to align it. If I already have something in my model, I like to try to align it with that. So let's delete this one. And is this one also at the same? Yeah, it came in at the same height. So we'll put that there. And that's what it looks like. Now it's a little bit buried. We may have to raise it up, and it's going to be on a pad. So let's get this up a little bit higher. Let's go to 12. and apply. It takes a second. There we go. And even 12 seems a little low. And so we'll go a little bit higher, 12.6. And we'll go one more. Let's go to 13. And again, we're not going to draw the pad. We're not going to get that crazy. We'll let the architects and civil engineers, draw a pad for us. But that's good representation of that transformer sitting out near the street. Now we need to get a meter, and I'm going to say the meter's mounted pretty much at the top of this little wall. Now, what do we have for a meter? Again, we don't need an electrical connected meter. We're not connecting it electrically. So what can we use for a meter? So what we'll do is we'll just bring in a custom family that I've already created that we use in our own projects for this one. And I'll link up above to how you can create some of these custom families there. And some of these are pretty basic. So they're mainly just one or two extrusions, 3D extrusions with an electrical connector in some places. And then we're not even using the electrical connector for this meter. You could also put a panel board in here and repurpose it to be a meter. There's a few things you can do. You can just bring in a 3D box. So what I have is a meter. Let me go down here and get it. It's down here under electrical equipment, and it's called ER meter base. So if I drag that in, there it is. And it's the top view of a meter, and the red is a clearance zone for a safe working zone. So this is just free floating. It's not hosted to anything. I can place it anywhere I want. Right now, looks like it wants to go in at 13 feet, which is probably close to what I want for my wall here. So what I can do is hover it over the wall like this, and then hit the space bar, and it will rotate to match what's underneath, which is nice. Now, I don't want this on the face of this curb because it's low. I want it on top of the curb, but I'll maybe want the meter overhanging. So I'll do something like this, and I'm going to turn off the clearance lines in this case. Since I'm outside, I'm not worried about it getting tight with clearances in here. Now let's take a look at this. I'm going to draw a little section right here so we can see the height of this thing. And right here, let's use our section view template. And we can see that it's down in the concrete a bit. It's just a box with a little meter sticking out. Very simple. Now we can just nudge this up. I'm hitting the arrow key, the up arrow key. We'll just nudge it up 1 inch or 2 at a time. And we can do that. And then I can move it to the left just a hair to be at the same face. And I'll nudge it back down. Now, in reality, you would have to build maybe some kind of a post behind it, things like that. I'm not going that detailed in my model right now. If I was to actually show a detail of this and show an installer how to mount it, I might do that. But in this case, again, I'm being diagrammatic. I just want to show the intent. So actually, because I'm going to have conduit coming up through this concrete to make it buildable, I'm going to pull this back a little bit and give us some room. So that is our meter installation, and we can tag it. If we give it a name, because it's an electrical equipment, it actually has room for a panel name, and we will just type in meter base. Now meter's fine in this case. And then use my tag by category to get this guy tagged. Now I'm going to use a leader tagged, and I already have an arrow assigned. If you don't see an arrow, you can click on your tag, edit type, and then here, leader arrowhead, you have a choice of arrows, and sometimes it comes in with none. I like the little filled thin arrow, and I'll put this here. That section line actually won't be there in the final printed product. So now we have our meter, and we can continue on with the rest of our site electrical work. So we've got our transformer, and up here, let's give that panel name. Any piece of equipment, they just call it a panel name, and we'll call it transformer. Apply that, and let's go ahead and tag that as well. And we can give it a little shoulder up there. So we have a transformer meter, and then we have our panel P1 down here, again, which is obscured. This is probably the time where we can deal with our filter to control visibility of our site. First of all, there's a couple different ways we can deal with visibility, and one common way, and I have some older videos that show this, is to use the work sets that are associated with a work shared project. In those, you would go up to your Collaborate tab, and under here you see work sets. And work sets are just a way that Revit groups things into separate groups other than the categories that we usually use. And so that things can be turned on and off visibly, and kind of almost like it helps the performance of a model, but also because multiple people are using it, different users will check out different work sets to be editable, and the other people can't change something that you've checked out. But you can create additional work sets. It gives you 2 work sets to begin with, but you can create additional work sets, and then you can use those for visibility if you want to turn things on and off. Now, there's arguments out there all over the place about which way to go, work sets or not. Again, we used to use work sets. They kind of are cumbersome because every piece of the model you put in has to be put on the proper work set. And this gets back into the CAD days of layering, when things weren't on the proper layers. One nice benefit of Revit, I think, is that it automatically categorizes what you put in so that every receptacle you throw in is in the same category as electrical devices or electrical fixtures. Anyway, so that being said, we're going to use filters for this one. And filters take a little bit of getting used to because it's kind of almost a reverse logic, and I'll show you what I mean. So the general idea is we're going to create a filter for this view that controls what shows up and what doesn't in certain categories. And that filter is going to relate to some parameter that's in the device. So for example, let's just create a basic filter. The filter is going to further separate the categories into subcategories. So I can just turn the electrical equipment off with my visibility graphics override. If I just turn electrical equipment off, it turns it off. And if I turn electrical fixtures off, then I won't see all these receptacles. So there. Problem is, I do want some of these to show. So how do I decide which ones show, which ones don't, when everything is in one category? We need to apply a parameter to each. In this case, let's apply a parameter to the fewer items that I want to show. I only have a few items on the site that I want to show, so I'm going to apply a parameter to those. So let's undo those 2 visibilities so I can get to it. And so let's look at how the filter works. So again, in here, one tab we haven't really looked at is this filter tab. So every view has not only model and annotation control, links, and work sets, you can also hit filters. Now in here, there's already some filters set up for this view out of the box. And they have some, it looks like it's for plumbing. They have domestic, sanitary, vent. Well, we can remove all of these because we are not worried about plumbing in this project. So what this does is you can put a name of a filter and you enable it and visibility and all these different things you can override. We're going to add a filter, but what do we have for filters? These are names. General lighting, general power. We have some filters pre-made. We need to make our own filter for the site. So down here we need to add a new filter. And we can call it something. So right here we go down to new. Create a new, and we're going to call it site. And we know it's electrical because we have an electrical model. So we'll just say site. Now we need to define the rules. Select one or more categories to be included in the filter. So I'm going to include electrical equipment and electrical fixtures that I want to control. So I have those 2 checked, and then it says all the selected, which means all of these selected. There's an AND rule. AND rules must be true. You have different kinds of logic. You can do an AND logic or an OR logic. So I'm going to do an AND. So you'll see what I'm doing here. All selected. Now this gives me a chance to which parameter within these families do I want to check? Well, it says a number of different ones. There's none of them that are called filter. So what I need to do is repurpose one of these parameters that are within my families to check. Now, I could go keynote. What I've decided to do is I never really use model. If I'm going to put a note, even on a light fixture, I may put it under manufacturer, but I don't usually put model using that. Now, you can use some of these others, but I like to use model. And so model, and then I can set up the rules. If it does not equal site, and I'm going to put the word site and say, okay. So I created a filter, but now I need to apply it to this view. So now I need to add, select a filter, select my site. Okay. Now I have the site filter applied to this view, site plan electrical, and eventually a view template. So I'm enabling the filter. This lets you easily uncheck them without deleting them. And the visibility. So what you have to do is look at the logic of this now. My rule is, if it does not equal site, then right now it is visible. So the logic is none of these say site, so it's visible. What I'm going to want it to be is if it doesn't say site, I want it invisible. So if I click OK, now you can see that it turned off everything because none of them have the parameter set to site. Let's turn this back on, and once you do this a few times, it'll start to make sense. So now if it doesn't say site, it's still going to be visible. I go into each piece that I want to show on my site. And again, there's fewer pieces on the site than in the building. So under transformer, go to my type, and down here we'll find this model. I'm using this parameter to be my filter control, and I put site. Apply site. Okay. And then I want to do the same thing to my meter. Go to its model parameter, and now I can drop down and find it. And I can add more words to this. So if I want it filtered different ways. And then one more thing I want to show up on my site is this little panel. And put site under model. Apply it. Okay. Now these should stay showing up because they're in the architectural link. If they're not, then we'll have to go and turn them back on in the link. Now let's apply our filter properly. If it doesn't say site, we want it off. And now we have our panel showing, and our meter and our transformer. We don't have these showing. So now that means we need to go back to our Revit link and actually don't go by host. We're going to go custom, and we want the custom here also, like we've done in the other videos. And we want to turn on electrical equipment, electrical fixtures. So we have those turned on. But what we also need to pay attention to is under basics, that filter will apply to this linked model unless because right here, view filters are by host view. We want no view filters in the architectural link in this case. So, okay. And therefore our stuff shows up that's in our link. We said, don't apply our filter to it. So again, you have to think about the logic of this, but after you do it a few times, it will make sense. So now we have the pieces we want to show. Now the rest of these items we don't want to show. We don't want to show a bunch of plumbing fixtures. So we can actually just turn these off by category in that Revit link. So go to custom, and let's just turn off the plumbing. Turn off the plumbing fixtures. There we go. So now we simply have the roof plan. We have our electrical devices showing. We have a crop region that we can change around. We can bring this crop in a little bit so we don't need to see the whole world. And that will fit on our sheet a little better. And then we can move these elevation views out of the crop so they don't show up as well. This guy is persistent. Get him way out here. There we go. Okay, now we've got that set up. Let's go ahead and get the connection, the disconnect for this solar connection. We're going to say that it's all a separate system and it comes down to a disconnect, which is mounted on this wall. So we'd already loaded this disconnect. We can go ahead and use that. Disconnect is an electrical equipment. Now, one thing we have to be careful of is that we need to make sure that it is set up for the site. So this disconnect, we are going to make sure that it has sight. And we can bring that in and mount it to that wall. And it says it's not on the host face. It's probably a height issue. We can draw a section and see what it looks like. And use our section as an elevation. And what we need to do is make sure that that section, it was not looking far enough, get it past this wall. Now we can see this. And the wall is very short in this instance. Take a look at this. Yeah, see, so that's a very, very short wall. So we may want this disconnect on the other side of the wall in this area here. So let's do this. And to move it to a new wall, I can't just move it because it's hosted. A hosted device can only slide along the wall. I can't move it unless I hit pick new. So I'm picking a new work plane or a new host. And I can put that, let's say we'll put that over here. And that will look, we change our view to look at this other angle. And we can't see it around the building. So we can hold shift and center mouse button and we can orbit. And there's our disconnect switch. So that seems like a more appropriate place for it. So now we can start modeling some conduits. I have a whole video about how to model conduit that I'll link above. We need to put in some sections so we can do this horizontally. We'll start at plan view and we can start by giving some vertical heights. So this guy we know, okay, so we're all relative to level 1. So this guy we know is up at 4 feet and we want to go below grade. So we're going to go, what's the spot elevation of this floor we're at? It's minus 111. It's 2 feet below level 1 anyway. So we need to be down 2 feet plus another 3 feet of cover. So we need to be 5 feet below. So let's go ahead and go to our system and go to conduit up here, conduit. Now, over here we can pick what level it's at, and down here we pick what trade size diameter, and we're just going to be using rigid non-metallic. So like a PVC schedule 40, and that's fine for this. We're just going to be showing a conduit, a pipe, and so the material itself doesn't really matter for our purposes. Now, electrical contractors that have detailers will get into specifics of exactly which kind of conduit is it and exactly which fitting. So we're just going to draw a basic elbowed kind of conduit to show design intent for space planning. So we're going to say that this little solar only needs 1.5 inch conduit. You would base it upon the design you got from your solar installer. Let's say they told us we need 1.5 inches. And we want to go, the top elevation is going to be -5. 5 feet below level 1, which puts us 3 feet below this concrete. So there. Now we can start. Now if I click right on the device, it's going to try to connect it. And I don't typically connect conduits to the device because it makes it hard to change later. And I show that in that video. So I'm just going to get close, like right there. And then I'm going to start drawing it. Now, as I draw, I notice I cannot see what I'm drawing. Well, we have another visibility issue. We're 5 feet below level 1, so we need to adjust our view range. As you recall, the bottom was at level 1 with 0 offset, and then the view depth down below level 1 is set. There's no view depth below, so we need to see below the view depth. So I'm going to go associate level, and I'm just going to go, so I'm at least 10 feet deep. I can see it 10 feet below. So let's try that conduit again. Conduit, it remembers what I did before. Let's get close, and now I still can't see the conduit. So there's some other visibility issues. Do we even have conduit turned on in this plan? Let's go look at this. And there we go. Our electrical site plan does not have conduits and conduit fittings turned on. So turn those on. And let's try it yet again. Conduit. We have everything selected still. Go from here close to this disconnect. And now we see a line. Now we can draw a conduit over to our panel. Now, if we had structural drawings, we would see footings and things like that we need to dodge. We don't have all that information, but we can assume with these walls there'll be footings. So we may go down this way and then come into the panel this way. We're going to do that. Go here and then come in. And again, I don't want to attach. If I attach to the panel, then it's going to give me, see how it shows up here on this little diagram here. I'm at the top of the panel, and now I can move where in the panel am I going to connect. You can do all that, but it connects it all as a network, you call it, or a chain, so that if I move one thing, that all moves together. And I like independent control, so I'm not going to connect it to the panel. I'm just going to right-click, draw conduit. I can continue my conduit. If I already have a piece done, I can right-click on this connector and say draw conduit. I don't want to create similar because that would just create a separate conduit. I actually want to hit draw conduit and then pull it down and get close to my panel without touching it, and you'll see why there. So let's see if we're good with elevations. Now, what you see typically is this green circle, and that's showing the end of the circular end of my conduit. So I want to make sure these views I'm working on are set up for a fine view, which actually shows the 3D size of the conduit. And even that site plan, I need it to be a detail level fine. And you can see it even changed these solar panels, how they look. But now I can see my three-dimensional conduit, a center line, and then two walls of the pipe. To connect this, I need to bend it up and into this disconnect. Well, I can't do it from this view. I need to do it from a perpendicular view. So let's do another section right here, and you'll be doing a lot of sections when you do conduit. A little section here. And instead of having to redo all these settings, I'm going to create a section view based on this, a section view, and I can change whatever scale I want, but I'm going to create a section view template. So where am I? I'm up here in section 10. I'm going to right click this. I'm going to say create a view template from this view. Enter a name. I'm going to give it the ER, and we will call this section distribution. I do distribution because that means I'm drawing conduit and such. So it'll be an extra fine view. And there we go. And then I want to apply it to this view. I already have an elevation. Let's do a section. Now, when I create these other sections, I can simply go to my view template, go to section, and it pops everything in the way I want it. There's my 3D. Now I notice the crop line is not helpful, so I need to get this crop line fixed. Now there's things I can't see. There we go. So I bring it down and now I can see things. Now I can move my levels out of the way, click on my level, and move it out of the way. Now I have the levels from the architectural link showing, so I can turn those off in here. And I do that with Revit links, custom, annotation, custom, and I can turn their levels off. And that way my levels show and I can move them around. Okay. Again, that's the joy of having a view template for this section. There's my little disconnect. Where's my conduit? I need to go down a little deeper. Still can't see my conduit. Well, let's take a look at our site plan and see what's going on. Okay, my section I actually drew on this side of a wall, so I went a little too far away. Let's go on there. Now let's see what happens. Take a look again. Click on this. Well, it looks like I ended up mounting this up at 9 feet. Somewhere in here when I was going back and forth, it lost my height. So I can simply make this back to -5 feet. And because it's all connected, it should move the whole piece. Let's see if this one got moved. -5, yes. So it moved the whole piece that's connected. Now that's another reason I don't want to connect to my panel. If I did that, it would have lowered my panel 5 feet too. So that's why I don't connect them. So let's take a look at this section again. And here we go. Here's our conduit showing up. And it's kind of another slab here. So I'm going to go even lower. And I can just actually take this and drag it down. And we're down around 7 feet. I want to take this conduit and turn it up into this disconnect switch. So I can click on it, right click, draw conduit, and I can turn it up. Now I'm not right under it, but I'm close. I'll go here, and I missed it. Once I draw it, I can change its angle like that. And then if I just grab this piece of conduit, I can slide it around now and get it underneath this. Now we have pretty thick walls because of this scale. Now if I was to change the scale of this and get it to more like a 1/4 inch to the foot scale, which would be, or an 1/8 inch or 1/4 inch, would be a more typical section and detail. So there we go. So I like my section that kind of scale. And I can get it close, actual mounting, they may have unistrut or something on here, but for now, we're just going to strap it to the wall. We're not getting that detailed on this. And then, again, if I pull this up here, it'll connect it. But so what I do is I click on it and just use the align tool. If you just align it to the end, it doesn't physically connect it, and you don't have that issue. This is just a section for a working section. I'm not going to be dragging this onto a sheet. But there we go. We can see our conduit coming up into our disconnect. This is helpful just to make sure everything's aligned properly. So back to our site plan. Now we want to take a look at another section, and we want to bend this one up into the panel. So we need a section that's parallel with the conduit, if you will. So I guess, yeah, so it's a parallel to the conduit. We can just move this guy and use this section. Again, it's just a constructability section. And here's our conduit. It looks like we're still good. We're underneath this lower slab or foundation. So we're going to bend this straight up into this panel. So the same thing, click on it, right click, draw a conduit, get it up vertically, get close, and then I'm going to pull this over to the panel and use my align tool. Align it to the bottom. And there we have that drawn, and we can't see it in this view because it's all hidden. But now we have that shown, and on a site plan, you'll be able to see that conduit run. So it will give other trades, gives the electrician an idea that we need to go from here to here, and it gives other trades the idea. Now, this is not electrically connected. It is just a 3D representation of a raceway system. We don't need to electrically connect the solar panel because they're actually a source. It's just a representation. So now we can do the same thing with our transformer. This is, I think we figured out a 200 amp service. So, it might be a 2.5 or 3 inch, something like that for pulling reasons. So we're going to go ahead and do a 3-inch conduit from the transformer to the meter, and then from the meter into the panel. So let's start out at the transformer. Now let's again figure out what height are we dealing with. A lot of sites will be pretty flat, but others like this one are not. So we need to have an idea where we're at. It's not seeing our surface from this view. So we may have to go to 3D view to get that elevation. I think we kind of knew where this was already. We're at 13 feet. So we can go about 3 feet below this and work our way over to our meter, which is right here. So we are going to start a conduit, draw a direct line underneath all of this slab to our meter. So on the site plan, let's start drawing our conduit. Hit the Systems, Conduit. We're going to go with 3" in this situation. You can pick them from the drop down. And then our upper top is going to be, we're 13 minus 3, we're going to be at 10 feet. If you want to get really picky on a transformer, looking at the face, the primary comes in on the left, looking at the face, and it leaves the right. So we would leave somewhere under this section of the transformer. And that's a point to be made, is that when you're doing any conduit work, you really have to get a little more into how conduits attach to things. So it takes kind of an installer's perspective to do conduit runs if you want it to be somewhat realistic and, not look like you're just making things up. So you may have to look at some photos, look at the cut sheet for this transformer, look at installation manuals for these things so you have an idea where conduits can and cannot come in. So from here, we're not going to connect it to the transformer. We're going to get close here and then down to, again, get close to the meter without going in it. And then we will draw our sections, and I want it parallel with this conduit. So I'm going to do it as parallel to that conduit as I can so that I can turn it up into the transformer. Get our section and move our crop. So here we go. And we're going to go, this is the doors. We're going to go up into this section. So draw conduit, continue it over, and go up into the section, and we can, now because we're not exactly parallel, it thinks we're putting a bend. So if you look here, it kind of is putting a little bit of an elbow in that. So we need to undo that and just drag the conduit where we want, and then we will continue up. And again, get close and finish it with an align. Check our plan view. So we're a little bit too far. This crosses the end of the conduit. We're going to pull it back a little bit. Let's go back a little bit. And I go back and forth between plan and section. That is good enough for us. And then down here at the meter, we want the same kind of section. So just move this guy down. And we'll get this over here, continue it to underneath the meter. Right click, draw a conduit, and bring it up near the bottom of it and extend a line like that. Check our plan. And that comes in right there. And again, that works out well for us. So that's that conduit. Now let's take a look at actually the depth of this conduit and make sure we're okay. The full length. So extend this section, and we have to extend this section view rectangle as well. And take a look at the whole route. Now, as we can see, we did not go deep enough for this slab. So now we can simply pull this down and get it down underneath the slab. And it doesn't have to be too deep. It can be pretty close to the slab. So now we are fine with our depth. And it'll be even more important on this next route when we come way under the building to get up into this panel. Now, some might say, let's try and just run it underneath this bridge and then down in. But we have, it's called unprotected service conductors. There's no main breaker out here at this meter. So there's no overcurrent protection, no fuses, no breaker, circuit breaker to protect this line coming in from the transformer into our panel, because the panel has the main circuit breaker. So code-wise, this is called unprotected service conductor. It has to be outside of the building. And once we come to here under that bridge, how would we could then go down underground and come up. So we could do that, but I really like to have this unprotected service conductor buried out of the way so people can't even get close to it. So let's go ahead and take this down to this area. The same conduit, I can right click and say create similar. It's still a 3-inch conduit. I'll keep it the same depth that it is right now. So I'll take it from this other side of the meter And let's go down towards our panel. And can I do a straight shot? I pretty much can. Look at that. So we'll get close to that panel right there. And then let's get our sections parallel to the conduit. And see what we have. Go to our section. You can see why we have this view template for a section. It makes it very fast to develop a section. And again, we can extend that further. But for now, let's get this guy up. It's going to be pretty much in line with this one. And let's draw a conduit up. Now, it may try to attach to this other conduit, so we have to be a little tricky. We're okay there. Sometimes you have to play games with what's visible, what's not. Get different angles of your section. Looks like we're okay there. And then let's extend this section. We can just extend it here rather than in plan view. Okay, so here we go. This is where we have to dive down and get underneath this slab. Now let's see what's below that slab. So we have to get way down below this slab to get it up into our panel, like we did this other conduit. So how can we do that? Well, we can take this guy and can we turn it like this and make that work? Let's see. It did. It let us. It bent the elbow along with us. So it provided the elbow and the bend just like we need. So now we can bring this another bend and go horizontally. Now, sometimes if you're going to interrupt a conduit you already have, you don't want to touch it because it'll try to connect it. I will tend to go a little bit further or keep it a little bit shorter so they don't interrupt, and I can always back it off. So I can get my bend in here and not be directly under the panel. And then I can move it to where I want it to be. Right there. Check out this, and it looks like we're good to go. And to document this, I would put some notes on these conduits and refer them back to our one-line diagram, which we will eventually continue to add to. So we can just go with some text and just say, I use UG for underground, and this could be in your symbol list when we create that. Underground, service, lateral. And I'm not going to put a size on this because that will be sized on my one-line diagram. Now for this kind of tag and leader, we can leave it as an arrow, but you can also go over here and you can create another type of tag. It's a type parameter. So what I'm getting at is I want to put a loop around this instead of just an arrow. If I just change this to a loop, all of the type 3/36 arrow will have a loop. So I need a separate type that is a loop. So just like anything else, I can take this and edit my own type, duplicate it, and then I can put afterwards, I can put loop to show that it's a different style. And instead of a leader arrowhead, I can go with a dot or an open. I can do a loop. What's an 1/8 inch loop do for us? It does a loop. Now that's a little big. I may just go with the 1/16 inch loop. Down here, let's go to the 1/16 inch loop. There. And that way, that's another kind of a tag and leader is a loop for going around a line or around a conduit. And we also have the same thing here. So I can actually I can do create similar. I can actually click on this note and actually copy it down to here. And then I can rearrange my loop to hit that. And then over here, I can label this. This is more like a feeder. So I can say underground feeder. But put the notes that you would normally put in your project, your company. Your firm may have a method that you want to use. So let's go down to loop and just change it. Again, it's another type that we can easily change to. And this guy here, we will call the solar disconnect. We're going to say AC, just so it's obvious that we're not talking about the DC side of things. All right. So there we have most of our site plan done. The one last piece I'd like to put on this site plan is actually a light, a pole mounted light up here at this parking area to help illuminate that. We already have a light on the wall over here, but this light will be out here, and on the site plan, I want to put it here roughly beside this meter. It'll be in its own foundation out here. So we need to find a pole mounted light. Well, like we're trying to do on this one, we're going to use some built-in out-of-the-box Revit families. So let's go up to our insert and see what we have for lighting exterior. So we need to go to all results, and we're not just electrical this time, we are actually lighting. Click on the lighting tab. We do not want architectural. We want MEP, and we actually want external or exterior. And we have a street light antique and a street light standard. Let's bring both of these in just so we can see what they are. The rest of these are other kinds of lights. We don't need a bollard in this case, which is just a short pole. So let's do that, and let's see what we have for lighting. Now, we also want to make sure we have lighting turned on in this site plan. Escape out of here. And we don't have a view template yet. So let's make sure we have lighting turned on. We do not. So lighting fixtures and devices, let's turn those on in this view. Now what's that going to do? Like it did with our power, it's going to show up here. So we need to apply another filter to only have site lighting showing. So after we get our light in here, we will do that. So let's go ahead and look at these lights. So we can close the whole electrical equipment and fixtures folders. And let's go down to lighting fixtures. And we have downlights. All of our fixtures are here. We can close those so they're not making us scroll too much. And let's see. Here's our street light antique. So, of course, these are all the old halogens and sodium type of things. It doesn't matter. We can change those. But let's bring one in and see what it looks like. And we'll put it right here. And then let's get in our 3D view, because this is another instance where we want the 3D look. So we'd installed down a level 1, and we need to raise that up. But if we click on the light, we look over here, there is no place to put a height. In fact, it's hosted to level 1, and that's grayed out. So this acts like a floor hosted family. So if I go to my section and make sure, yes, we'll make sure I can see this light. Go to this section, double click. You can see it hosted down here to this level 1. I can't lift it. I can only move it along here. So again, that's one of the problems with some of this built-in content is it's not really set up for maybe the way we'd like to use it. So we're going to have to mount this to a different level. Now we can use this level here, which is level 2. And this little, they're not showing the full foundation. A full foundation would go down below grade, but that's okay. We could do that and maybe get close, but we really need a level. And let's make sure our section is as close to this light. We're going to actually put this light over here and get this as close as we can so we can make sure what level we're at. And this won't stick above level 2. I may have to draw my own level. And in this case, because this is level hosted, we will do that. Let's right click on this level. This is what we have to go through to deal with this kind of hosted fixture. And let's put our level like right here. And remember, levels aren't just floors. They are any level within any elevation within your project for any purpose. So if we do this, then we want to move it up to mechanical 4. And that should pop it up there. There we go. And look at our 3D exterior. That looks more like what we're looking for. So we're going to go with that one. The other light, if we take a look at it, it is, and we'll put one right here to look at it. It is more of, a 30 or 40 foot parking light. Let's see what it has for height. Yeah, it's a 25-foot height. It's a little overkill for our residential purpose. And even if this isn't the best looking light, it's a little more residential look to me. So we will use that guy there. And then this will need a type. So let's go back to from our previous episodes, we created a fixture schedule, lighting fixture schedule, a start of it. So we will see that we can go with an L12. We went L1 through L11. Let's do an L12 for this fixture. So let's edit the type. And if you need to see how we did all that, go back to previous episodes and you'll see how we created this start of a lighting fixture schedule. We will call this L12. And we'll look at the cut sheet and say that it ends up being a 150 watt. It ends up being a 100 watt LED fixture. And type mark so it displays the tag properly. It'll be L12. And our description is post top area luminaire. Something like that. We can tag it. We do not need a leader. L12. Now, the only thing we're going to see is that symbol right there, which is not very dark. Again, if I was doing this on my own custom family, I would have an actual symbol that has maybe some more line work to it that's more bold, but that's what we get for now. And then we want to circuit that up to our panel. Now, we don't need to draw a conduit for this one because it is just it's probably a 3/4 inch conduit. I don't typically model anything smaller than like 1.5 inches. We just don't need that level of detail here. So let's just do an actual circuit. So power this to our only panel, P1. Now, what voltage is this at? We didn't check. I think it's just 120 volt. Oh yeah, it was a 120 volt when we brought it in, so we'll leave it there. If you're going a long ways, you may need a 240 volt light, but we're close enough where the 120 should work. Again, this is residential, so that should be fine. And we'll call this lights, and we'll call it parking, the parking area. Apply that, and let's get a home run. And that didn't work. Try it again, arc wire. Now, why didn't the wire work? Let's see if we have wire turned on in this view. Another visibility thing, which again, you run into a lot of times. Wires are turned off. There we go. And it only did one. I mean, I hit wire twice, but if it's already connected, Revit knows that it's already connected and won't do another one. So let's get that over here. Again, I have to remember this section won't be there. And hit a tag for this home run. Go into circuit 26. And again, it's close enough. Revit's not great at voltage drop calculations, and there's a bunch of videos out there on YouTube that explain why. For one single fixture, it may be appropriate, but when you have a whole line of fixtures, it figures all the load at the furthest away element, and it just really screws up a voltage drop calc. But for one single fixture, we can use it. So take a look click on this, and go over to the wire size, and it still puts it at number 12. If we tab over the circuit to actually light the circuit and click on it, now we can see some more circuit data, and you'll get actual voltage drop, which is 0.25 volts. Now, we actually want that as a percent, and if we go into the options, you can see that we set it up for any branch circuit. We will allow up to a 3% voltage drop before it upsizes. So it did not upsize for us. 0.25 volts is of 120, our nominal voltage, is only a 0.2% drop. So we are fine. It's a very small load. It's only 100 watts. So anyway, voltage drop is done, but you have to be careful how you apply it. For a single piece, it's not so bad. Now, the last thing we want to do is get the rest of the interior lights off, and we need to apply a filter. We can use our site filter. If we put, like we did on the rest of the electrical, on the rest of the power stuff, we added that parameter. In here under model, we used site. And let's see, we don't have that into a light fixture yet. So we will add it. So we added site, but now we need to fix our filter. Go edit our filter right here. And we have one called site. We want to edit this filter. And we only had electrical equipment and fixtures. Now we need to add lighting. So we can keep adding, and we don't have devices out here, but we'll do it anyway. We can add that to our filter. So now it filters out also lighting. So you can see how clean that works. Once you get used to filters, it's very convenient and they really work well. And a benefit is you can have multiple filters. So that's my plug for filters. And that should complete our site plan for now until we'll drag this onto a sheet eventually when we create sheets, and we'll add a north arrow and title and all of that. But for now, this is the site plan. Welcome to episode 10, the last episode in this full projects residential series. In this feature-packed episode, we're going to review another method of setting up that site plan that we created and getting it rotated. We're also going to finish up our lighting schedule and show how we can repurpose some of the parameters that are built into Revit to put into our schedule versus creating shared parameters. We're going to add some text notes to our plans. We're going to create a symbol list, symbol legend. We're going to finish that panel schedule, and we're going to finish the one-line diagram and just do some general buttoning up of the project. And then we're going to finally create sheets, fill in the title block, and then we're going to print or extract to a PDF. So lots to come. Let's get into it. I wanted to address a comment that I had from one of the viewers. It was a great point that many times the architectural model is set up such that there is two different north. You have a project north, which is what we use for the floor plans, such that it's a made-up north so that we can draw the plan with horizontal and vertical lines without having some crazy angle in there like you would see on the site plan. So as you recall, in that architectural site plan, we have the building at an angle from this north arrow, which is true north. So true north is up on this page and the building is slanted. And in the previous video, to create our site plan, I showed a method of bringing this PDF into our model and acquiring with just lines and angles what angle this is tilted at and setting things up that way. But like the viewer pointed out, if the architectural model is set up properly, we can acquire that angle directly from the architectural model and set our site plan up for that without having to go through this PDF scenario. So for example, we go back to the site plan, and to bring that true north value, again, which is set up behind the scenes, it's set up by the architect in their model, and it's set up with survey points, things like that, that I'm not going to get into in this video, but they set that all up for you so you can just acquire that point through Revit. So if we go up to the Manage tab, there's a little button over here called Coordinates. And it says it manages coordinates for linked models, which is what we have. We have a linked architectural model. So if you click on this drop down, you will get to a number of different things you can do. You can acquire some coordinates from a model. You can publish things. You can reset. All these things. We want to acquire coordinates from the architectural model so that our model will match. So we go to Acquire Coordinates. And then at the bottom left, it says, select a linked project from which to acquire shared coordinate system. So we want to acquire from this linked architectural model. So hover over it so that it highlights like that. And here's our linked architectural model. Click it. And it says here, coordinates acquired from the RAC Basic Sample Project, which is our architectural model. And so it acquired the coordinates that quickly from our model. So now how do we deal with this? Well, just to show you the contrast, go back to the first floor plan. One thing we haven't talked about within our view template, or if you don't have a template, it would just be up here, is the coordinate system that it's using. If you go down here, you'll see orientation, this line right here, which is included in this template, project north. You can see that there's project north or true north. Well, the floor plans are set up by default as project north, and that makes them vertical and horizontal. So our site plan right now, if we go to our view template for the site plan, it is also orientation project north. Now that we have acquired coordinates from the architectural model, we can just change this to true north, and that will instantly, right there, orient our plan to be relative to true north, so that true north is vertical, which tilts the building. This ends up being the same thing we did by manually rotating our view. And I really wanted to show you in that video how to rotate a view for other reasons if you need to. But this is actually the best workflow to accurately set up your site plan such that it is properly oriented. So I just wanted to cover that and show you this is the actual best method for moving forward. We also need to finish up our lighting fixture schedule that we started. So if you recall over here under schedules, we have a lighting fixture schedule. And first of all, if there's a schedule that I'm going to drag onto a sheet view that I'm actually going to use in production, I like to make it all capital. So I just go through it and change to lighting fixture schedule. Simple as that. And double click that to open it. This is our schedule, and we can hold down the control key and mouse scroll to enlarge it if you want to see it. That's better for the video. So this was our lighting fixture schedule, and we simply went L1 through L12. And we have some placeholders for lumens. We have some basic descriptions. Now, depending on your company standards, you may have other columns you would like to put in here. Now, we typically include more than this. We also include things like the housing construction and the optics. What kind of lensing is there? What kind of distribution pattern is there? And then we also include things like what type of driver is it? Is it a standard driver, or is it maybe a dimmable driver, remote driver, things like that. So you can add more columns. That's the easy part. Now the tricky part is what parameters will you use for those columns? We only have so many parameters in our lighting fixture families that we mostly brought in from Revit's out-of-the-box library. So let us review our lighting plan. First floor lighting. And let's take a look at one of our lights. Now, we can also get to these lights down here in our project browser under lighting fixtures. And as you recall, we made our own lights and gave them our own names like L12. So if we double click L12, look at its type properties and type parameters. We have a number of parameters under identity data. We used model to help filter our site light fixtures. So that's already used. Now we can use manufacturer, and then maybe this is appropriate for housing, but we won't find a housing, we won't find a driver, we won't find, a notes parameter built in. Now, an advanced topic would be to create some shared parameters in each of these lighting families that we can then schedule. Again, that's more advanced, and that takes family editing, which eventually you need to get into. But for now, as a beginner lesson, we are just going to, what I call, repurpose some of these built-in parameters and use them for whatever we want. I have a whole video on doing this, which I'll point to up above in that link up there. But I'm going to show you the basics of how you can, from a beginner's perspective, we can just use some of these parameters to do other things. So for example, let me go back to my schedule. If you recall the way we deal with this schedule and add more columns, these are called fields. So we go over here to fields and hit edit. And here we already have the fields that we're using, the type mark, lumens, load, and description, as you see up here. Let's bring in the manufacturer parameter and say, okay, and it adds it. Now we don't have to leave this as manufacturer. We can change this to whatever we want. So we can call this something like housing. That's just a heading. And then we can type in here whatever we want. So again, we are under the basis that we have a lighting designer that has given us the lighting design and given us fixture cut sheets that describe these light fixtures. And so we just kind of want to reproduce that. So let's say this L1, the suspended linear, is just a extruded aluminum housing. And we might give dimensions. Now, when I hit enter, it lets me know that this change will be applied to all elements of this type L1. Since L1 is a type, it will apply to all the L1s, which is what we want. I'm going to shrink this a little bit. So, extruded aluminum housing. If we go back to the L1, which is a pendant lighting fixture, we can open all these up to find it. There's L1. If we double click that, here's the type properties and parameters. Now we can see that it filled in extruded aluminum housing into the manufacturer parameter. So again, we're repurposing that. So what are some other parameters that we could possibly use? There's some type comments. There's a URL. Cost would be probably a number, but we can use some type comments and the URL. So let's go to, in our schedule, we can go to type comments as our optics. And then here we can put in the optics of this, and we will just say, we'll say that this suspended linear is a 20 up, 80 down type of direct indirect. So that works there, and we can stretch these out as we like. And then the last thing we can do is add one more for the driver, and let's see if we can use this URL, repurpose that guy. So I'm just going to reuse the URL for my driver comments. So down here at URL, move this over. Okay, and driver, and you can see that this is already in here for some of these. So driver, we can just say 10% dimming driver, 10% dimming. So that just gives you an idea. I'm not going to fill all these out, but you can get the idea that this is how you can create this lighting fixture schedule to have more fields, more columns, and repurpose them without having to get into each fixture family and edit that and create these shared parameters. So that's kind of a shortcut beginner method to do this. Another thing I'd like to cover is if you've done electrical designs before, you've often wanted to add some notes to a plan. And you can actually just type these notes in and point to them with arrows, or you can have a keynote of some type where you have a symbol pointing to this, and then the symbol is reflected up somewhere else on the sheet to describe that keynote. Now, Revit does have a built-in keynotes system that you can learn to use, and it relies on an external text file and things like that. I think if for a beginner, and the way I actually still prefer, is to just have my own symbol and my own notes without them needing to tie together. I find that I'm still able to keep those coordinated without the keynote system. So I'm just going to show you the shortcut method, and that is either have a symbol, a custom symbol, which is the way we do it, or when you, again, as a beginner, and if you don't want to have to create a custom symbol yet, you can just use the simple version that I've seen other engineers actually still use. It just say note 1. If you say note 1 and then use the arrow to point to it, then this doesn't take a special symbol, and you can just type your notes. Now, where are you going to type your notes? Should we type them here in the view? Well, that's not recommended. The best way we found to do this is to either type them directly on the sheet, which again, I don't recommend as much, or create your own notes as a drafting view or what's called a legend. Now, the difference between a drafting view, which we have for our one-line diagram, if we go up here, drafting views, one-line diagram, the difference between this drafting view and a legend, they are both an annotative type of view, but you can only have this drafting view dragged onto one single sheet. Now for a one-line diagram, that works fine. But for something like a set of notes, if you have a project that has repetitive power plans, like we may use the same notes on first floor and second floor power plan, we can't drag a drafting view onto both of those sheets when we eventually make the sheets. So we want to make it a legend. So that's the difference. A legend will let you place a legend on multiple sheets. So let's create a legend. You can do it from here, or you can go down to View and then go to Legend. Give it a name. And I'm going to call this Power Keynotes. And the scale won't really matter too much. And I've created a new legend now. It's empty. But I can just start typing. And I can say 1, suspend fixture at 8 feet above finished floor. Now this abbreviation we will put into a symbol list or symbol legend. So something as simple as that. And then you can put a heading up here, and you can line these up with that little blue dash and just say something like keyed notes, power. And if you want, you can have this underlined. There's some text options up here, bold or underlined. You can make it bold if you like. And that will help that stand out. Now, this legend, we can actually drag onto a sheet when we get into creating our sheets. But this is a way that I like to create my keyed notes or keynotes rather than just typing them onto the view or onto a sheet. Because then you can rearrange them and you can use them multiple times. So I just wanted to show you that's how we are going to handle keyed notes on this project. Another thing we need to do to finish this up is create a symbol list or a symbol legend. Now, when you eventually get to the point where you create your own project template or project template file, the best practice is to have this symbol legend in that template, or at least in your library of details, so that you don't have to create it each time. But for a beginning project and you're just learning how to do this, I'm going to show you how you can create a symbol legend. So let's go to Legends. And again, a review of Legends is we can place this legend on multiple sheets. So sometimes you'll want this legend on each sheet. I prefer to just place it on one sheet personally, but some people use it on multiple sheets and some clients require that. So I make it as a legend rather than a drafting view. So let's go to New Legend, and we will call this Symbols. Now, how do we get our symbols onto here? So let's see if we can drag in some of our light fixtures to start with and see what happens. I'll bring in L1, and that's promising. Now I hit spacebar, I can't rotate it. So let me just place it, see if I can rotate the symbol, because, you know, along with the L1 3D geometry is an actual two-dimensional symbol. So we should be able to deal with this, and hit rotate, and there's a center point. Start at the right and click vertically, and it doesn't rotate. Let's bring in a electrical fixture. Let's get our standard receptacle in here, see what happens. There's a receptacle. Well, we get the symbol, but we also get the extrusion. And see if I can rotate this one. And I cannot rotate it either. So just dragging these 3D elements into a drafting view is not going to work for our symbol list. It's an advanced topic, but what you can do is you can create custom families that are just the symbol that can be brought into a symbol list. Now that's something you may want to do, but often the easiest way to deal with this is just to draw your symbols with drafting lines and go from there. So we can have this as a reference, but what we need to do is go to annotate, and with detail lines, recreate these symbols. And for the scale, you may want to go to a 1:1 scale, 12 inches equals a foot. And you can see here that at that scale, it doesn't even show these symbols. But this way I can draw them at a true paper space size, which is typically what a symbol list is. So let's go to a circle, and I want this about 1/8 inch diameter. So I have to really zoom in here, and I can do that, click on it, and then just type in 1/8 inch. There we go. And then I can put some medium lines works. I can put a line starting right at the bottom. Do something like this. I can move this over here, and then I can mirror this and create my own own mirror line somewhere in the middle. Something like that, you know, and I can adjust these as I want to make it look right. So you're really just going to have to go through and kind of draw your own symbols. And for the light fixture, we can do something like get a rectangle in here and maybe get some dots, small circles to show the pendant. And there's a certain minimum size that things can be. And I think it's like right there. And then you can again mirror this. Mirror by drawing an axis. And the axis, it'll kind of snap to the center line. So there's a light fixture. And just draw all the symbols that you used in your lighting plan and floor plan, and even in your single line diagram. We've already drawn symbols by hand because we don't have a one line diagram package of symbols. So we can take this, and you can actually Control-C, copy this, and then go to your symbols and actually paste it in, Control-V, paste, and that will come in. And it was drawn at, 1-to-1 anyway. So at least we can do that, and then continue to draw your symbols, and then right next to it, you can type what they are. This can be duplex receptacle, and put whatever you would put in your symbol list. Sometimes for residential here, it would be about 12 inches above finished floor. Or if you're doing commercial, it would be more like 18 inches, things like that. So you can just create your own symbol list and give it a title. If you want to bump that up a size, click on it, go over here and find your 1/4 inch, or you can customize this, make whatever size you want. And then you can simply draw a box around it. And you would do this for all of your symbols. But basic symbol list is just drafted. Again, you'll want to have something like this in your project template so that you don't have to create it on every project, and you can add a symbol or delete symbols as needed. So that's how we get the symbol list set up. Now we need to take a look at our panel schedule. We only have the one panel in this project, and button that up, make sure it's all ready. It's pretty close to done. We can make sure we have the proper circuit description for each of these, because if we didn't type a description in when we circuited, we could end up with just a miscellaneous name. So we also want to check breaker sizes. Now, again, in commercial work, 20 amp breaker is typically the smallest you see, except for small motors where we'll have a 15. But in residential, we use a lot of 15 amp breakers to save cost. Now, you can do that here. Like I mentioned at the beginning of my project series, this is a residential style project, but I'm doing it in more of a commercial method just to show those methods. So I could just leave these all at 20 amp, but I will change a few. So that for the standard receptacles, we're going to make these just 15 amp. So you can go through, and this is how you do it. You just simply change it here. But you can change these values here, or even in the floor plan. If you hover over something on this circuit and hit tab a couple times, you'll get to the electrical circuits. The little note right there comes up. Tab, electrical circuit, and then click it. And now you've selected the electrical circuit. And down here under rating, you can adjust it here. And we're not showing what frame it is in our panel schedule, so we're not so worried about the frame of the breaker. These are all the 100 amp frame breakers. But you can change it there. I like to change it here. So again, let's go 15 and just go through and change these how you want. And we have our main set up right. And instead of 225, let's say that this is just a 200 amp load center. And we do have a main circuit breaker. This is a commercial load summary. As you see down here, it's applying commercial demand factors. So it comes up with 157 amps for a total estimated demand, which is within our 200 amps. I show in other videos how I've created a custom load summary for residential calculations, which I will also point to up above if you want to look at that further. But for this project, we're going to leave it as a commercial style panel schedule because that is what most of our work is. Another thing we need to finish up is our one line or single line diagram that we had started prior. And it's up here as a drafting view under coordination. So double click one line diagram, and this is what we have, a very simple diagram for this single panel house. So we have the transformer, which we've already labeled. This would be the meter. So we can start labeling the rest of this. And depending on how you do things for your designs, you can label these as you want. But really, this is just done in this drafting view with lines and text. And if you have symbols, you can use symbols. We can line these up like this. You can just label these how you want. And we can call this meter base. And again, just label these how you want. And you can add leaders up top to your text with the left and right leaders. You can get rid of a leader up here with this minus, remove leader. And just get these things lined up. It gives you some little construction lines here, the little dashed to make things look pretty. Let's go ahead and label this as the load center. And again, whatever you do in your office, let's say the way you did things in CAD, you can do similar here, and it's a simple drafting view. I find drafting views in Revit are very easy to deal with. If you want to label these service laterals, you can do that as well. And let's say we want to label this with an actual size, and coming from the transformer to our meter, let's say that the utility is going to furnish the conductors. We just need to provide a conduit. So we will just say 3-inch conduit only. And then you might put things, again, whatever you do, you might put things like minimum 36-inch bury, but whatever you put for a note. Now on this one, we have this arrow. And like we saw on previous episodes, we can change this from an arrow to a different kind of symbol. So if you click on this, and then we can go to a drop down on properties, we already created a type of text that has a loop. So click on loop, and you'll see you have this little loop that you can move around and use that for looping around a single line. And the way you create that, if you missed it in a previous video, is you just go to edit type, duplicate it, and create your own name called loop. And then under the arrowhead, leader arrowhead, you can select from the drop down different kinds of arrowheads, boxes, diagonals, filled dots, all kinds of things. And this is, we chose loop. So that's how we did that. And then here you can label this one, but it's a simple diagram. It's just simple text with arrows and loops and some symbols. But that would complete your one-line diagram, and we will drag this onto a sheet. A couple things I wanted to finish up on this first floor power plan are a code issue that has been nagging me since I created this, and that is this guy right here. That is a big old column right through the middle of the project. Now, I'm not sure what purpose it serves. It doesn't appear to be structural. Let's take a look at a 3D view of this. Let's go ahead and turn off our selections so we don't select the model. And I'm going to just select a box like this and go up to this little view button up here called selection box. It isolates the selected elements in the current view and does a little 3D view of that. So there. It created a little 3D view of the area I surrounded, and it gives me this section box. Now, if you can't see this section box, and sometimes you can't see it, you need to go into the VG graphics and get that turned on. So it's actually under annotations, go down to the S's, and you will find section boxes, and it may be turned off. So make sure that gets turned on so that you can see this section box. And then when you click on the section box, you can drag the cut of that section where you want. So this is a nice little way to draw a small 3D section of an area. But I'm doing this just to show this column. And here's the top. It doesn't even go through the second floor. It is purely on the first floor. But it's a column, and technically, if you look at the NEC and read those rules, you will see that this is counted as a wall. Just as if I had a square box wall in the middle of my room, that is wall space that's greater than 2 feet. So I need to get a receptacle on there. So let's get a receptacle on this guy. And it's just going to be a standard receptacle like this. So right click, create similar. And luckily it is treated like a wall. So it lets me host my face hosted receptacle to it. So let's see, where do we want it? The other issue is how many would we need? It depends on the linear circumference, in this case, of this circle. Well, one way to figure that out is hover over it, get these back on, hover over it, and see if we can see the circumference. Now, we don't get the circumference of this over here. So what we can do is draw our own circle, and this should snap to the middle. Draw it out here and get the same size. Now if we click on this, it shows us the length of this line, which ends up being the circumference, is only 10 feet 3 inches. So it's less than 12 feet. We only need one receptacle on it. Get rid of this. So we will just draw one receptacle, create similar, and I'm going to put it on this north end of this so that we can use it out here. So right there, something like that. And I want to tie it into this circuit, and it would feed most likely, underground, under the crawl space. So tab, get to the circuit, edit circuit, add this guy, finish editing. And then again, tab to the circuit. It wants to draw the wiring. Click on there, hit arc wire. And it wants to put the home run here. Now, you can let it do that and get rid of this home run, or you can just say, I like the home run I have, and just delete this. So that's the way I'll handle that one. But it added it to circuit 16. I just wanted to address that one little issue. The other thing I want to address on this is we had already in previous episodes drawn some conduits into this panel. And this is how they show up in a plan view. I don't really like these giant green circles in my drawing. A couple ways I can deal with this. I can just turn conduits off on a power plan. Some power plans you actually want to show conduits. You may want to show some distribution on it. Other times you may have a separate view, a separate plan that shows distribution. So you have to make that judgment call. I'm going to keep conduits on in here just in case I want to show them somewhere. But what I can do is I can change the size of this symbol. And this is just simply an up-down conduit symbol. It's like looking down into the tube of the conduit. So if I just go up here to Manage and go to it's an MEP setting, Electrical Setting. Down here, if I go down to Conduit Settings, it's not here, go down to Rise Drop. Conduit rise drop annotation size. That is what this thing is. And it's drawing an 1/8 inch in paper size circle. And I don't need it that large. So let's pick something like maybe a 32nd of an inch. Tiny's fine. So that there is it's not too prominent. It's not obscuring the panel. I think that's fine. Again, I could totally just delete the conduit from this plan, but I'm going to leave it on. But that's one way you can deal with those sizes. You don't have to have this giant 1/8 inch circle. Another finishing touch for this power plan, first floor power, is down here where I had not added these floor receptacles to my circuit. So I need to add them. I already did it over here. But on this one, I want to show you something to deal with wiring. We already have wiring shown between these two receptacles, and we want to add this guy in between them. So first of all, let's get the receptacle added. So let me hover over this receptacle, tab a few times until we get to the circuit. Click the circuit. Now we're editing a circuit. Edit circuit, and it's by default going to add to the circuit if you recall our circuiting. Click on this guy and then finish it. it's added to the circuit. Now I want to wire it. If I leave this wire in place and hit tab, it wants to draw it a line in. Let me do that. It wants to draw a wiring arc from the closest receptacle, which ends up being this one down here. Well, I don't really like the look of this coming back, and I really like this to come from here to this one to this one. So the way I can do that is get rid of this, is I have to actually delete this other wire. Just hit delete. Now, when I hit the circuit, you can see that it is redrawing these in a more logical fashion because that other wire is not there. And then I can take this and move it as I want and move the endpoints like we did in the previous episodes. So I just want to show you that's one method that you can have the wiring automatically generated to your advantage. And a similar approach down here, a branch over like this should be fine. So I'm going to leave that. Unless I want to go from here to here to here, I can rearrange these myself. But I'm going to let this do what it wants. I need to add it first. And then again, have to reselect the circuit, get that guy. And I decided I want to pull him up here and move these grips like we did before. So I just want to show that's one way you can get this wiring to show more like you want without having to manually move it around. So now that we have all these beautiful looking views and plans set up and schedules done, we need to drag these onto sheets so that we can create PDFs or print these on paper and make them useful. So how do we do that? Well, down here in the project browser under Legends and Schedules, Panel Schedules, you'll see Sheets. And right now we have none. And that's right above Families. So we can right click, depending on which version you're in, you can right click and say New Sheet, or you can go up to View. It's another view option. And then over here, there's a sheet, creates a page for a document set. Click on Sheet. And depending on which title blocks you have in your project at the time, you can select one. The out-of-the-box Revit template that we are in right now does come with a size E1, 30 inch by 42 inch title block that we can use. So we'll use that. Say OK, and it just creates a sheet, puts the title block in. It's pretty much blank. Under our sheets, if you expand it, you'll see a sheet that it just gives a number to. You can right click and do a rename, or you can even click it and hit F2 to get to the sheet title renaming. We'll call our first plan E100, and that will be the electrical cover or electrical symbols, whatever you want to call your first sheet. And then we can drag our symbol list into that we've started. And we only have a partial symbol list right now. But eventually you'll have your full symbol list that you can bring on here. Now there's a couple options for this view title. It takes the default up here of called viewport 1. You can create other kinds of views where maybe you don't want the title, or maybe you don't want a scale. Maybe you want this to look differently. So that can be done. And I'll have a whole separate video on how to deal with sheets and view titles and customize that. Because again, sometimes we don't even want the scale, or we don't even want a title. But in this case, we don't even need a view title. So we can set this up for a none. So duplicate this and let's call this none. And the view title will be none. Show extension line no. So our none will just be blank. We don't need a view title just for a symbol list. And again, this is just the start of our symbol list. And then we can create some other sheets. So let's create another sheet. And once you've created the sheet, you'll see down here that it shows what has been dragged onto that sheet. So it shows that the legend called symbols has been dragged onto that sheet. And you can actually get to this legend from this sheet list right here. Now I open it just as if I went up to my legends and hit symbols. So that's another way to get to that sheet. You can also, on the sheet, double click it, and now I'm editing the legend. I can't edit the sheet. So it's like I've popped into kind of a viewport. And if I need to get back out here, double click over here and you're back out to your sheet. So I personally think it gets a little confusing to do it this way. You forget which one you're in. So I prefer to either click fully into the view this way or through the project browser up here. But that's personal preference. Let's create another sheet, a new sheet. Okay, now we're going to call this one E200. And this will be first floor plan, lighting. And you can put these in whatever order you would like. And then we can drag our first floor lighting plan. We just hold it, drag it over, let go, and see how it looks. And then place this anywhere on your sheet you would like. So I'm going to kind of center it here, leave some room for maybe city comments in the upper right. Click it on there. And luckily our scale was set up properly so that it fits on the sheet that we have. Now, if you go down here, you'll see that the title comes in the same way that the view was named. So we have a 1-. You may not want that actually to show a 1-. So you can just click on the sheet and you can come down here to the right under identity data. You have the view name, which is the name from here. And then under that, you can have the title on the sheet and it can be different. And for me, it's typically the same, but without the 1, or maybe I had a shorthand name for the view name and actually I want a full name. So I'll just go first floor plan lighting and apply that. So you feel like you've typed it twice because you had to name the sheet and you had to name the view, but that's typical. And it shows our scale. There's a couple ways to pick this stuff. You can click here on the view and that will let you move the whole view. Undo that. However, if you escape out and just click on the view title, now you can move it independent of the view. See how that goes by itself? Let's undo that. If you select this view and move it, everything moves together, the whole view. But if you just select the view title, it moves by itself. So perhaps we want to get that moved differently, and now we can move the whole thing down. So you have some variety on how you can do that. You can also click here and get to these little dots at the end, and so you can shorten this up if you want to. Maybe you just want a short little line instead of going clear across. So you can mess with that. So we'll set up all of our sheets in the same manner and just drag them over. And just as a note, like I mentioned before, most views you can only drag onto one sheet. I cannot create another floor plan lighting and drag this same sheet over. The only thing I can repeat over here are these legends. So for example, I put a legend on the electrical cover. I can also drag this legend onto this sheet, but I can't drag this floor plan again. This view is already placed on that sheet. So to place a similar view on a sheet, you can use the duplicate view or duplicate with detailing. You can also duplicate as a dependent. There's other view commands we can do to deal with that, which we would cover in another video. But for now, we've got our sheet named. Now, how can we get owner and project name in here? Now, we could just jump in here and start typing these things in. However, we know that our architectural plan is already set up. If we look at the PDF, you can see that it's already set up as sample house. So we can just bring that data into our model from there. The way we do that is under Manage, Transfer Project Standards, right there. And it's bringing it in from the architectural. It knows that we already have this architecture model open. So all these things, there's even things like browser organization and all these different settings for systems, even conduit sizes. So let's check none. All we want to bring in is some information about the project. So there's project info and project parameters. We want project info. Say OK to that. And it brings in energy settings, project information, and some shared site information, and just overwrite what we have. And what that did is it brought in the title block information, Autodesk Sample House. Or on a more complicated name of a project, which may have the address and things like that, this is very handy. And then under here, you can put your issue date, you can put who is drawn by, checked by, all of this information for the title block. And that is repeated on every sheet. Go to electrical cover, that information also got brought in. So let's go ahead and make that site plan sheet because we were concerned about the scale and how that would look. So let's create a plan here and call it E101 Site Plan Electrical, and drag this site plan and see what we get. Okay, so it looks fairly small on this sheet. So the scale we selected, 1 inch equals 20 feet, is a little bit too small. So let's see what happens if we bump this up to a different size. Now it's already on the sheet, so we can just leave it there, but let's go into our site plan. And we have this set up as a view template, so we need to change the view template. Let's change it to 1 inch equals 10 feet. And we may have to go through and adjust some of these leaders and notes, but right now they look like they're okay. And let's see how that looks. Let's see if it fits. It's a little bit big, but we can adjust. Looks like we have some room up here to adjust the actual plan. So again, we can get to the plan from here, get to the view, and let's go ahead and bring this down to here. We can bring the sides in a bit with our crop region. Let's try that. There, that looks like it's fitting better. Now we have this we can deal with, and this is too short. One thing I would say is you can just delete this off here, and all we've done is taken it off the sheet. We haven't deleted the plan. Go back to the site plan, re-drag it in, and it will resize the view title to the size of the window or viewport automatically when you drag it in. So that can save you some resizing. So that looks much better. And then our view itself, I think our notes work. This is a little bit away, but that should work. And our light and our home runs, I think everything looks okay in this scale. And again, these section cuts that are not used, that did not get dragged onto plans, will not be there when we print this out. I'll go through and do the rest of these sheet setups off camera, and we'll go from there. And now that we have all of our sheets created, we need to create PDFs of these sheets. As of Revit 2022, there's 2 different ways to do this. The first way, the way we used to do it, is to just use the print function, and then you can select a printer such as a Bluebeam PDF type printer or Adobe and use that. And then what we do is we have the file you want to name it and the print range, and then things like the settings like the sheet size. So first thing, we select our printer, and then I jump down here to the print range, either the current window, which would just be this sheet that I'm looking at, or selected views and sheets. Now you can create, if you hit select, you can create a set of, in our case, sheets that you want to print. Right now, as long as this isn't checked, uncheck that. Hide unchecked views or sheets. Well, if you hide unchecked views or sheets, you can't check any, so uncheck that. Here's all the views, and then eventually we get down to sheets. Here's our sheets. We want to create finished sheets, so we don't need views. And you can uncheck the views from here. So all you see is the sheets, and that makes it a little bit easier. So narrow it down to sheets. And in this case, all of our sheets are ready for printing. Sometimes you'll have sheets set up that are not ready yet, and so you would not check those. So we want to check all of these. And then we can save this as a set name so that we can print these again. So up here, right here, we can save it as and give it a name. And I'll just call this electrical set. And so that saves this selection of sheets as a print set name that you can refer to again. So you don't have to check these again next time. And now that we have those picked, we can say select that. And do we want to save those for use in a future Revit session? Yes, we already did that. Called electrical set. And then up here, it defaults to create separate files. You can create separate PDFs for each sheet if you want, but I typically like to combine them into one set. So I'll hit combine. And then the settings for the sheet size, we can close this now and look, and the name of this was E1 30 by 42. So there's the size. Now sometimes it won't say that in your title block, so you may have to measure it. And you can just measure it with these tools here, and you'll see here that that's 3'6". So back to the print, and then we want to set up our sheet size for that 30 by 42. So we do not have any named print setups, so we'll have to create it from scratch. Pop in here, you see there's a lot of different sizes. We want to go down to the ANSI E1, which is 30 by 42. And then center is fine. Now, how do we want it to zoom? If you fit to page, it will typically add margins around your sheet. We don't want that. We want it zoomed at exactly 100%. And then we want to, down here is where we can hide these unreferenced view tags, which are those section views. Hide scope boxes, hide crop boundaries, and that's what we need to set for that. The rest of these defaults are fine. Vector, processing, high quality, and we just keep it in color. And then save this setup as something we can come back to. So I like to give it a PDF and then a size, PDF 30 by 42. And now we can save this. And you would do this in your project template so you have these available in multiple sizes. Say OK to that. And everything is set up. So now we can say OK, and it will ask you where do you want to save it. And then you'll have a PDF document that we can look at. And then open up the PDF and take a look and see how it printed. It looks like it went clear out to the edges. It printed well. And it has nice curved vector processing. It's not pixelated, so it does a nice print job even if you zoom in. So everything looks good there. And it got all of our sheets. Go through the whole set. Now you have your PDF set printed with the printer function. Now, the other way you can do this is, instead of printing it, there's a button here now called Create PDF. It's also under File, Export PDF. And it's similar to the print window, where you can select what do you want to print. So you can go, and it remembers your electrical set that you just created in your print settings. So fortunately, they use the same settings. And then here is where we can combine the views into a single PDF. And you can give it a name. And then it will automatically use your sheet size. And then we can hide unreferenced view tags and hide all that and say export. You want to save them. And we can call this PDF 30 by 42. That's the part that didn't save. And in the background, down at the bottom, you can see it's printing. And there it's done. So that concludes this 10-episode full project series. And I sure hope you learned something in this. I will be doing more projects in the future that get a little more complicated. We'll do a full commercial project and things like that, along with continued individual little videos about how to do certain things. So thank you for sticking through to the end. And thank you if you've subscribed. I really appreciate that. And until next time.